Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat dua program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat dua program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. satu laboratorium pendidikan, yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi Kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi Kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia, serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia, merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan, yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi Kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi Kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia, serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia, merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia, serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia, merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat dua program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia, serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia, merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi Kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi Kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia. Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia, serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia, merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi Kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi Kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia.
Learning process of bachelor degree. In the pandemic, learning is generally carried out by Zoom. Even though it is online, various learning methods in delivering courses can still be done, such as providing one-way material, discussions, group discussions, and doing practice questions. Delivery of lecture material is carried out using either a PowerPoint.
Ya, gitu ya. Jadi kalau kita makan lemak ya, misalkan gajih gitu ya.
Muncul persatuan volume dikalikan dengan
explaining from textbook sources.
Konsentrasi A dikali HR-nya, tetapi ini berbeda karena ada yang mengurangi sejumlah HR absorpsi tadi ya.
As well as adding other sources that can enrich the subject. For example, in the subject of atomic and molecular structure, students are shown the website chemtube.com, which visualize several types of molecular orbital to make students become more aware of symmetry that are difficult to imagine. In the subject Modern Physics, the lecturer also introduced students to use EduGame in gamelab.mid.edu to help students understand about the relativity concept.
Nah, warnanya kalau kita perhatikan itu kayak ke arah biru.
The subject structures, properties, and reactivity of inorganic compounds. Lecturer asks students to make the molecule model using plasticine when explained about the molecule symmetry concept. Lecturer also developed the web from the medium to deliver the subject content as performed in the subject chemometric. Some subjects also add the external exposure to introduce students the subject application. For example, in the subject marine chemistry, students go to the sea to see various marine species. Then they discuss the relation to the subject. This activity was done in 2019 before COVID pandemic. In the pandemic, the external exposure is replaced by the virtual external exposure. In the subject chemistry membrane, the lecturer invites the industry practitioner to sharing about the problem of membrane application in industry, and the students are invited to discuss the solution. In the subject research methodology, students are required to be more active in exploring chemistry literatures and writing it down in the form of manuscripts, oral presentation, and posters. Guidance on how to search literatures is done in practice, directly by showing several websites related to searches on chemistry. For subjects that require students to have the ability to calculate, exercises are carried out and discussed carefully. Implementation of assessments are carried out in various ways, such as conducting tests via My ITS Classroom and supervision using Zoom, or giving other tasks that can increase learning outcomes in the form of skills. For example, subjects biochemistry and foodstuff chemistry have assignments that are required to be submitted through the TikTok app. Subject chemical literature gives out assignments of video presentation, example, video, and poster. During this pandemic period, practicum is carried out either with demonstration in the laboratory with the help of lab assistants, or some practicum are developed with an online module. The following is a video footage of the Chemistry 2 Basic Technique Laboratory. Measurement of density.
Dengan ukuran densitas dan pada dasar cair.
Solution.
Mari kita lakukan percobaan 3.
Thermodynamics. Calorimeter bomb. Binary solution. Freezing point.
Kita akan melakukan praktikum termodinamika yang dibuat pasang waktu dalam dengan menggunakan metode
Chemical dynamics. H2O2 decomposition. Acetone iodoform reaction. And synthesis organic reaction practicum. Styrene polymerization.
In year 1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Masmurni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Masmurni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Masmurni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Welcome to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50%, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. And discussion space at the corridor. The chemistry office for administration is placed on the second floor. There is a waiting room, office area, discussion room for lecturer, lecturer rooms, and prayer room. There is also a small library on the fourth floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory, Material Chemistry and Energy Laboratory. the Natural Product and Chemical Synthesis Laboratory. The Molecular Geochemistry Laboratory.
Do you ever wonder what makes a life-changing history? Right, a solid mission of the visionaries. It was Dr. Anka and his colleagues' mission to accelerate technology development. Through the establishment of Institute Technology 10 November, their goodwill has encouraged ITS students to take important roles in both local and global communities, ministers, CEOs, professors, entrepreneurs, and yes, another history maker. These successful alumni were trained in a healthy learning environment that was equipped with various supporting facilities. From vocation to marine technology, all faculties and departments of ITS were formed to be the best place to learn science, technology, and design. 7 faculties and 1 interdisciplinary school. Scientix, Faculty of Science and Data Analytics. MarTech, Faculty of Marine Technology. INSYS, Faculty of Industrial Technology and Systems Engineering. Electex, Faculty of Intelligent Electrical and Informatics Technology. CivPlan, Faculty of Civil, Planning, and Geoengineering. CreaBiz, Faculty of Creative Design and Digital Business. Vocation, Faculty of Vocational. And Interdisciplinary School of Management and Technology. Recognized as one of the top best-ranked institutes doesn't mean the finish line for ITS. To gain greater international recognition, ITS launched International Undergraduate Program. Students can get wider international exposure through 20 study programs they can apply. the chances are also open for professors from all over the world to teach and conduct research at ITS. These opportunities have made international joint research and other international activities successfully performed. Like IUP, students and lecturers from other programs have also contributed to the ITS achievements. Numerous appreciations earned exemplify Institute's excellent performance. But technology and academic excellence is not the only goal of the Institute. Students are guided to apply their knowledge for the welfare of society. Because to note a new life-changing history, technology must advance humanity. ITS, Institute Technology, 10 November.
Surabaya, the provincial capital of East Java, is the second largest city in Indonesia. This city has a huge number of diversities among the people, cultures, and ways of living. Surabaya has been acknowledged for its green public open spaces. It also has successfully equalized the development between build-up area and green area that makes Surabaya a livable city for all.
I see Surabaya as a great city with amazing people.
Living pace here is quite slow, so you don't feel the rush of living in the city.
It's also a good place to travel around. I mean, in bus you can go in many places, or taking train on Java.
It makes me also to be in peace, so I think that is a good place for me to stay.
Surabaya is also known as the City of Heroes because of its role in Indonesian struggle for independence. Moreover, Surabaya nowadays has already become the center of businesses, commerce, industries, and education in Indonesia. One of the pioneers of education in Surabaya is the Institute Technology 10 November, better known as ITS. ITS has 3 campuses in Surabaya. ITS Sukolilo as main campus. ITS Manyar its campus vocational study of civil infrastructure engineering. ITS Jokro Aminoto's campus for Master of Management Technology. Occupying a large area of 180 hectares as its main campus, ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, 10 faculties, and 38 departments. ITS has various fields of study, faculties, and strategic study program which are the center of excellence. Faculty of Industrial Technology, Faculty of Marine Technology, Faculty of Electrical Technology, Faculty of Civil, Environmental, and Geoengineering, Faculty of Business and Management Technology, Faculty of Architecture, Design and Planning, Faculty of Information and Communication Technology, Faculty Mathematics, Computing and Data Science, Faculty of Natural Science, Faculty of Vocational Studies. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS also has more than 130 full-time international students and 400 international student mobility short program, K&B program, student exchange, and another programs.
I work with many projects and many assignments, so it's helped me to improve my personal skill and also for communication skill.
There are many things that we have to fulfill, and ITS has been helping me to improve this kind of things. Besides my hard skill, I also have been able to develop my soft skill, which is important for nowadays leadership.
Also with ITS, I had a lot of opportunities to join different events for free, like the Rujak Connect Festival, which was the cooking event, something. Yeah, this is like kind of opportunities that you don't have every day, and it's funny to take part for once. Yeah, it's nice.
ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS. ITS Central Library is in a 6-story building, with total building area 9,000 meters square. This library, more than 121,000 printed textbooks, more than 10,000 e-books, 10,000 audio-visual data, and 18,000 digital library collections. Besides providing students with the books, the library also provides students with comfort study area, like discussion area, hotspot cafe, computer rent, multi-purposes room, and Indonesia Development Information Services, which connect to the World Bank database. research and innovation at ITS are geared towards addressing global challenges. Therefore, creative inventions are increasingly being produced by ITS researchers.
If people are talking about logistics and supply chain in Indonesia, we publish papers, we are doing research on transportation modeling, we are doing research on warehouse modeling, and we also do a lot of networking with industries, with companies, and our research has been used in many companies in Indonesia.
We know that Indonesia is the second biggest biodiversity in the world after Brazil, but I think if we combine with our sea area, Indonesia will be the biggest biodiversity in the world. And we do believe that if we perform science of nature and how to utilize it, it is very big opportunity for the treatment of some disease, not only for Indonesian people, but also for the world.
Considering the fact that Indonesia has unique climate characteristics, and also Indonesia is also very well known as the laboratory of disaster, therefore a lot of issues, a lot of problems have to be solved. But this is a challenge for us. We cannot work alone, we need to work interdisciplinary, which involve expert, local or internationally. Therefore, we invite all of you to work here with us in ITS. We expect that our contribution and our work will bring ITS as the Center for Excellence in Disaster in Indonesia.
ITS has more than 180 laboratories spread over 10 faculties. The laboratory is used to support faculty and students' research and provides the opportunity to collaborate on big projects and create impactful research programs.
So, as the institution, I think ITS has contributed a lot in terms of giving an ideas and spirit, and at the same time self-confidence to our country about how capable we are.
ITS, within the next 5 years, it would be a research and innovative university. It means that ITS will be playing a big role in the region, especially in Asia. For the next long term, in 2045, ITS would be an entrepreneurial university, means that it having a big role playing in the global world.
Okay, so for today seminar, I would like to invite our MC, but before that, I wish you guys enjoyed our seminar and have a fruitful discussion. So my message is there is no stupid question. So just ask anything. Just ask anything you are curious about. Because our target is to learn something new, to make more contribution toward the SDGs. So for today's MC, I would like to invite Dr. Zeni Rahmawati. She will guide us for the first half of the day up to the lunch. And today we have also some notorious speakers. We have Professor Agus as the Senate Academic Leader of ITS. He is also the ex-rector of the Umrah. Umrah stands for what, Professor Agus? Universitas? Maritim. Okay, Maritim something. Okay, so please welcome Dr. Zeni Rahmawati.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome back to the 5th Isoc, the International Seminar on Chemistry. I hope you had a very nice evening and also very good sleep, so we can attend these events today in a refreshed mood and join the interesting discussions. Before I start these sessions, I would like to introduce myself. My name is Zeni Rahmawati and I am from Chemistry Department, Institut Teknologi 10 November, Surabaya. Okay, I would like to describe the events for today. The first is the keynote speaker, the talk by keynote speaker, Professor Shafir Akhlus, and then followed by our invited speaker, Dr. Sorry, I forgot the name. Dr. Juhana Jafar from University Technology Malaysia. Oh, sorry, yeah, my bad. I deeply apologize for that. Okay, so our second keynote speaker, Dr. Juhana Jafar from University Technology Malaysia. And then there will be a guest speaker from Mexican Petroleum Institute, Dr. Heriberto Diaz, and also Dr. Femi Oloy from University of Saskatchewan, Canada. And there will be a lot of sessions for today. Some of our speakers are already here, and there will be also invited speaker Dr. Wanur Hayati and Dr. Kojo Seksi Aqua. I don't know if it's the correct pronunciation. I'm so sorry if I pronounce it incorrectly. And then the last keynote speaker will be Professor Adi Setio Purnomo. And in the end of our event today, there will be awarding ceremony, so please stay tuned until the end. Okay, let's move on to the first session today. This session is the talk by our honorable keynote speaker, Professor Shafir Akhlus, and this discussion will be directed by our moderator, Dr. Yuli Kusumawati. So please welcome Dr. Yuli Kusumawati. Okay, thank you, Dr. Zeni. Okay, ladies and gentlemen, my name is Yuli Kusumawati, and I am a lecturer at Chemistry Department at ITS. So I will be serving as your moderator today for the session presentation with Professor Shafir Akhlus. Okay, we will be hearing his presentation, but before we get started, I want to take a few minutes of your time to reveal his curriculum vitae. Okay, here we have his CV. So you can see now he's a lecturer at Chemistry Department also as a chief of academic senate, senate academic, okay, in ITS. Before he was a rector at Umrah University Maritime. Sorry. Okay. Without further ado, I would like to welcome Professor Safri Aklus to deliver his presentation. Okay, please, Professor Safri Aklus. The space is yours.
Assalamualaikum. Cek ya. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself first. I'm Aklus. You can call me Aklus. Aklus is from Aklus Nawal but just Aklus you can become. I'm from now Department of Chemistry ITS, and in this occasion I would like to deliver some note because firstly I would like to apologize because I don't write any paper for you due to the my activities, that's why I have a limited time to prepare paper, but I try to deliver the idea and a little bit some resume of works that I had been done. Well, I saw at the screen, I choose the title Solar Cell from silicon to perovskites. I am a professor for photochemistry, that's why I choose this title. But the most important is from this title, I would like to ask me and ask all of the audience the one very important question. What is our contribution for our next generation? That's a very important one. And I try to describe what kind of contribution can we give to our next generation by this presentation. Next slide, please. Now, next slide.
Depan belakang ada Pak.
Well, when we search to the certain numbers of the information that we can conclude that the human impactance problems for next 30 years, which means that 2050, is there's a third problem. And don't forget that in 2020 we have only, let's say, 7.8 billion people in the world. But in 2050, maybe we have around 20 billion people, or at least we have 10 billion people for all of the world. And for, let's say, 12 or 10 billion people, they have this problem, the third problem. And the first one is very important one is the energy. Now we are already touched by the energy crisis, and as a scientist, we must take care about the problem. That's why I ask me and you to think about this first problem. And the second generation, you can, this one and second generation. And the third generation, there is a very, very basic difference between the first and second generation with the third generation. In the one and the second generation, our cell is based on the inorganic compound. But at the third generation, we start use the organic compound to excitate our electron. This is the simple principles of the disolar cells. We have the light here, and then light can excitate the electron from DD plus to D star, and then the electrons go to semiconductor CiO2, and then the electron move to another electrode, and by electrolyte, the electrons go to the enol of the die, and this is the circulation of electron in the disolar cell. Disolar cells is the discovery and developed by Professor Gratzel, Michael Gratzel. Yeah, this one, not this one. This is the Professor Gratzel. I met him at San Galen at 2007, and we have very fruitful discussions at the time how to develop the system of the dye-sensitive solar cell, the SSC. Well, the simple principle of the SSC is like this is the light comes through the glass in the system, and then this is the dye, and the dye absorbs the light and excited the electron from the ground state to excited state. Before the electron goes to the ground state, they pass by the CiO2, and then the electrons move to counter electrode, and then the electrons go back to the dye by electrolyte system. This is the principle, the simple principle of the disolar cells. Until now, we develop several kinds of the disolar cell. And the other, the SSJ is the same. I'm sorry. The same principle, but the difference is when the electrons goes to the ground state of the dye, they give, we call it the hopping. It means that they hop step per step in the electrolyte. And this electrolyte we use not the liquid electrolyte, but the solid liquid. Okay. And when we look to the development of dye-sensitive solar cell, this is the years 2018. We have reached up to only 12%. That's also the other challenge for us, how to increase the efficiency of the DSG. And now we call it perovskite solar cells. The principle of the perovskite solar cell is a little bit more, how we call it, combination between the DSSG and the traditional one. It means that we have light, and light, the energy of light can excitate the electrons in the, how we call, planar heterojunction, but the hole in the planar heterojunction also move to the second parts of the perovskite, yeah, and goes to the third part, and this is the different level of energy, and this it means that the circulation of electron. Well, now the question is how we can increase all of the system, all of the technology in order to increasing the efficiencies of the energy from light to energy, electrical energy. That's one of the questions that we must answer about it, okay? And this is, I give you the last data of the annual PV production, include the first, second, and third generation, include the perovskite, but perovskite is very, very small amount to the how we call the installation of the PV, and this is when the 2018, we have the year 2018. The bigger one is the China, and followed by Taiwan, Europe, and Malaysia is a very good, how we call the infestation in that area, and after Malaysia is United States, and this is the rest of the world. I don't know Indonesia maybe the top one, a little bit. Yeah. Well, this is that I can deliver for today, and I hope that we can answer our question together, how and what kind of the contribution can we give to our next generation through our group of research. It means that in each system we can produce maybe 10 or 100 or maybe 200 Q1 publications, yeah. But I think that now, yes, we need the Q1 publication for our works, but the most important one is let's start to think about our migrations by our research. What kind of research that you develop now? Thank you very much, and welcome to explore the renewable, clean, and free energy. And hopefully that we have a little bit share to our next question. Thank you very much. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you. This is very valuable talk. Yeah, talking about conversion solar to electricity. Okay, maybe will be a interesting topic to discuss. So I will invite participant here to ask the question, please, or maybe participant in Zoom meeting. I hope there is no trouble. Maybe I don't know. The participant in Zoom, it's okay. Can hear me? Okay. Maybe if you want to ask the question, you can raise your hand here or in Zoom. Yeah, it's the same. Okay, please. Okay. Can you come here? Please state your name and where are you come from.
All right, thank you for the chance, Dr. Yuli. I would, please let me introduce myself. My name is Arif from Chemistry ITS. I would like to ask about the silicon-based material. I think silicon is an old but not absolute materials, I think. So I would like to ask about the silicon-based materials. So far, I knew about the microchips material. That what is that mean? In Germany, there is an industry. If I'm not mistaken, the name is Infineon. That developed the silicon-based material for microchips. So, how can that be possible to use silicon for commercialize these microchips? So it is very interesting because the silicon that we know, it is an old materials. So what kind of silicon that used for what kind of part in silicon that used for microchips? What is the important thing in silicon that for microchips? Thank you. That's all.
Okay, please. Don't worry, I will give the microphone.
Yeah. Okay. Thank you, but yeah, you're right. That's one of the problems where the utilization of the silicon is also they use silicon for the microchip. That's right. Yeah, and now the worldwide or consume I don't know in the numbers, but the huge silicon for our development of the hardware, okay? And that's why the PV or solar cells, we don't use the prime quality of the silicon, okay? And that we don't use the prime quality of silicon, and it means that we limited source of the silicon for the PV. Okay, but you're right. You're right that the good quality of the silicon goes to the microchips now. Yeah.
The next one is. So it is the similar thing that we use silicon in solar cell for microchip. Oh, not from silicon. All right. Thank you. I got the answer, I think. Thank you.
Okay, thank you. There is another question, maybe in the Zoom meeting. There is someone raise hand, no? Or here? Okay, please come here. It's work.
Okay, thank you very much, Prof. Ahlus, for the next talk.
So actually my field is not about the perovskite solar cell, but when I was in Kyoto University, I almost got this project. So the problem is when we develop the perovskite solar cell is about the, how to say, reproducibility for the component scale, and then for the characterization is like quite expensive. It needs like sophisticated device, I think. So if we talk in Indonesia, like, is it possible to develop such kind of the perovskite solar cell? Then we can make it for our country, something like that. Thank you very much.
Yes, yes, yes. We can make in the laboratory, but it's very difficult to mass product in the industry. Yeah, I do agree about it. I do agree about it. But from this talk, I would like to invite you to take a more attention or give the more attention to development of the PV, including the perovskite PVC, because one of the most problem when we produce the PV perovskites is the waters and the vapor of the waters is a very important parameter that we must look at the presence of the water. Yeah, it means that I think that we can invite the other researchers, maybe have the technology how to reject the vapor, something like water, since we produce the perovskite PV. That's one, this is one of the questions. It means that, yes, when we make the PV in the laboratory, we have very good milieu condition or environment to produce. But when we go to the industry, that's another question. Yeah. Okay, I agree with you.
Thank you very much. Yeah, actually, like even in Japan, the one that only have the device only in Kyoto University. So I'm thinking, actually, I'm interested in this field, but like, no, I'm thinking like, in which part we can contribute to for the development of the solar cell in Indonesia, something like that. Maybe we can make some collaboration with.
Hopefully, yes.
Thank you very much.
We still have about 3 minutes. If there is a last question, maybe. No one in Zoom raise hand? No? Okay. I'm waiting. No? Oh.
You're a photovoltaic, you must be a chemist, yeah?
I will ask the last question. So, what do you think the bottleneck that we see the efficiency of the solar cell is very limited? It's not.
Yes. Since beginning, it's a very good. That's a very important question, and I asked also to Professor Gratzel about that problem, and
I never got more than 15%.
Yes, that's the problem. Maybe that we must think about we choose another possibility or another kind of I don't know. Maybe we develop the hopping system, because we not yet too much publication about the hopping system in the DSSC. Maybe that's one of the solutions to how to increase the efficiency. Yeah, you're right. I also have only 13 and 15. Yeah, and 15 that's in the lab scale. Yes. Okay, and it is impossible to have the same efficiency when we produce in the industrial scale. We can count about -2 or 3% from the laboratory scale. Yeah.
Okay, thank you. I think we have already in this end of the session. By the time it's already 45 minutes. Okay, so thank you very much, Professor Safri Akus, to give us the very important. But wait, wait a minute. We have something for you. No, this is not about the solar. Okay, Mr. Freddy Kurniawan, please come to give the. Yes, okay. So this is a certificate for you. Okay, thank you. Okay, thank you for. Okay, thank you again for Professor Safri Akus. So I will give this place to the MC, Dr. Jenny.
Thank you very much, Professor Akhlus and Dr. Yuli, for a very great talk and interesting discussion. So please, we can give applause again for them. Yeah. So the next session is the second speech by our keynote speaker, Associate Professor Dr. Johanna Jafar from University Technology Malaysia. This talk will be directed by our Secretary of Department, Dr. Yatim Lailun Nikmah. Before we begin this session, I would like to announce that the coffee break is ready on that corner, so please help yourself so that we can attend this talk by having a morning tea. Yeah? Okay, please, ladies and gentlemen, please welcome Dr. Yatim Lailun Nikmah.
Thank you very much, Dr. Zeni. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, I would like to say welcome to Associate Professor Dr. Johanna Jafar. And then I would like to introduce myself. My name is Yatim Lailun Nikmah, and then you can call me Nikmah. I will be serving as your moderator today. We will be hearing a presentation from Associate Professor Dr. Johanna Jafar on his maritime subject. But before we get started, I want to take a few minutes on your time to deliver her curriculum vitae. Associate Professor Dr. Johanna Jafar, her affiliation is from School of Chemical and Energy Engineering, University Technology Malaysia, and her expertise is. There are a lot of expertise, proton exchange membrane, and then direct methanol fuel cell, and then microbial fuel cell, polymer inorganic membrane, and nanocomposite. And her recent publication is thermally stable nanoclay and functionalized graphene oxide integrated SPEEK nanocomposite membrane for DMFC application. Before the presentation begins, let me tell you how this seminar will run. First, Associate Professor Dr. Johanna Jafar will deliver her presentation around 30 minutes, and then after that, we will have discussion around 10 or 15 minutes. And then after that, we will be have conclusion. Without further ado, I would like to welcome Associate Professor Dr. Johanna Jafar to deliver her presentation. So, please, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone.
So first of all, let me introduce again myself. My name is Johanna binti Jaafar. So I'm from Advanced Membrane Technology Research Center, AMTEC, University Technology Malaysia, Skudai. Okay, so today, thank you very much to Ms. Chairperson for a very nice introduction about myself. Thank you so much. So today I will talk about alternative polymer electrolyte membranes for fuel cell applications. Okay, so this is the presentation outline. So I cover a bit about the global energy issue, about fuel cell technology, the current development and commercialization of fuel cell, and some conclusion. So actually it's about the same, yeah, with the Prof invited speaker plenary speaker just now. I'm talking about energy as well. So this slide shows the growth in energy demand around the world. Yeah, so as you can see, we can conclude that most of the country around the world has increase in energy demand in terms of the patterns. Yeah, but only Europe and Japan has decreased pattern in energy demand because they already phased out the how can I say, the petroleum-based energy source. Yeah. So demand always versus the production. So this is the global energy production. Yeah. So you can see a measure of the energy production still comes from the petroleum-based or carbon-based energy fuels like natural gas, coal, oil. So this contribute to 62% that comes from the non-renewable energy. Unfortunately, this contribute to the carbon footprint. Yeah, it has been reported that the carbon footprint has increased 7 times, yeah, from 1890 to 2014, yeah, due to the usage of the carbon-based fuel to produce the energy. So worsening scenario is that it affects the environmental, our environmental, yeah, by using these petroleum-based energy sources like global warming, air pollution, water pollution, acid rain, and etc. Okay, so all over the world has come with these initiatives. At world or global level, we have the Sustainable Development Goals, SDG. Okay, so for today's topic, it will contribute, or the direction is more to SDG 7, yeah? Energy, affordable and renewable energy, I believe, yeah? So at Asia level, we have Clean Energy Program. And then Southeast Asia, we have ASEAN Plan of Action for Energy Cooperation. And since then, I come from Malaysia, so I would like to highlight we also have the initiative, okay, Malaysia Renewable Energy Roadmap. So all in all, these initiatives is moving towards having the decarbonization or to reduce the carbon footprint effect. So one of the approach that we can do in order to support the initiatives is by having or by using the renewable energy. So we have numbers of renewable energy available, okay, such as solar, wind, tidal, and geothermal. But there are some drawbacks because this renewable energy is an intermittent energy. Yeah. So such as for solar, it needs clear weather. Wind, it needs area with lots of wind. Tidal, it needs high tide and low tide, and geothermal needs high magma activity. So even though I can say that these renewables energy, all renewables energy are conventional, even though not many countries has yet implement this renewable energy. Okay, but as compared to, you can see here, okay, fuel cells. Okay, fuel cells. As compared to these all renewable energy, it can be said as the future energy. Okay. So what is fuel cells? So fuel cell is electrochemical reaction that directly convert energy from fuel to electrical energy. Okay. So this schematic diagram shows the operation principles of fuel cells. Okay. It starts, actually we have 3 main components in fuel cells: anode, cathode, okay, and membrane. Okay, so in this slide, I showed the proton exchange membrane fuel cells. We have numbers of fuel cells actually, but I use a proton exchange membrane fuel cells as the example. So the membrane, okay, the membrane should be proton exchange membrane. So it starts with the feeding the hydrogen. So in PMFC, we use hydrogen as the fuel. So feed in the hydrogen at the anode side. So at the anode side, we have the catalyst that separate the fuels, the hydrogen, into protons and electrons. So protons will pass through the membrane, okay, and the electrons will pass through the external circuit, okay, to produce the electricity. At the cathode, the protons, electrons, and oxygen, another reactants, okay, will combine to produce the air and water vapor. So you can see fuel cells, the output or the byproduct of fuel cells is only water. Okay. Okay, so let's see how fuel cells versus the combustion engine. Okay, so for combustion engine, we have 4 steps at least to produce the electricity. So during this journey, okay, it will release the CO2 and lost the efficiency, lost the energy. Okay, as compared to fuel cell, as I mentioned just now, it isn't directly convert the electrochemical reaction of the fuel to the electricity. So just one step of operation to produce the electricity. So the loss of energy, the loss of CO2, the loss of energy is reduced, the loss of CO2 is reduced as well. That's why it will tremendously contribute to the CO2 release. So this is one of the effort to decarbonize the environment. So as I mentioned just now, we have many types of fuel cells that differ based on the operating temperature. Okay, we have low temperature, intermediate temperature, and high temperature. So among these 3 temperatures range, okay, low temperature of course is preferable, yeah, because of course we want to reduce the energy consumption, yeah. So under the low temperature type of fuel cells, we have proton exchange membrane fuel cell, PEMFC, direct methanol fuel cells, DMFC, and microbial fuel cell, MFC. Among these 3 low temperature fuel cells, proton exchange membrane fuel cells and direct methanol fuel cells are more favorable as compared to microbial fuel cell, because microbial fuel cells contribute very low energy in terms of the power density. Okay, so these are the fuel cells applications. We can use it as the fuel cell bus, yeah, fuel cell forklift, UAV, home for home appliances, yeah, telecommunication tower, and so on. Okay, so this is the general features of fuel cells. So it is high in efficiency, 80% as compared to the combustion cell, because why? Like I showed just now, we have 4 steps for combustion, but for fuel cell we have only 1 step to produce the electricity, so the losses of energy reduced, so we can have the higher efficiency as compared to the combustion engine. And then good reliability, environmental beneficial, it greatly reduces CO2 and harmful pollutant emissions, size reduction, and noise, because there is no mechanical parts involved in operation of fuel cell. A part of the benefits, many advantages of fuel cell, this is one of the remaining issue, yeah? High cost. Okay, generally, we have these general causes that contribute to the high cost of fuel cell. One, expensive, yeah, to manufacture due to the high cost of catalyst, because we use platinum, and then lack of infrastructure to support the distribution of hydrogen. Okay, very lack of these facilities like a pump station for hydrogen. Okay, a lot of the currently available fuel cell technology is in the prototype stage still, okay, and not yet validated. So in terms of if we going to have the mass production, of course we can reduce much on the cost of the fuel cell itself, and then hydrogen is expensive to produce and not widely available. Okay, but then when we look into the cost breakdown by components of the fuel cell, like I said just now, we have the main components in fuel cell: membrane, anode and cathode. So membrane electrode assembly represent the membrane, anode and cathode. The electrode the electrode represent the anode and cathode. Okay, and we also have the supporting components like bipolar plates, yeah, gasket and gas diffusion layer. Okay, so the MEA itself, okay, contribute a lot in terms of the cost for the fuel cell. So the membrane and the electrodes. So there's more room for improvement in the MEA, in the membrane and electrodes, but today I would like to focus on the membrane only. Yeah. Okay, so we have two types of membrane for fuel cell: anion exchange membrane and proton exchange membrane. So by its name, yeah, we have the anion exchange membrane. The anion represent the counter ion. Okay, the counter ion that must or should pass through the membrane. Okay, so what is the anion that must pass through the membrane is the OH negative. Okay, so to attract the OH conductive, so the membrane of anion exchange membrane should have the ion exchange group that positively charged. Okay, so vice versa for the cation exchange membrane. So the cation representative the protons that must pass through the membrane. In order to make the protons to pass through the membrane, so the membrane should have the ion exchange that negatively charged, like sulfonic acid group. Okay, but between AEM and PEM is more favorable because it has high ion conductivity. So I'll focus on the PEM today. Okay, so what is the state-of-the-art membranes for proton exchange membrane fuel cells? Okay, up till now, Nafion by DuPont is still dominate the PMFC market. Yeah, so Nafion actually you can see in this chemical structure of Nafion, it has the PTFE backbone with the perfluorinated side chains containing the sulfonic acid and groups. Okay, so these are the properties of the Nafion. It has high hydrophobicity, high proton conductivity, durability, and so on. Okay, so I just would like to highlight that there's many Nafion grades that have been produced by DuPont. Okay, that differ in terms of the thickness, hydration, and permeation properties. Okay, so like here, I just highlight 4 of the membranes from DuPont. Nafion 112, yeah, Nafion 117, NR212, NR211. Actually, they have more. Yeah, it's just that I would like to highlight here for those who work with a proton exchange membrane. Let's say you contribute or you would like to come up with new polymer electrolyte membrane or proton exchange membrane. Actually, polymer electrolyte membrane, the terms polymer electrolyte membranes and proton exchange membrane can be used either. Okay, so if you want to contribute in terms of the membrane in PEMFC, so to do comparison study, you have to use Nafion 112. Okay, because the DuPont company has produced this Nafion as a standard membrane, yeah, for PEMFC in order to minimize the ohmic losses. Okay, the ohmic losses meaning that the internal resistance of the membrane. Okay, but if you're working with direct methanol fuel cell, for example, okay, so Nafion 117 is better. Okay, because Nafion 117 is the, how can I say, the standard membrane that have been produced for the MFC in order to reduce the methanol crossover through the membrane. Okay, so these are based on what I've shown just now is all the benefits that a Nafion have, but unfortunately it suffers of these major problems like high cost material, proton conductivity decreased at low humidity, meaning that it only performs at high humidity like RH maybe up to 100%, yeah, but when the humidity reduces, yeah, this proton conductivity will deteriorate, yeah? And then relatively poor swelling stability and degradation problem. So that's why many researchers has come up with the alternative polymer electrolyte membrane. Okay, so in this table, we tabulate the strategy, okay, the specific membranes under the strategy, and then the outcome or the output from this membrane in terms of the proton conductivity at humid and hydrous conditions. Okay, between this output and hydrous conditions is appreciable actually, yeah, because meaning that at very low RH, low humidity, it still can withstand or sustain its proton conductivity, yeah. Okay, so one of the characteristics that a PEM or polymer electrolyte membrane should have is proton conducting features. Yeah. So what is conducting membranes? Yeah, conducting membranes are those membranes which conduct proton due to delocalization of protons. So we have two types of mechanism of proton transport in PEM. Okay, vehicle mechanism under the hydrodynamic diffusion, in which, yeah, so this is the proton, it will combine with the water molecule to produce the ion hydroxonium. So with this ion hydroxonium, it can freely diffuse through the membrane, okay? And then the Grotthus mechanism is the second mechanism of proton transport in PEM, in which it diffuses through the protonic diffusion via proton hopping. The proton itself will hop from one molecule of water to another, okay? And the strength of proton conductivity from membrane functional groups, yeah, can be determined by any functional group with a pi bond that is polarized, that can potentially be a pi acceptor. So these are the, the C double bond O, C double bond N, and also of these functional groups, such as the nitrite, nitro, sulfoxide, sulfonic acid, and phosphoric acid. So you can introduce to the polymer backbone of your membrane, okay? So how we can discuss further? So this is the basic procedure for polymer electrolyte membrane development. Okay, so this is normally what we do in our laboratories, okay? We start with material synthesis. It's up to you if you want to use the commercial materials, yeah? But in our case, we start with the material synthesis itself. So we have, in this case, we use polyether ether ketone, yeah? So as I mentioned just now, in order to improve the proton conductivity of the polymer, for the polymer electrolyte membrane, we have to introduce the functional group. In this case, we introduce sulfonic acid group. In order to do so, okay, so we have this polymer, polyether ether ketone, and then we dissolve it or we mix it with the sulfonating agent. Okay, in this case, we use sulfuric acid. So in sulfonation, we can vary the condition in terms of the type of sulfonating agent, the temperature, and also the reaction time, yeah? And then here, in order to stop the solution, yeah, to dissolve, to precipitate it, we pour it into the ice cube, yeah? So you can see here, okay, we stir and we can get the solid structure of the sulfonated polyether ether ketone, yeah? So then we collect it and dry it, and then here we grind it a bit, resulting of the sulfonated polyether ether ketone polymer. Then we make the membrane. How to make it? How to make the membrane is very simple. Okay, we have the polymer, the sulfonated polyether ether ketone polymer in this. Then this is the solvent, and then we mix them, okay, to make the dope solution. Okay, and then we screen a bit, okay, and then we pour it into the silicone mold to make it into flat sheet type membrane, okay, and then we dry it. So this is the picture of our flat sheet membrane, okay, and based on the SEM images, okay, we get this dense structure flat sheet membrane of sulfonated polyether ketone. Yeah, so this is the thickness of our membrane is about 70 micrometer. So these are the, after we get the membrane, of course, we have to do the characterization. Okay, so basic characterization involves such as the surface morphology or cross-sectional morphology of the membrane using the SAM, or you can also use the FISAM. And then since that we do the sulfonation, okay, sulfonation process. Okay, so that's why we have to determine the degree of sulfonation. So we use HNMR to determine it, and then we characterize it in terms of the thermal stability using the TGA and DSC, and then the most important characteristics is the proton conductivity determination. So we use the EIS and so on, yeah, water uptake and so on. Okay, so once we do the characterization, of course, we want to see what is the performance of the membrane. So before we proceed with the performance testing, we have to build or make membrane electrode assembly. So to do so, we use the hydraulic hot press machine here, okay, to hot press the membrane. Okay, we have the membrane like you see here in the middle and sandwiched by the electrodes. In our case, since that this is for PMFC, proton exchange membrane fuel cells, so the electrodes that we use for anode and cathode both are from platinum. Okay. Okay, so this is the performance testing in which we use this system in order to, to give the VI voltage current polarization curve. So from that VI polarization curve, we can calculate the power density. Okay, so by using the same instrument, we also can get the voltage stability. So in this case, we conduct 5 cycles of voltage stability. So each cycles we conduct it about 8 hours. So we stop, then we purge with nitrogen in order to remove the how can I say, impurities on the membrane surface. So this is a kind of post-treatment. Then we start again in another cycles and continues it for 5 cycles, which compute to 5 days. Yeah. Okay, so I would like also to share our recent study in proton exchange membrane fuel cells. So highly sulfonated polyphenol sulfone nanocomposite membrane for proton exchange membrane fuel cell applications. Yeah. So from this topic, we managed to publish about 4 papers in Q1. Okay. In this study, we use polyphenol sulfone as the polymer base. Okay, so because it has high thermal, mechanical, and chemical stability, and it can easily sulfonate. Yeah, so as I mentioned just now, again, we have to do some modification on the parent polymer in order to improve the conductivity of the polymer. So we introduce the sulfonic acid group, okay, by sulfonation process again, okay, but it is slightly different from what I've shared just now. So normally after sulfonation, we can get normally researchers will choose the water-insoluble sulfonated polymer for PEMFC, okay, in which it shows the degree of sulfonation less than 70%. Okay, because why? It has high mechanical stability, yeah? Dimension stability is very good, so meaning that the membrane is desirable for the fuel cell application, okay? But it has lower proton conductivity. Okay, so actually, in order to improve the proton conductivity is very easy actually. You can improve more functional groups and do some modification on the desirable, how can I say, desirable physical structure of the membrane. But if you have water-soluble a sulfonated polymer in which the structure, the mechanical stability is not up to the desirable properties of the PMFC, then it is very hard to handle actually. So we take this challenge, okay? So for water-soluble sulfonated polymer, we have the degree of sulfonation more than 150%. Okay, so you can imagine, yeah, it will has a very excess swelling membrane, yeah, so very hard to handle. So we take this challenge, we do thermal cross-linking. Okay, we do thermal cross-linking on the sulfonated PPSU. So this is the mechanism of the thermal cross. After the thermal cross-linking, we integrate it. We manage to integrate it through the SO2 here. So we managed to improve the mechanical strength. Okay, but okay, it reduced a bit in terms of the proton conductivity because we have lost a bit of the acid function in the polymer. Okay, so in order to further improve the proton conductivity, we introduce inorganic materials. Okay, so we have many types of inorganic materials that can be incorporated into the polymer backbone of PMFC, of PEM. Okay, so such as the heteropolyacids, metal oxide, carbonaceous materials, silica, and clay. But we are only focusing on these three types of the inorganic materials. So for carbonaceous material, we introduce carbon nanodots. And then silica, we use this POSS, okay? And then clay, we use immogolite. Okay, this is the step of sulfonation of the PPSU as I mentioned just now, so I won't repeat this. Okay, and then this is the stage to produce the filler. Okay, the filler itself we synthesize ourselves. For the CND, this is the how we prepare it. Yeah. So for the SPOS and also the immogolites. And then, okay, so this is the step where we do the prepare the nanocomposite membrane. We prepare the dope solution consists of the SPPSU in DMSO, okay, plus with each of the fillers that we have synthesized, and then do the thermal cross-linking and then do some post-treatment, then characterization. Okay, so in terms of the results or characterization result for the SPPSU. Okay, so this is in terms of the image whereby you can see the different after the thermal cross-linking at higher temperature. Okay, so this is the HNMR to confirm the attachment of the sulfonic acid group, and we managed to improve the thermal stability of the SPPSU. Okay, but in terms of proton conductivity of the parent SPPSU, it shows lower than Nafion, commercially available Nafion membrane at all costs, at all conditions, at low RH, at high RH, at higher temperature, all SPPSU membrane shows lower performance. Okay. All right. So now we have introduced the CND into the SPPSU. So we have SPPSU CND nanocomposite. Okay. So this is the structure that we obtain from the cross-linking, thermal cross-linking of the CND to the SPPSU. It is in black color. Okay, this slide is just to show or to confirm the addition of the CND is successful into the SPPSU. Okay, so in terms of performance, yeah, so we managed to improve, yeah, greatly the performance of the SPPSU CND as compared to the SPPSU parent, yeah, but still lower proton conductivity as compared to Nafion 112. Okay, and then we continue with SPPSU SPOS. Okay, so this is the silica type of filler, yeah, and surprisingly, we for pause, if I'm not mistaken. Yeah, it shows the highest, yeah, proton conductivity as compared to any other filler that we introduce into the SPPSU. So as you can see here, it reached up to 6.5 for the only 40% of relative humidity. So if you compare with the proton conductivity of Nephion, only 1.7. So we have successfully, significantly improved the proton conductivity of SPPSU as compared to Nephion. And we have the SPPSU immogalite, same procedure to, how can I say, to characterize it, and it shows considerably good proton conductivity, but not as good as the SPPSU SPOS. Okay, so in terms of the performance, this is the order of the performance that we obtain. SPPSU SPOS is number 1, followed by the SPPSU CND, and then Nephion, SPPSU immogalite, and SPPSU parent. So maybe SPPSU immogalite, I would say the lower in terms of the performance is based on the features of the immogalite itself. As you can see here, yeah, it been mentioned here, it has the porous morphology. Yeah, so it is good actually for the inorganic materials to have these features, the porous, so we can accelerate the proton transport through the porous structure. But if the pore size is not that controlled well, okay, in order to only control for protons to pass through, unfortunately hydrogen will pass through it as well, in which we will waste of the fuel to do the electrochemical reaction. Okay, so that's why the performance of the SPPSU with immogalite shows lower as compared to others. Okay. All right, so this is a very small contributions from our research center towards commercialization of PMFC. Okay, so just now I just show about the membrane electrode assembly, in which we have the membrane and also the electrodes, anode and cathode. But now we stacking up all the MEA, okay? So meaning that, for example here, yeah, you have the MEA, then you have to have the plate. Plate is graphite plate. We use graphite plate. We how can I say, we design it based on the properties of our membrane, so very specific for our membrane. So this one single cell, okay, represent this one, okay? So meaning that this one stack have about 10 cells, okay? So this is, sorry, time's up. Okay, so this is our rigs that we have prepared, okay, in order to, how can I say, to see the performance of our stack. Okay, so this is the output of our performance of our stack. Not talking about the membrane itself, so now we are talking about the stack. Yeah. Okay, same goes to here. That's all. I think for conclusion, I would say maybe we can focusing on this one. So we should contribute in terms of the PEM that have the capability to perform at humid. Humid meaning that at high RH, yeah, with low temperature, and anhydrous at low RH and high temperature. Okay, so it's tolerate to these conditions to perform well in the PMFC. And maybe this is a good approach as well in order to align the proton conduction, the proton conductive cluster, so that proton can pass through easily through the membrane without hiccup, so we can further increase the performance of the membrane. So that's all from me. Sorry, take your time. Thank you.
Okay, thank you very much for your nice talk. Sorry, yes.
I'm sorry,
because the
my
time
bad.
is limit, yeah.
Yes.
Okay, now we continue to discuss her nice talk about actually about fuel cell, yeah, about the polymer, the membrane.
Yes,
for fuel cell. Okay, maybe this. Oh, okay. From Zoom, I will give time for the participant in the Zoom first. Okay. Okay. The question is, you cannot show in the, no? Okay. Okay, I will read the question. Is was there any attempt to measure the gas involved during TGA? Was there
gas?
any attempt to measure the gas involved during TGA? TGA, thermographimetry analysis.
Oh, okay. So normally we use TGA in order to determine the degradation temperature of the membrane. So we want to see the stability of our membrane at different temperature in the operating range of temperature of the PMFC. So like I showed just now, we have the operating temperature of the PMFC up to 120 degrees C. So we try to find out or to determine whether our membrane is capable to withstand with this temperature, right? But in terms of the gas evolved, we never try with this TGA approach in order to determine what type of gas evolved during the operation. We just, I think, we just in the membrane level, we do not test any about that. But when we have the stack, we have the gas tight determination. So we actually don't have that. How can I say that instrument? Okay, but we send it to the company that have the standard operation or standard instrument to determine the gas tightness of our stack. Okay, so maybe I can reveal it. The company is TUV Rainland. Okay, so we have the collaboration with this company. Okay, but I don't know, before we come out with the stack, we don't have any information about the company that have this standard, you know, in order to see the performance of the fuel cell. But end up when we start the, how can I say, the project, yeah, to produce the stack, then we managed to find this company. So I think in order to go into to determine in terms of the gas evolve and so forth, we can approach some standard, some company that have this standard instrumentation. Okay. Yes.
Or maybe from the TGA curve, we get the temperature, and then we know we can get like stairs, right?
Yeah.
The degradation.
The degradation, yes.
If we put in the
in the intensity in terms of the weight loss, yes.
Maybe we can compare this weight.
Yes. The weight.
This gas.
Yes, with gas, yeah.
Maybe.
Yes. Yeah. Great idea. Yes. Maybe we didn't explore it yet. Thank you so much. Yes.
Okay, maybe go to the next question. Yes, please, Pak. I think we can go.
Assalamualaikum warahmatullahi wabarakatuh.
Salam.
My name is Bambang Buluharto, come from University of Jember. I would like to ask you about you modify polyelectric membrane by polysulfonic.
Sulfonic, yeah.
By
thermal cross-linking.
Okay. But how impact to ionic conductivity?
Ionic conductivity, yeah.
And with compare with Nevion,
yes, yeah. Okay. Thank you, Prof. Okay, so as I mentioned just now, yes, the cross-linking, the thermal cross-linking really helped to improve the mechanical stability of the polymer base. Okay, the parent polymer. Unfortunately, it's reduced the proton conductivity a bit. Yeah, a little bit. So because we lost the how can I say, the sulfonic acid group a bit, because we have the cross-linking it with another backbone of polymer, right? So yes, I totally agree. We have facing that problem. That's why we introduce another filler to improve the proton conductivity. So as you can see, the after we sulfonate, yes, the proton conductivity drop. But when we add with fillers, okay, we have the CND, we have the SPOS, and we have the Imoglide, the proton conductivity increase. Okay, thank you so much.
Okay, thank you. Any other question from the participants? Yes, Bapak AF.
Thank you. My name is Aypeta from ITB. How do you think about the foresight and also force distribution in your membrane? Is there any impact or effect to the performance of ion passing through membrane?
Thank you, Prof. Yes, definitely we have such problem when we add the inorganic materials into the organic materials. Of course, agglomeration is one of the big problem. Okay, it's just that when we have the thermal cross-linking, this really help us to reduce the effect of separability of the inorganic or the fillers in the polymer backbone. Okay, but when we just do, physical blending, okay, just let's say you have the polymer and then you have the filler, of course you have to have the solvent, and then you blend. Of course, you cannot run with the agglomeration effect. Okay, but normally we use some compatibilizer in order to improve this. Okay, previously we have triaminopyrimidine. Okay, this is one of the good compatibility in order to improve the connection between the filler and the polymer. Yeah, thank you, Prof.
Okay, yeah. Okay, please, you can come here.
Thank you so much for your presentation, Doctor. I'm Alvin from ITS. I would like to ask regarding the proton exchange membrane application in microbial fuel cell system.
Okay.
In my case, the obstacle of this research is the falling in the proton exchange membrane. Instead, the proton conductivity is important. However, the sustainability of the performance of the PEM in the system is also important. In your expertise, what is the best modification to develop proton exchange membrane with anti-fouling properties in the microbial fuel cell system? Thank you.
Thank you, Arvin. Okay, so MFC, the operation or the principal operation of MFC is little bit different from PMFC. Yeah? So because we have the substrate using like organic, how can I say, organic, yeah, like food, yeah, from food as the substrate, yeah, because we, how can I say, we, it relates to the microorganism, right? So in PMFC itself, in the PEM itself, I must say that's not much contribution we can do because in terms of the performance, very low for MFC, but you can look into the electrodes. So try to find the best or to find good carbon-based electrodes in order to further enhance the metabolic reaction of the microbes so that this will reduce the fouling effect. So you play around with the electrodes instead of the membrane.
So if we use a commercial membrane like Nafion is not suitable in microbial fuel cell system?
It is suitable, but in terms of the fouling, you can reduce it by contribute into the electrodes to reduce the fouling. The fouling cannot run. You cannot run with fouling when you just use any type of PM. Okay, and maybe you can look into AEM as well. When we talking about the proton conductive materials, okay, when we're talking about the proton conducting base fuel cells, okay, PEM is good. But for microbial fuel cell, I would say AEM. So AEM, two factors that I will suggest to you. You try with AEM and look into the electrodes. Come up with a good carbon-based electrodes.
Thank you, Doctor.
Thank you.
Little bit different with your talk, yeah, but it's still
I have a slide.
Still your expertise, right?
Yeah, still.
Okay. Any other question from other participants? Yes, please, you can come here.
Assalamualaikum warahmatullahi wabarakatuh.
Assalam.
Really nice presentation from Dr. Johanna.
Thank you.
My name is Dian Permana.
Mm-hmm.
I'm a PhD student of chemistry in ITS. I would like to ask about the synthesis of carbon nanodrops.
Mm-hmm.
Actually, my research talking about using carbon nanodot as a filler.
Mm-hmm.
From your research, I see that the synthesis of carbon nanodot using bottom-up method.
Bottom-up method.
Yeah. In my research, I would like to try using a top-down method. So I try to find a natural source to fabricate carbon nanodot from such as using celluloid waste. I would like to ask, or I would like to know, in your opinion, what is the weakness or advantage using bottom up and top down? Thank you.
Thank you. Wow, very challenging question actually when it comes to the synthesis part. Yeah, so this one, of course we do bottom up. So bottom up as compared to top down, right? So top down, bottom up is how can I say, very easy as compared to top down, yeah, because we just we have, let's say you have the precursor materials, okay, and then you dissolve, okay, you make you mix them and then dissolve in water. So in this approach we do hydrothermal method. So it is very straightforward, and then we when we dissolve it with water, and then we heat it up at certain temperature to get the CND. Okay, so I would say for top down, maybe, well, we choose bottom up because it's simpler. Okay, that's why actually. So I cannot go further because actually we have a collaboration with NIMS from Japan. So they contribute a lot in the synthesis of the CNDs, the immogaline, and also the spores. So that's why I can answer that the bottom up is a simpler method as compared to the top down. Yeah. Okay. Thank you.
Okay, thank you very much. There is still question for participant. I think the time is up. Yeah. Maybe more. Okay. Thank you very much, Dr. Johanna Jafar. Please give big applause for her presentation. I give back to Dr. Zeni. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Oh, okay. Please still, Pak Freddy, please come forward.
Thank you very much for Associate Dr. Professor Dr. Johanna Jafar for a very interesting talk and discussion. So would please give another round of applause. So the next session is the honorable featured speaker, and the speaker will be from very far away. The first speaker is Dr. Heriberto Diaz from Mexican Petroleum Institute, and the second is Dr. Femi Oloye from Saskatchewan University of Canada. Before we begin this session, I would like to check with the operator. Is everything okay? Is Dr. Heriberto with us? Dr. Heriberto, are you on board at the moment? Is everything okay over there?
Recording in progress.
Everything should be okay. Okay. I think I can introduce myself. My name is Heriberto Diaz. I studied in my bachelor and master's of science in Mexico, and then I went abroad for my PhD in Belgium, and later on I pursued postdoc position in Mexican Petroleum Institute and the second postdoc in the Aberdeen University in UK. So now I got a position recently at the Mexican Petroleum Institute, and the research we do is related to oil and gas industry activities, and especially oil refining and hydrocarbon transformation and CO2 transformation. So I'm going to talk to you about my research on CO2. I want to share my screen if you don't mind. Can you see my screen now? Not full. Yeah. Sorry, can you? Yes. Okay. So I think you can see my presentation, right? You can see here. Okay. Well, okay. Okay. Thank you. Thank you. Yeah. So, well, basically, during my stay in the Mexican Petroleum Institute, we have been working in the, well, me and my group have been working in how to, I'm sorry, how to transform, how to efficiently transform CO2 into value-added chemicals. We've been focusing on the cyclic carbonates. So let's just have some introduction first, and let me talk to you about the issue with increase in CO2 concentration during during this amount of during, let's say, beginning of the industrialization and during, well, the 21st century now. I can tell you that some countries like the UK have been working very hard to reduce their CO2 emissions. However, the behavior of the whole world is completely the opposite. So there's still a lot to do in order to make the emissions go lower and reach the target of the IPCC, lowering to 1.5 degrees up to 2030. And well, there's a lot of work to do. So well, basically, as we can see, the energy consumption is in countries like UK, for example, goes to 40% more than the highest energy consumption goes for the oil industry, and just very close to natural gas usage. So we can see that oil and gas industry is one of the most CO2 emitters from the other industrial activities. So so we have a huge challenge to reduce the emissions, and one of the ways to reduce them is create more technologies of carbon capture and storage. But there is also possibility to start with CO2 utilization when I'm sorry. Um, sorry. No. Yeah, as I told you, well, one of the most important processes at the moment is the production of urea, which is uses up to 2016 880 megatons per year as a global production, and for 2030 the projected productions around 2000 to 210 megatons per year. So it means that the use of CO2 will be increasing, and it's increasing every year. One other the other products that can be commercially available from CO2 are still much lower. That their CO2 usage is still much lower than the urea production. So of course the use of CO2 is still very low compared to urea. And uh, no, one other very important is the formation of inorganic carbonates for example, the cement production. Well, the conversion of CO2 into cyclic carbonates, we have working basically by using natural polymers as a catalyst enhancers or boosters. Cyclic carbonates are very important as solvents, electrolyte, or paint strippers. They can be used even in the synthesis of polycarbonates and polyurethanes. And well, one of the important uses, um, our work has been focused to the synthesis of cyclic carbonates by the insertion of CO2 into oxiranes and using natural-based catalyst. So this is one of our first publication in this respect. We uh, we we found out that by combining classical catalysts like Ki, potassium carbonate, um, potassium iodide, I'm sorry, plus an organic base like DBU, it is possible to make a very efficient catalyst which has up to 99% selectivity and plus and even higher than 95 conversion. And the let's say the mechanism of how this works is like basically having the N-acetyl moieties of the N-acetyl glucosamine moieties of the chitin polymer can can interact with the oxirane ring by hydrogen bondings. This allows the attack of the iodide anion in order to open the cycle. In this way, we can also apply an organic base like DBU in order to activate CO2 in one of the regions, or even directly connect by a covalent bond to the electron deficient carbon of the CO2. This way, we can make a direct attack of the alkoxide to the carbonate, and this way we create let's say an intermediate carbonate, organic carbonate, which is then close in the ring to release the cyclic carbonate and to renew the potassium iodide as a main catalyst. So well, this one of the first works I did here, and in the second work we compared the Ki catalyst or K-tin catalyst with a Ki silica alumina catalyst, which is a catalyst that is well composed of a hybrid mixture of inorganic, organic, and inorganic matrix based supported catalyst. So we noticed that the influence of the K-tin polymer is stronger than the one than the effect of the silica alumina, which is only affecting with some in some parts of the catalytic cycle. So as you can see, we could reach almost 100% conversion of the oxirane by applying 160 temperature with and less than 100 minutes, for example. So if you can see the larger catalytic activity of the Ki and K-tin ring, K-tin polymer supported in K-tin. So basically, we noticed that the effect is stronger when an organic support is used instead of an inorganic support. Later on, we worked on how to better how to better fix the catalytic system into two different reactor types. So we used basically a tubular reactor and a Robinson honey reactor, which are of different configuration. So by using the inorganic based catalyst or support Ki supported on the silica alumina, we noticed that the Robinson Mahoney reactor is more efficient in terms of keeping the high selectivities and with a lower loss of conversion. So the yield of this in case of propylene carbonate was more let's say was less pronounced than the loss of yield when used a tubular reactor. In this case, tubular reactor produced much more as byproducts because the hot spots are more pronounced. So the heat that is produced during the exothermic reaction is not controlled, is not efficiently controlled, which is not the case with the Robinson Mahoney reactor, which can react, which can let's say work more efficiently by doing this the turbulence more efficient and making the heat to be more easily released and then temperature control is much better in case of the Robinson Mahoney reactor. So this is another work we did just recently, but finally we noticed that we can create a whole, let's say, microplant which can use a specific reactor configuration with a homogeneous and homogeneous catalyst. And the thing is that we have to work more on the modification of the catalyst in order to keep more sustained conversion and yield of our product. But at least we already have gotten some good interesting results on this. And finally, I want to talk to you about my research on the electrochemical conversion of CO2. This research is still on the pipeline. We still just making some initial tests, but basically we know that by creating electrical current through the electrochemical cell, we can reduce CO2 if you have hydrogen donor. In this case, water splitting can be one. Water can be a good hydrogen donor, which encourages you have oxygen as a byproduct, or in the um, the large trap more CO2 molecules, and way we can get better catalytic activity or
Diaz, excuse
to
me.
the catalytic side.
Excuse
So,
me, Dr. Diaz, can you hear me?
Yes.
Okay, I'm
Are you
so
still on?
I'm so sorry. I actually want to remind you that your time is a bit up. Can you
Oh,
go
sorry.
to the
Okay.
conclusion, please?
Yes, yes, please. Just finally, I just wanted to tell you that in our research we have well you have here two methods of the MOF synthesis. Well, we are using more hydrothermal. I think just to look for you to see some of these pictures of nanoparticles. We still have to make more tests, but initially copper and some copper on copper MOF, like copper BTC, created interesting results on the reduction with low some tests. Well, sorry, final remarks. Just we have several improvements of the catalyst are to be done, but we are still working on that. And well, thanks a lot. Sorry for my overtime. Yeah. I,
Dr. Heriberto Diaz. Can we please give a round of applause for Dr. Diaz? Yeah. Okay, thank you very much for your very interesting talk. So for the audience, is there any questions? Please raise your hand. Or probably I can deliver the questions from the audience in the Zoom. Okay, so the first questions, what is the most influencing factor in CO2 transformation? Oh, okay, so which one first? Okay, this question first and then Wahyu. Is that okay?
okay.
Okay, can you see the chart? Can you read the
Yeah,
question
I can see. I can see it.
Okay.
Yeah, thank you. And
Okay.
let me tell you, the most influencing factor or the main obstacle to overcome is to being able to make a material which can interact more strongly to the CO2 molecule in order to allow its chemical interaction with another reactant in order to transform it into a new chemical. The thing is that due to the chemical properties of the CO2 molecule, it's really difficult to make it react with something else without an efficient catalyst. So the thing is that the catalyst should be very active, and the energy used must be very low in terms of if you want to use something that is that can be commercially available or applicable in real life. Yes. So I can see the second. What is the characteristic of catalyst required for CO2 transformation? Yeah, as I told you, the catalyst must be strongly active. Some others work at low temperatures, but the ones that work at low temperatures are very sensitive because they are very, because they are very reactive. So you need active sites that can interact with the CO2, but at some conditions that don't that are inert, in order that only is selective to the CO2 molecule. There are many catalytic systems for that, but yeah, you have to be very specific on that for the CO2 molecule. Yep.
Thank you very much for the answer. I am sorry for Dr. Wahyu because our time is up, so you can just deliver your question privately, or I can deliver your questions. Okay, please give round of applause again to our invited speaker. Okay, thank you, Dr. Heriberto. See you again when I see you again. Okay. Adios. Okay, so the next session is the talk by our invited speaker, Dr. Wan Nur Hayati, and her talk will be moderated by Dr. Trianda Gunawan. But before that, we would like to take picture together, for the keynote speakers, invited speakers, as well as the participants, all of the participants, while everybody is still here. So please welcome our keynote speaker, our invited speaker, and as well as all the participants, please. Oh yeah, and the committee, please. Okay, I'm so sorry. Yeah? I deeply apologize for that. Okay, and people in the Zoom.
Ladies and gentlemen, for the next session is the invited speaker. So we will have the talk by Dr. Wan Nur Hayati, and her talk will be directed by Dr. Trianda Gunawan. Okay, please welcome Dr. Trianda Gunawan.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. We are moving to the next parallel session. Hybrid, both online and offline, will be conducted simultaneously after with the invited speaker of Dr. Wan Nur Hayati Wansaleh. But before we start the session, I would like to introduce to all of the participants who are attending virtually or in Zoom. So as you can see, the screen already shares the room of each respective abstract number. So you can enter the respective breakout room, which will be provided by our committee, our technical committee. And after that, in each breakout room, there will be its own moderator with its highlighted in the yellow color. So, like for instance, in the room 1, we have Garcelina Anindika, Andin as your moderator, and so on and so forth. So, for reminder, for the presenter in each breakout room, your time only 15 minutes. And please present not more than 10 minutes, so we have at least 5 minutes to discussion. That also applies for all participants in here, in the offline session. So is that clear for everyone in Zoom? Okay, cool. So let's start to the next session, which is the invited speaker. For our next invited speaker, our next invited speaker is Dr. Wan Nur Hayati Wansaleh. Before she talk, I will read about her brief CV. Okay, her affiliation is from Advanced Membrane Technology Research Center, similar to the Dr. Joanna, and she's like senior lecturer at the School of Chemical and Energy Engineering, UTM. Her research interest is about membrane for respiration, photocatalytic, hybrid membrane, and water treatments. For me, Dr. Nur Hayati is my supervisor during the PhD. So finally we can meet again, Doctor. Thank you for coming. Without further ado, Dr. Nur Hayati will give a talk for not more than 20 minutes, I hope. So we can have plenty of time, at least 10 minutes for discussion. Okay, so without further ado, Dr. Nur Hayati, please come. And for all of the presenter, I would like to ask you to collect your presentation files to our committee here at the corner, so it will be easier for us to organize your files later on. Okay, thank you, Dr. Nur Hayati.
Thank you very much, Dr. Trianda, for the very nice introduction of me. So I'm so glad to meet you here. So before this, I don't have a chance to attend your Viva at that time. Okay, here is the. Okay, Assalamualaikum, a very good morning. So let me introduce myself. So my name is Wan Nur Hayati. So I'm from MTech and Faculty of Chemical and Energy Engineering. So I am senior lecturer in UTM and also the associate member at the center, research center. So first of all, I would like to thank the committee to invite me as one of the invited speaker. So this is my first time in Surabaya. So it's a very nice city. So I'm so glad to be here today. So this is my title that I would like to share with you on the photocatalyst for the degradation of the organic pollutant using the tungsten trioxide photocatalyst. Next, all right. So when we talk about the photocatalyst, so there is a lot of the application that we can use to apply the photocatalyst itself. So in this case, in my recent research, we would like to tackle on the water pollution. So here are those wastewater that come from several sources of the industry and also the household. So there is from the distribution, so this is the data that we reported around in Malaysia. So we have the wastewater that come from the water supply and sewage, manufacturing, wastewater sewage, agriculture, construction site, and also the household. So from the data, it's reported that most of the wastewater is come from the agriculture. So one of them is a POME, palm oil mill effluents. So one of the our photocatalyst, we have tested for the POME degradation. So other than that, from the pharmaceutical that's come from the hospital, for example, they have several other types of the pollutant. They also have a personal care product from the sewage, EDC, pesticide from the agriculture, and also dye from the textile manufacturing. So from the data as well, they reported that the dye is, most of them are coming from the Middle East and also the India, because there is a lot of textile manufacture there. So other than Malaysia, I believe that in US and China also, in a big country, they have same problem in the water pollutant. Also, the major contribution is come from the agriculture industry. Okay, so because of the water pollution that have been increased by year, and a lot of country and global research and engineer have been need to have a method to reduce the water pollutant by several type of the wastewater treatment. So photocatalyst is one of the method. As for now, we know that there is a lot other than conventional method that have been used using the chemical, physical, and biological method, and also absorption. Okay, they also give a very good performance in terms of the water treatment. But one of the other approach is on the advanced oxidation process, where the photocatalyst is one of them. Okay, why we would like to tackle the problem using the photocatalysis is due to several advantages: low energy consumption, no secondary pollution, environmental friendly, and also the photocatalyst itself give very good features that we can use during the application. Okay, photocatalysis as a definition is the process in which the light energy is used to drive pair of chemical reaction, where the reaction or degradation will happen in the presence of light. And the challenge in the photocatalyst nowadays, the researcher would like to tackle on the low solar energy utilization, where the broad application of the UV, sunlight, and also visible light is taken into consideration, and also the high recombination rate of the electron hole, where we would like to reduce or minimize. We want the recombination is not to be happen, but of course, in terms of the efficiency, we cannot achieve the 100% no recombination. We still have the electron hole pair recombination, but we'll need to find the photocatalyst that can delay or prolong the rate of the recombination. Right, this is the basic principle of the photocatalytic. So here are the mechanism. So we need a light, okay. In the presence of light, the chemical reaction will be occur. So in the case of the tungsten trioxide, WO3 is irradiated with the light where the energy of the excitation source exceed the band gap energy of the semiconductor. So this is the band gap. So each of the photocatalysts, they have a different value of the band gap. So it will determine the range of the wavelength where the photocatalyst can be degrade the pollutant. Then the photon absorb and the excitation of the electron at the conduction band, thus generating the electron-hole pair at the valence band. The oxidation and reduction will occur at the surface of the photocatalyst. Okay, they will oxidize the molecule of the surrounding substrate. So it depends on the what types of the organic pollutant that you would like to degrade during the process. Okay, tungsten has a very unique advantages that can undergo photoactivity process at a wide range of the wavelength. So under UV, visible light and also sunlight. Compared to our current, this is most famous photocatalyst nowadays. But this catalyst, photocatalyst only can be effectively under UV light. Okay, this is the structure of the tungsten trioxide and the different structure of the nanorods or nanosheet can be produced during the synthesis of the tungsten trioxide. So it depends on the method of the synthesis. So here, as you can see, there is several types of the tungsten trioxide that can be produced at different synthesis method, and also it will produce different band gap. Okay. So this is the current, mostly researchers has been used on TiO2 and zinc oxide. So now study have been enhanced, the publication also increased by year on the tungsten trioxide. It is because of their complete mineralization and effective pollutant degradation, where the final product will be CO2. And the advantages of the tungsten photocatalyst: narrow band gap energy, photostability, high crystallinity with high yield and recyclability, low cost, intense absorption within the solar spectrum, and also the photocorrosion resistant. So here are the challenges that we need to take into consideration when we choose tungsten trioxide as a photocatalyst. The recombination will occur once all the photo-excited electron accumulated on the surface of the photocatalyst and making it ineffective for the degradation to occur. So we need to modify the current tungsten trioxide in order to overcome this problem. Okay, here are the evolution of the tungsten trioxide and also for the photocatalyst. So any other types of the photocatalyst also follows this kind of the improvement and also the modification. So first they are study on the single photocatalyst, and then they come up with the binary where it's coupled of two types of the photocatalyst and also the ternary. Okay, if you can see from the publication, there is a lot of publication on binary and ternary nowadays. Okay, but for the single also, they also have still come out with the publication, and they have come out with a new photocatalyst. Okay, so from the performance, here they are using the degradation of the rhodamine B. It's achieved about 92% of UV irradiation in 100 minutes. This is they are using the single tungsten trioxide. Okay, and then the disadvantages is found that the fast recombination of the electron hole, so means that very low photocatalytic activity and low surface coverage of the photocatalyst. So by having this problem, so they come out with the binary by couple with the graphite nitride. So this is one of the combination between tungsten trioxide and graphite nitride. So here the electron in the semiconductor A, here is referring to the graphite nitride, are transferred rapidly towards the tungsten trioxide. Therefore, the valence band of the graphite nitride could accept easily the photoexcitation hole from the tungsten trioxide. So this combination, as you can see, they could achieve about 96% of the same pollutant from the single photocatalyst under visible light. Okay, here we could highlight this one is under visible light 100 minute 96%, but for the single they only have a 92 and under UV light. So we know that UV light, most definitely the photocatalyst will perform very well. But in order to have a visible light of high performance under visible light is very difficult. Okay, so within the same time as under different wavelength. Okay, so if under visible light, the tungsten only can degrade about 32%. And graphite nitride is 56%. Okay, so the mechanism it's proposed is based on the band gap difference between those two photocatalysts. The Z-scheme mechanism has been applied for this combination for the accelerating dispersion photo-induced electron, and the hole retain the charge with strong reductibility in photocatalytic process. The fast recombination means that the electron will be go to the H+. So when the combination happen, means that the hole for the degradation, reduction and oxidation cannot be occurred. So the photocatalytic activity will be reduced. So we need to delay the recombination. Okay, next one is on the ternary composite combination. So ternary means that 3 components. So here they combine 3 types of the photocatalyst with different band gap. So here are 2 examples here, TiO2, SnO2 and tungsten trioxide, and the other one is tungsten, graphite nitride and bismuth. So here also what we can see is on the Z-scheme mechanism. So nowadays, in order to delay the recombination is by having the Z-scheme mechanism. So when you choose the photocatalyst, so make sure that the first thing you can draw some kind of diagram based on their band gap. So from here you can propose what is the mechanism of that combination of your photocatalyst. Okay, Z-scheme, as for now, they are looking for the Z-scheme mechanism. And as we can see from the chemical reaction time, so previously they achieved about 100 minutes. So when we have a couple, 3 types of the photocatalyst in one composite, they can reduce the reaction time about 60 minutes. This one is for the tetracycline, is one of the pharmaceutical pollutant under visible light. And the other combination is using for the dichlorobenzene, where it can degrade about 98% in 240 minutes. Okay, when we are dealing with the pharmaceutical, it's very hard to get fully mineralization. So meaning that fully mineralization can be achieved by having a longer times. So and also they can operate under visible light. How we can determine whether the photocatalyst can be operated under visible or UV light? By having the photocatalyst that have a low band gap. Okay, this is the mechanism when we have the evolution of the photocatalyst. Other than having the visible light features, We also, currently the research are eager to have a photocatalyst with the energy storage substance, where it can operated under without having the light. Okay, so this is the semiconductor that have a energy storage substance is tungsten trioxide. And the other one is this combination, TiO2 will function as a light harvesting. So they have, means that in order to have both features, you need two types of the photocatalyst. One for the light harvesting under the presence of the light, and the second material will function to store the electron during the presence of light. And then under dark, it will, the WO3 will be, will function for the chemical reaction to degrade the pollutant. Okay, these are the published on the energy storage mechanism photocatalyst. They also have Ag, TiO2, platinum, and also etc. So this is the types of the tungsten trioxide for the single, binary, and ternary. So we can highlight here on the times of the degradation. So when you have a ternary, it takes shorten when you have a binary and single photocatalyst. Okay, this is the type precursor that we can use to fabricate the tungsten trioxide. And during the preparation also, when you choose the right precursor, and then you need to choose the preparation method. So there is 4 types of the method that you can choose. Sol-gel and co-precipitation, the process is at low temperature, where the hydrothermal and solvothermal is at high temperature, and also you need the expensive equipment where the autoclave is involved. Alright, this is the factor that involve the photocatalytic performance. During the preparation is calcination temperature, and for the photocatalyst, you have to have the desired properties first, and then you can choose the right photocatalyst. Okay, these are the factors. Other than that, so in terms of the performance, so when you have a solution or wastewater, it depends on the pH, on the catalyst loading, initial concentration of the organic pollutant, and also the type of pollutant. So most of the paper reported on the synthetic pollutants, on model pollutant. So of course, when you use a real wastewater, the times takes for the fully degradation will be longer. Okay, and this I have summarized on the performance tungsten compared with the model pollutant and the industrial wastewater. So as from here, for the industrial, it takes more than 6 hours, and for the synthetics, of course, is less than 2 hours. Okay, in summary, WO3, tungsten trioxide, have several advantages. Narrow band gap, can be operated under visible light, and in economic aspect, the synthesis method of WO3 required only low cost of acid. Environmental aspect, tungsten trioxide associated with harmless, non-toxic, environmental friendly. So for the next commercialization, the most important part is we need to find the optimum parameter that we can use during the photo activity. Okay, this is my current work on the tungsten trioxide. So we use ternary with the graphite nitride and pani. So we did tests on the pomade decolorization. So this is the scheme that we use. We give the light for the light harvesting about 2 hours, and under that 1 hour, and then supply the light, and then dark condition. So from here we can see that the degradation is still happen even under dark condition, meaning that the light harvesting semiconductor is function during the light, the presence of light. Okay, you can reach me through this email. So me and my teams at MTech is very welcome any collaboration from you all. So thank you very much.
Okay, thank you, Dr. Nur Hayati. Actually, you have 10 seconds left, so that's count as in time. Okay, so we are moving to the next Q&A session. Any of you, if have some curiosity regarding the Dr. Nur Hayati works, you may ask. Anyone? No one? So maybe I will start first, Dr. Nur Hayati. So you are working on in this time is about photocatalytic membranes, maybe materials, more like materials. So we also do some of it like photocatalytic, but we are curious on how we know that the process is actually photocatalytic process, not an absorbent. Is there any way to, like simple methods to understand this is a photocatalytic process, this is a absorption process? So maybe you can explain about that. Thank you.
Okay, thank you, Trianda, for the question. So yes, normally during the photocatalytic performance testing, we do have the adsorption at first. So we need to find out the limitation, the optimum time where the adsorption is stopped. So normally below 2 hours. So after 2 hours, then we present give the photocatalyst the light. So meaning that we allow all the absorption process and then we proceed with the photocatalytic. So prior the photocatalytic, we will do the pre-adsorption about less than 2 hours. Okay. So most of the reported is after the 2 hours operation, before the light, the present of light.
Oh, so
because without light, the photocatalytic will not occur.
Okay, so this actually knew that we need pre-treatment in in the form of adsorption process.
Yes.
After that, we threw the light to the sample. Like that.
And then we proceed the photocatalytic with the present of light.
Okay. How about if we do simultaneously, like we throw the pollutant into our material at the same time we also
give the light.
Give the light.
So most probably most of the reviewer will not happy with that because we cannot. This is what can I say? The method or the procedure that long been reported. They have that kind of scheme. Absorption and then proceed with the photocatalytic.
Okay, I see. Thank you. Okay, thank you. Is there anyone have idea now to ask? No one? Oh, okay. Bu Ratna. Thank you.
Thank you very much. Just to know what method do you use? Do you normally use to observe
method? Is it method?
The method to observe the mechanism of degradation, photocatalytic degradation.
Okay, by having firstly we come up with the figure with the different band gap, and then we also have the radical scavenger experimental in order to identify the right mechanism of the photocatalyst.
Any other method?
As for now, we've been reported using the...
For example, you analyze the...
Oh yes, and also the byproduct, by identify the byproduct of the pollutant.
You did.
Of the pollutant.
Have you done this experiment with, did you analyze the product?
Yes. Before this, on the biphenol, ibuprofen, we identify what types of the byproduct along the chemical reaction.
Okay, because normally for the photocatalytic, the result is oxygen and CO2 and water.
Yes, that one is the final product where the fully mineralization happens. Yes, before that there is so many byproduct with it, which is actually more hazard than the raw pollutant. Yes. So along the way, we have identified using the HPLC.
Yeah, it's PLC. Okay, thank you.
Okay, thank you for the question.
Thank you, Bu Ratna. Is there anyone? We still have 5 minutes left. Okay, so maybe I will ask again. Okay, so I see that some of your work also related not only materials, but the combination of the photocatalyst material into the polymer matrix. So I have two questions here. The first one is, sometimes we are also afraid that our polymer matrix for the membrane is also being degraded as with along with the pollutant, because it has the photocatalyst material. How do we prevent, or how do we choose the right polymer as a matrix for the mixed matrix membrane for a photocatalytic process? And the second one is related to your offers about AMTEC, because here also present the director of the AMTEC. Maybe some of the participants are willing to visit the AMTEC. Is there any special like requirement how to get there? Because Johor is like Surabaya in the term of the living cost, so it's also not that far from here. Maybe how we can get there into the AMTEC as a attachment student. Maybe that is two final question for me. Thank you.
Okay, thank you, Tianda. Okay, so for the first question is on the polymeric photocatalytic membrane. Okay, so we have incorporated our photocatalyst into the polymer membrane. What I can say is the most challenging part is on the performance itself. When we mix with the photocatalyst and polymer, we want the photocatalyst is on the top of the membrane. So most of them are going within the membrane. So the photocatalytic will be reduced because the chemical reaction is function and it depends on the photocatalyst, or not on the membrane. Membrane is only for the host and also for the filtration. Okay, that is the challenge that we are facing. So we also have incorporated into the electrospinning. Okay, so that one is showing the much better performance as compared to the photocatalytic membrane. I've been tried before and been reported. So for the second question, okay, all of you are welcome to MTech for the attachment, and Dr. Nurul also always send the students. So Dr. Trianda is one of them. So you are welcome to MTech. So we are very happy to have the attachment student from Indonesia. So please visit Malaysia. Please go to Johor, okay? And then you can have libur dekat Kuala Lumpur.
Okay. Thank you, Dr. Nurhayati. Since the time is up, please give a big applause to Dr. Nurhayati. And please stay here because Prof. Freddy will give you some souvenir to remember as a proof that you have been visit Surabaya. Okay. Thank you, everyone. So it's lunch time actually, but before I give it back to Dr. Zeni, I would like to make an announcement. After a lunch, we'll have the presenter session. So please, for all of you who will present right after the Dr. Nur Hayati, could give us your presentation files to the committee in the corner, in the front corner, and maybe after this we can have lunch, and Dr. Zeni will explain about the time expenditure for the lunch and praying time. Okay, I will give back to Dr. Zeni. Thank you.
Ladies and gentlemen, now we have to postpone our sessions because it's time for lunch. Okay, so for the lunch, it's already here on the corner, so please help yourself with the lunch, and we will back here at 1 p.m. Yeah, so you can have time, more time for lunch and prayer. And before we start our lunch, I would like to remind everybody, please stay tuned until the end because there will be awarding ceremony for the best presenter. And don't forget, for the presenter after this time, after lunch, please send your file and copy to the committee. Okay, so ladies and gentlemen, please have your lunch and please help yourself. Thank you.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart Eco Campus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web and mobile site. Smart Eco Campus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, a medical centre as health service unit, language and culture centre to boost English competence, ITS library, and several co-working spaces as a learning resource centre. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory, that has pioneered research, development and education, and already successfully winning national, regional and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
Learning process of master degree. The teaching methodology in the MOC is conducted by various methods. The conventional explanation by the lecturer followed by the class discussion. The courses that adapt this method are thermal analysis.
Di thermal analysis nanti kita akan belajar tentang yang pertama nanti kita ada TGA seperti ini sebenarnya gambarnya, kemudian ada TTA seperti yang di atas ini, kemudian yang di ini adalah DSD, yang ini TMA dan yang bawah di sini adalah DMA.
Research methodology.
Lebih spesifik ya dibandingkan manfaat karena ada yang tidak tahu juga.
Membrane synthesis.
Yang paling mudah dibuat itu menggunakan inversi fase ini. Metode-metode yang lain ada, nanti kita akan bahas juga metode-metode yang lain, meskipun metode yang lain.
Natural products chemistry.
Gamanya yang dekat A ini alfa, yang di puncak atas itu beta, di bawah gamma di sini. Jadi gamma-gamma, dua gamanya. Dimetil, tadi siapa yang nanya ada dimetil di hidroksi, ini dua metil, dimetil.
Quantum chemistry. For quantum chemistry, students are required to have the deep concept understanding and ability to derive several equations. The video showed that lecturer was direct the students to derive several equations and solve several problems. The study based on the recent article in the journal that has a relationship with the topic. The article-based study as an additional source explained by the lecturers. Discussion topic or presented by the students to develop concept and build the knowledge. Here is the courses that adapt this method. Structure and analysis of surface. The recent research on the application of structure and analysis of surface is studied based on the recent publication. For example, the study of scanning electron microscopy to identify a non-edible oil seed as energy corps. Molecular reaction dynamics. In addition, the explanation based on article-based study, The lecturer also gives the assignment for students to study the article.
Telah disajikan 3 artikel mengenai spektroskopi Doppler, yaitu mengenai aplikasi terkini untuk mengamati perkembangan
porous material.
Warna tekstil dihasilkan banyak oleh industri, di antara industri batik, industri tekstil, industri pewarna tekstil, dan industri bagian batik. Bahwa dimodifikasi dengan reos, kemudian dilakukan
membrane synthesis.
Dimulai dari introduction overview dulu, yaitu teknologi membran yang muncul sebagai teknologi inti di bidang pemisahan. Teknologi membran juga diterapkan secara luas di berbagai bidang, terutama untuk pengolahan air, limbah, industri, farmasi, makanan, bioteknologi, dan lain-lain.
Develop students to have the ability in research design through the course micro project. In this course, student is required to design the research, how to conduct the experiment, then finally present their project. Before doing the research project of their thesis, students are required to present their thesis proposal. Here are the records of several thesis proposal.
Teknik poliol. Di antara berbagai metode yang ada, metode kopresipitasi merupakan metode yang paling sering digunakan.
Kembali lagi ke ini ya, awal tentang masalah ya, masalahnya. Jadi tadi.
Namun penjelasan terkait interaksi yang terjadi antara nikel yang didoping terhadap ZNO terhadap pewarna tersebut belum dijelaskan secara detail. Oleh karena itu, pada penelitian ini kami memenuhi
Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana, untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia.
Learning process of bachelor degree. In the pandemic, learning is generally carried out by Zoom. Even though it is online, various learning methods in delivering courses can still be done, such as providing one-way material, discussions, group discussions, and doing practice questions. Delivery of lecture material is carried out using either a PowerPoint.
Ya, gitu ya. Jadi kalau kita makan lemak ya, misalkan gajih gitu ya.
Molekul persatuan volume ikan-ikan.
Explaining from textbook sources.
Konsentrasi A dikali HR-nya, tetapi ini berbeda karena ada yang mengurangi sejumlah HR absorpsi tadi ya.
As well as adding other sources that can enrich the subject. For example, in the subject of atomic and molecular structure, students are shown the website chemtube.com, which visualize several types of molecular orbital to make students become more aware of symmetry that are difficult to imagine. In the subject Modern Physics, the lecturer also introduced students to use EduGame in gamelab.mid.edu to help students understand about the relativity concept.
Nah, warnanya kalau kita perhatikan itu kayak ke arah biru.
The subject structures, properties, and reactivity of inorganic compounds. Lecturer asks students to make the molecule model using plasticine when explain about the molecule symmetry concept. Lecturer also developed the web from the medium to deliver the subject content as performed in the subject chemometric. Some subjects also add the external exposure to introduce students the subject application. For example, in the subject marine chemistry, students go to the sea to see various marine species. Then they discuss the relation to the subject. This activity was done in 2019 before COVID pandemic. In the pandemic, the external exposure is replaced by the virtual external exposure. In the subject chemistry membrane, the lecturer invites the industry practitioner to sharing about the problem of membrane application in industry, and the students are invited to discuss the solution. In the subject research methodology, students are required to be more active in exploring chemistry literatures and writing it down in the form of manuscripts, oral presentation, and posters. Guidance on how to search literatures is done in practice directly by showing several websites related to searches on chemistry. For subjects that require students to have the ability to calculate, exercises are carried out and discussed carefully. Implementation of assessments are carried out in various ways, such as conducting tests via My ITS Classroom and supervision using Zoom, or giving other tasks that can increase learning outcomes in the form of skills. For example, subjects biochemistry and foodstuff chemistry have assignments that are required to be submitted through the TikTok app. Subject chemical literature gives out assignments of video presentation, example, video, and poster. During this pandemic period, practicum is carried out either with demonstration in the laboratory with the help of lab assistants, or some practicum are developed with an online module. The following is a video footage of the Chemistry 2 Basic Technique Laboratory. Measurement of density. Solution.
Mari kita lakukan percobaan 3.
Thermodynamics. Calorimeter bomb. Binary solution. Freezing point.
Kita akan melakukan praktikum termodinamika yang membuat masa melakukan dengan menggunakan metode
Chemical dynamics. H2O2 decomposition. Acetone iodoform reaction. Synthesis organic reaction practicum. Styrene polymerization.
1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Welcome to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50 persons, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. And discussion space at the corridor. The chemistry office for administration is placed on the 2nd floor. There is a waiting room, office area, discussion room for lecturer, lecturer rooms, and prayer room. There is also a small library on the 4th floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory, Material Chemistry and Energy Laboratory. The Natural Product and Chemical Synthesis Laboratory. The Molecular Geochemistry Laboratory.
Do you ever wonder what makes a life-changing history? Right, a solid mission of the visionaries. It was Dr. Anka and his colleagues' mission to accelerate technology development. through the establishment of Institute Technology 10 November. Their goodwill has encouraged ITS students to take important roles in both local and global communities, ministers, CEOs, professors, entrepreneurs, and yes, another history maker. These successful alumni were trained in a healthy learning environment that was equipped with various supporting facilities. From vocation to marine technology, all faculties and departments of ITS were formed to be the best place to learn science, technology, and design. 7 faculties and 1 interdisciplinary school. Scientix, Faculty of Science and Data Analytics. MarTech, Faculty of Marine Technology. INSYS, Faculty of Industrial Technology and Systems Engineering. Electix, Faculty of Intelligent Electrical and Informatics Technology. CivPlan, Faculty of Civil, Planning, and Geoengineering. CreaBiz, Faculty of Creative Design and Digital Business. Vocation, Faculty of Vocation. And Interdisciplinary School of Management and Technology. Recognized as one of the top best-ranked institutes doesn't mean the finish line for ITS. To gain greater international recognition, ITS launched International Undergraduate Program. Students can get wider international exposure through 20 study programs they can apply. The chances are also open for professors from all over the world to teach and conduct research at ITS. These opportunities have made international joint research and other international activities successfully performed. Like IUP, students and lecturers from other programs have also contributed to the ITS achievements. Appreciations earned exemplify Institute's excellent performance. But technology and academic excellence is not the only goal of the Institute. Students are guided to apply their knowledge for the welfare of society. Because to note a new life-changing history, technology must advance humanity. ITS, Institute Technology, 10 November.
Surabaya, the provincial capital of East Java, is the second largest city in Indonesia. This city has a huge number of diversities among the people, cultures, and ways of living. Surabaya has been acknowledged for its green public open spaces. It also has successfully equalized the development between build-up area and green area that makes Surabaya a livable city for all.
I see Surabaya as a great city with amazing people. Living pace here is quite slow, so you don't feel the rush of living in the city.
It's also a good place to travel around. I mean, in bus you can go in many places, or taking train on Java.
It makes me also to be in peace, so I think that is a good place for me to stay.
Surabaya is also known as the City of Heroes because of its role in Indonesian struggle for independence. Moreover, Surabaya nowadays has already become the center of businesses, commerce, industries, and education in Indonesia. One of the pioneers of education in Surabaya is the Institute Technology Sepuluh November, better known as ITS. ITS has 3 campuses in Surabaya. ITS Sukolilo as main campus. ITS Manyar its campus vocational study of civil infrastructure engineering. ITS Jokro Aminoto as campus for Master of Management Technology. Occupying a large area of 180 hectares as its main campus, ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, 10 faculties, and 38 departments. ITS has various fields of study, faculties, and strategic study program which are the center of excellence. Faculty of Industrial Technology, Faculty of Marine Technology, Faculty of Electrical Technology, Faculty of Civil, Environmental, and Geoengineering, Faculty of Business and Management Technology, Faculty of Architecture, Design and Planning, Faculty of Information and Communication Technology, Faculty of Mathematics, Computing and Data Science, Faculty of Natural Science, Faculty of Vocational Studies. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS also has more than 130 full-time international students and 400 international student mobility short program, K&B program, student exchange, and another programs.
I work with many projects and many assignments, so it's helped me to improve my personal skill and also for communication skill.
There are many things that we have to fulfill, and ITS has been helping me to improve this kind of things. Beside my hard skill, I also have been able to develop my soft skill, which is important for nowadays leadership.
Also with ITS, I had a lot of opportunities to join different events for free, like the Rujak Connect Festival, which was the cooking event, something. Yeah, this is like kind of opportunities that you don't have every day, and it's funny to take part for once. Or yeah, it's nice.
ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS. ITS Central Library is in a 6-story building, with total building area 9,000 meters square. This library, more than 121,000 printed textbooks, more than 10,000 e-books, 10,000 audio-visual data, and 18,000 digital library collections. Besides providing students with the books, the library also provides students with comfort study area, like discussion area, hotspot cafe, computer rent, multi-purposes room, and Indonesia Development Information Services, which connect to the World Bank database. Research and innovation at ITS are geared towards addressing global challenges. Therefore, creative inventions are increasingly being produced by ITS researchers.
If people are talking about logistics and supply chain in Indonesia, we publish papers, we are doing research on transportation modeling, we are doing research on warehouse modeling, and we also do a lot of networking with industries, with companies, and our research has been used in many companies in Indonesia.
We know that Indonesia is the second biggest biodiversity in the world after Brazil, but I think if we combine with our sea area, Indonesia will be the biggest biodiversity in the world. And we do believe that if we perform science of nature and how to utilize it, it is very big opportunity for the treatment of some disease, not only for Indonesian people, but also for the world.
Considering the fact that Indonesia has unique climate characteristics, and also Indonesia is also very well known as the laboratory of disaster, therefore a lot of issues, a lot of problems have to be solved. But this is a challenge for us. We cannot work alone. We need to work interdisciplinary, which involve expert, local or internationally. Therefore, we invite all of you to work here with us in ITS. We expect that our contribution and our work will bring ITS as the Center for Excellence in Disaster in Indonesia.
ITS has more than 180 laboratories spread over 10 faculties. The laboratory is used to support faculty and students' research and provides the opportunity to collaborate on big projects and create impactful research programs.
institution, I think ITS has contributed a lot in terms of giving an ideas and spirit, and at the same time self-confidence to our country about how capable we are.
ITS, within the next 5 years, it would be a research and innovative university. It means that ITS will be playing a big role in the region, especially in Asia. For the next long term, in 2045, ITS would be an entrepreneurial university. Means that it having a big role playing in the global world.
So, come and join us.
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 Come and join with us, ITS.
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 University of Heroes.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart Eco Campus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web and mobile site. Smart Eco Campus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, a medical centre as health service unit, language and culture centre to boost English competence, ITS library, and several co-working spaces as a learning resource centre. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory, that has pioneered research, development and education, and already successfully winning national, regional and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
Learning process of master degree. The teaching methodology in the MOC is conducted by various methods. The conventional explanation by the lecturer followed by the class discussion. The courses that adapt this method are thermal analysis.
Di thermal analysis nanti kita akan belajar tentang yang pertama nanti kita ada TGA seperti ini, sebenarnya gambarnya kemudian ada DTA seperti yang di atas ini, kemudian yang di tengah ini adalah DSC, yang ini DMA dan yang bawah di sini adalah DM.
Research methodology.
Lebih spesifik ya dibandingkan manfaat karena ada yang tidak tahu juga.
Membrane synthesis.
Yang paling mudah dibuat itu menggunakan inversi fase ini. Metode-metode yang lain ada, nanti kita akan bahas juga metode-metode yang lain, meskipun metode yang lain.
Natural products chemistry.
Gamanya yang dekat A ini alfa, yang di puncak atas itu beta di bawah, gamma di sini. Jadi gamma-gamma, dua gamanya. Dimetil, tadi siapa yang nanya ada dimetil dihidroksi, ini dua metil.
Quantum chemistry. For quantum chemistry, students are required to have the deep concept understanding and ability to derive several equations. The video showed that lecturer was direct the students to derive several equations and solve several problems. The study based on the recent article in the journal that has a relationship with the topic. The article-based study as an additional source explained by the lecturers. Discussion topic or presented by the students to develop concept and build the knowledge. Here is the courses that adapt this method. Structure and analysis of surface. The recent research on the application of structure and analysis of surface is studied based on the recent publication. For example, the study of scanning electron microscopy to identify the non-edible oil seed as energy corps. Molecular reaction dynamics. In addition, the explanation based on article-based study. The lecturer also gives the assignment for students to study the article.
Telah disajikan 3 artikel mengenai spektroskopi Doppler, yaitu mengenai aplikasi terkini untuk mengamati perkembangan
porous material.
Warna tekstil dihasilkan banyak oleh industri, di antara industri batik, industri tekstil, industri pewarna tekstil, dan industri bagian batik. Dapat dimodifikasi dengan reos, kemudian dilakukan
membrane synthesis.
Dimulai dari introduction overview dulu,
yaitu teknologi membran yang muncul sebagai teknologi inti di bidang pemisahan. Teknologi membran juga diterapkan secara luas di berbagai bidang, terutama untuk pengolahan air, limbah, industri, farmasi, makanan, bioteknologi, dan lain-lain.
Develop students to have the ability in research design through the course micro project. In this course, student is required to design the research, how to conduct the experiment, then finally present their project. Before doing the research project of their thesis, students are required to present their thesis proposal. Here are the records of several thesis proposal.
Teknik poliol. Di antara berbagai metode yang ada, metode kopresipitasi merupakan metode yang paling sering digunakan.
Kembali lagi ke ini ya, awal tentang masalah ya. Masalahnya. Jadi tadi.
Namun, penjelasan terkait interaksi yang terjadi antara nikel yang didoping pada ZNO terhadap pewarna tersebut belum dijelaskan secara detail. Oleh karena itu, pada penelitian ini kami menemukan
Selamat datang di Departemen Kimia, Fakultas Sains dan Analitika Data, Institut Teknologi 10 November, Surabaya. Departemen Kimia ITS didirikan pada tahun 1970. Terdapat 2 program studi, yakni program studi sarjana dan program studi pasca sarjana meliputi magister dan doktoral. Departemen Kimia ITS memiliki reputasi di tingkat nasional dan internasional. Badan Akreditasi Nasional Perguruan Tinggi menetapkan akreditasi A atau akreditasi tertinggi pada seluruh program studinya, dari sarjana hingga doktoral. Program studi sarjana Departemen Kimia ITS merupakan program studi kimia nomor 1 di Indonesia berdasarkan data Sinta. Tidak hanya itu, program sarjana kimia telah mendapatkan akreditasi internasional dari Asian University Network (AUNKIA) yang membuktikan bahwa program studi ini sejajar di kawasan ASEAN. Departemen Kimia ITS memiliki visi sebagai pusat pembelajaran kimia yang menghasilkan lulusan berkualifikasi internasional sebagai agen pengembangan ilmu pengetahuan dan teknologi. Dengan misi menyelenggarakan pendidikan tinggi yang efisien dalam bidang kimia sampai jenjang pasca sarjana untuk menghasilkan lulusan yang diakui dan dikenal di tingkat internasional. Menghasilkan lulusan berkualifikasi internasional yang mengerti dan menguasai konsep-konsep dasar ilmu kimia serta memiliki keterampilan yang sesuai dan berhubungan dengan ilmu kimia merupakan tujuan dari Departemen Kimia ITS. Hal tersebut didukung dengan lingkungan Departemen Kimia ITS yang sangat kondusif untuk kegiatan belajar mengajar. Diskusi dan interaksi antar mahasiswa sudah menjadi budaya bagi Departemen Kimia, sehingga proses transfer ilmu pengetahuan lebih efektif. Departemen Kimia ITS memiliki 6 fasilitas laboratorium yang dapat mendukung riset dan aktivitas belajar mahasiswa, terdiri dari 1 laboratorium pendidikan dan 5 laboratorium riset. 1 laboratorium pendidikan yakni Laboratorium Kimia Fundamental, yang berfungsi untuk mendukung proses pendidikan, belajar, dan mengajar di Departemen Kimia. Sementara itu, 5 laboratorium lainnya merupakan laboratorium riset. Kelima laboratorium tersebut fokus pada riset dan pelaksanaan penelitian meliputi tugas akhir, diantaranya skripsi, tesis, maupun disertasi, serta beberapa riset kerjasama di tingkat nasional dan internasional. Lulusan program studi kimia ITS rata-rata mampu mendapatkan pekerjaan kurang dari 3 bulan pertama setelah kelulusannya. Lulusan program studi kimia ITS dapat bersaing di dunia pekerjaan dan memiliki peluang karir yang besar dalam bekerja di dunia industri, lembaga pendidikan, maupun pemerintahan di Indonesia.
Learning process of bachelor degree. In the pandemic, learning is generally carried out by Zoom. Even though it is online, various learning methods in delivering courses can still be done, such as providing one-way material, discussions, group discussions, and doing practice questions. Delivery of lecture material is carried out using either a PowerPoint.
Ya, gitu ya. Jadi kalau kita makan lemak ya, misalkan gajih gitu ya.
Molekul persatuan volume ikan-ikan.
Explaining from textbook sources.
Konsentrasi A dikali HR ini kan, tetapi ini berbeda karena ada yang mengurangi sejumlah HR absorpsi tadi ya.
As well as adding other sources that can enrich the subject. For example, in the subject of atomic and molecular structure, students are shown the website chemtube.com, which visualize several types of molecular orbital to make students become more aware of symmetry that are difficult to imagine. In the subject Modern Physics, the lecturer also introduced students to use EduGame in gamelab.mid.edu to help students understand about the relativity concept.
Nah, warnanya kalau kita perhatikan itu kayak ke arah biru.
The subject structures, properties, and reactivity of inorganic compounds. Lecturer asks students to make the molecule model using plasticine when explained about the molecule symmetry concept. Lecturer also developed the web from the medium to deliver the subject content as performed in the subject chemometric. Some subjects also add the external exposure to introduce students the subject application. For example, in the subject marine chemistry, students go to the sea to see various marine species. Then they discuss the relation to the subject. This activity was done in 2019 before COVID pandemic. In the pandemic, the external exposure is replaced by the virtual external exposure. In the subject chemistry membrane, the lecturer invites the industry practitioner to sharing about the problem of membrane application in industry, and the students are invited to discuss the solution. In the subject research methodology, students are required to be more active in exploring chemistry literatures and writing it down in the form of manuscripts, oral presentation, and posters. Guidance on how to search literatures is done in practice, directly by showing several websites related to searches on chemistry. For subjects that require students to have the ability to calculate, exercises are carried out and discussed carefully. Implementation of assessments are carried out in various ways, such as conducting tests via My ITS Classroom and supervision using Zoom, or giving other tasks that can increase learning outcomes in the form of skills. For example, subjects biochemistry and foodstuff chemistry have assignments that are required to be submitted through the TikTok app. Subject chemical literature gives out assignments of video presentation, example, video, and poster. During this pandemic period, practicum is carried out either with demonstration in the laboratory with the help of lab assistants, or some practicum are developed with an online module. The following is a video footage of the Chemistry 2 Basic Technique Laboratory. Measurement of density. Solution.
Mari kita lakukan percobaan 3.
Thermodynamics. Calorimeter bomb. Binary solution. Freezing point.
Kita akan melakukan praktikum termodinamika yang membuat asam dengan menggunakan metode
Chemical dynamics. H2O2 decomposition. Acetone iodoform reaction. Synthesis organic reaction practicum. Styrene polymerization.
In year 1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Welcome to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50 persons, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. And discussion space at the corridor. The chemistry office for administration is placed on the second floor. There is a waiting room, office area, discussion room for lecturer, lecturer rooms, and prayer room. There is also a small library on the 4th floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory,
Good afternoon, ladies and gentlemen. Welcome back to the 5th Isoc, the International Seminar on Chemistry. I can see from your face that you are already full, and so we can start our session again. So the next session is the parallel talk, and this session will be directed by Dr. Trianda Gunawan. So please welcome Dr. Trianda Gunawan.
Thank you, Dr. Zeni. Okay, so we are moving to the presenter session. So we have quite a big names here. So alhamdulillah, after having lunch, hopefully your body and mind are focused now. So the first presenter, she is our secretary department, Dr. Nikmah. She will present about an effort to increase the conductivity of solid polymer electrolyte. So, Dr. Nikmah, maybe. So, please give an applause for Dr. Nikmah.
Thank you, Pak Trianda.
Okay, but before we start, a quick notes about the today's sessions. So all the presenter will have time at a maximum of 12 minutes to talk about their works, followed by at least 3 minutes for the Q&A session. I will remind you if you have 2 minutes left. So maybe that is the quick rule. So I hope everyone here will have a good discussion. So please don't shy to ask anything to our speakers. Okay, good, Nima. Time is yours.
Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about the research. Actually, this is my student work, and then I asked my student to come here to present, and they say, one of them, and then I choose another student, and they say, I'm afraid, ma'am. So, because it's already registered, so I must present this work. The title of this research is the optimization of sodium perchloride concentration and addition of filler silica to increase the ionic conductivity of solid polymer electrolyte, which is the polymer is PVA and then combined with chitosan, and the salt is sodium perchloride and the filler is silica. The outline of my presentation is the introduction, and then continue with methodology, and then result and discussion, and the last is conclusion. The introduction, the background of this research, as we know that the lithium-ion battery is one of the energy storage system that, as we know that the abundance of lithium is limited, but the use of the lithium-ion battery is very high, like our laptop, our mobile phone, the toys, and other tools need the lithium-ion battery. So the limitation of the abundance of lithium, and also the high production of lithium-ion battery, we choose another alternative by using sodium, because the characteristic of sodium and lithium is almost similar. That's why we choose sodium. And if we see the characteristic of the sodium, this is the abundance in the earth is more than lithium, so we choose sodium. And also the production cost also lower compared with the lithium. The component of lithium-ion batteries, we know we have anode, cathode, and also electrolyte. usually the electrolyte that used in the lithium-ion battery is liquid electrolyte. But actually, if we use the liquid electrolyte, it has high conductivity, but the electrolyte can make leakage and then cause explosion in the device. Like we know that maybe some laptop can make explosion because of leakage of the liquid electrolyte. So we need to find other electrolyte to make this drawback. So we use the polymer electrolyte, solid polymer electrolyte we use here to resolve the leakage of the electrolyte, and also the flexibility of solid polymer electrolyte also good. But here the conductivity of solid polymer electrolyte is low, so we need to increase the ionic conductivity by using a filler in this experiment, in this research. Yeah, so still in the background, so we will make the solid polymer electrolyte to increase the ionic conductivity, and then we use the polymer here is PVA, and then combine with the chitosan because we want to use the polymer from the natural, and then we add the salt by using sodium perchloride because we will make the sodium ion battery to change with the lithium ion battery. And then we will add the filler by using silica. The silica is synthesized from the in Indonesia we call tebu, ampas tebu. I don't know what is in English. And then we synthesize silica from there, and then we characterize and we get the silica, and then we use the silica to make the conductivity of this polymer electrolyte increase. So the problem of this research is to determine the condition, the optimum condition of the salt, the sodium perchloride, and then after we get the optimum condition mean we get the highest ionic conductivity. After we get highest ionic conductivity, and then we add using the silica. And then this is the scope of problem. We choose the specific ratio here of the polymer and then sodium perchloride. This is based on our previous publication. The reviewer asked to make the optimization from the salt, because before we just optimize only in the filler without optimization in the salt. And then we also add the filler here by using silica, and then we will compare the ionic conductivity increase or not. So the purpose of this research is to obtain the right composition of the solid polymer electrolyte by using PVA and then chitosan, and also the salt is sodium perchloride and filler is silica in the form of a thin film by varying the concentration of sodium perchloride salt, and in order to get the highest ionic conductivity. So the methodology here we use, this is all the tool and material that we use, and then the procedure here, we use chitosan and then we dissolve in the acetic acid. After this chitosan dissolve by using stirrer, and we do in the room temperature, and then this homogeneous solution we add to the PVA. We do two experiment. One is chitosan, we dissolve in acetic acid, and the other experiment we dissolve PVA using aqua test. After these two kind of polymer become solution, and then we add together, and then after that we add the sodium perchloride in different ratio, and then after we get the homogeneous solution, we do casting, and then after it is drying almost 1 day, and then we get the film of solid polymer electrolyte. This is the procedure of the silica synthesis as a filler. Yeah, we use bagas S. Yeah, I say before ampas tebu, bagas S. The bagas S we synthesize become silica by using this procedure. We add sodium chloride and then we do in the temperature at 100 degrees C, and then we maintain in pH until 7. After that we get the silica. And then the same procedure actually with the previous solid polymer electrolyte, but here we just add the silica after we get the silica from the bagas S. After we get the film, the first we characterize using ACE to get the ionic conductivity, and then we do other characterize like XRD and also FTIR. This is the result. These three film, we just take the first, the A is without salt, and then B is with salt with the highest ionic conductivity. We just take the picture with the highest conductivity because in the previous we have a lot of concentration of salt here, and then figure C here by adding the silica. Yeah, the optimum conductivity we get from this condition. The composition of PVA and chitosan is 3 divided by 2, and the sodium perchlorate is 4. And we get the optimum conductivity is 1.08 cross 10 minus 4. And then after we add the silica, the ionic conductivity increase little bit in this number. 1.0 become 3.0. The 10 minus 4 is the same. And then the other characterization here, we do the XRD test. The XRD test actually to prove that if we add sodium perchlorate and also the silica here, the crystallinity is decreased. Because if the crystallinity is decreased, it means that the sodium ion can move a lot between anode and cathode. And for FTIR characterization here to prove that the sodium, the bonding between all of these polymer, salt and also silica is not chemical bonding actually, because if we see here, no other peak from these 3 different sample. The peak almost the same. Okay, the conclusion, we get the synthesized solid polymer electrolyte with the optimum condition. The composition of PVA, chitosan, sodium perchlorate is 3, 2, and 4, and we add silica is 5%, and we get the highest ionic conductivity is 3 cross 10 minus 4 Siemens at room temperature. Okay, thank you. I give back to Pak Trianda.
Okay, thank you. So you actually on time, have 10 seconds left. So okay, so we have 3 minutes for a discussion. Please, anyone who have a question in mind, don't hesitate to come to the front and ask Bu Nikmah. Yeah, we call it Bu Nikmah. Question. Anyone? No? So maybe I will ask, but maybe it sounds like some stupid question, but at the beginning I just mentioned there is no stupid question. So why you in your research you are optimizing the sodium perchloride contents, right? So why the sodium perchloride content should be optimized? I mean, how it contribute to the conductivity of the polymer solid electrolyte. Thank you.
Yes, thank you for the nice question. Actually, like I mentioned before, why I optimize the salt concentration here, because in the previous our publication, we didn't do the optimization of the salt. We just optimized the filler, and then the reviewer asked to give the data that you need to optimize the salt also, and then we just say, thank you for your suggestion. Maybe we will do in the next research. Actually, the reason also why we need to optimize the salt after we do this research, if we give the salt too much, maybe the film, the solid polymer electrolyte cannot dry. So we can take the film. We cannot take the film, and of course, if we cannot take the film, we cannot characterize for all the characterization, and also for the application later in the battery. Also, if we cannot take the film, of course, we cannot apply it in the battery also.
Oh,
yeah.
I see. So it's basically indirectly affected to the ionic conductivity because it affects the structure of your solid electrolyte.
Yes.
Okay, thank you. Maybe one more question? No, yeah. Okay, I think that's wrap up the session of Bu Nikmah. So please give applause to her.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, we are moving to our next speakers. Wow, I'm surprised. So our speaker is none than the one and only our MC today, Dr. Zeni Rahmawati. She will present about the catalyst for production of green biodiesel. So Dr. Zeni, the same rules also apply for you. I will remind you 2 minutes when you have 2 minutes left. Okay, thank you. Time is yours.
Good afternoon, ladies and gentlemen. Yeah, it's me again. Yeah. I hope you are not getting bored with me. Okay. So thank you very much for having me here. It's such an honor for me to be able to talk some of my research. This is the continuation of my PhD and my current research, which is the production of green diesel through the upgrading of biodiesel over cobalt catalyst. So in the next 15 minutes, we will discuss about the background of my research, and it includes the catalyst, the characterization, the result, and of course, the overall finding of this research. Okay, let's move on to the introduction. Okay. So, biofuel has been developed for all along in Indonesia, and it's always a nice topic to talk about. In 2020, our government has a program called B30 mandatory program. It is basically the mixing between the fossil fuel and biofuel in the proportion of 70 and 30. This is a very successful story. We can increase the production of biofuel, we can reduce a lot of CO2 emissions, and of course, we can give a lot of jobs for many people. So our government tried to increase the target with the program called B40 in 2022 and so on. But the problem is, of course, our biofuel is not enough. And the second problem is the biofuel production in Indonesia always depends on biodiesel. And biodiesel, of course, has some problems. Yeah, biodiesel has a lot of oxygen content, so we cannot get complete combustion. So there will be a deposition of carbon in the machine, And also there is another problem, that is the degradation during the storage. So we need to find another biofuel, yeah, so we can create more biofuel with a better fuel properties. So we come up with this idea, the green diesel or the renewable alkanes. How can we get the green diesel or renewable alkanes from biodiesel? Okay, so biodiesel can be upgraded to the green diesel or alkanes by the deoxygenation. So this reaction can be conducted at elevated temperature, about 200 up to 450, and quite a bit high hydrogen pressure, about 1 to 10 megapascal or 10 to 100 bars. Yeah. So for this reaction, we required supported metal catalyst. Oh, sorry. Okay. So we required supported metal catalyst. So this deoxygenation involves 3 reactions, which is the hydrodeoxygenation, decarboxylation, and decarbonylation. For hydrodeoxygenation, this is the route. So we can upgrade the fatty acid methyl ester or biodiesel to alkanes with aldehyde and fatty alcohol as intermediates. For the second one, the decarboxylation, and the third one, decarbonylation, we can produce alkanes with 1 less atom carbon. So that's what we are trying to do. We, at first, yeah, because it is just the start of the research, so we haven't used the biodiesel, but we pick methyl stearate, like one of the fatty acid methyl ester, as the model compounds. So we conducted the deoxygenation of methyl stearate over cobalt silica and cobalt alumina in a batch reactor at 300 degrees, and the hydrogen pressure is 50 bar. So, okay. So let's move on to the catalyst characterization, because we want to know the properties of the catalyst, and we can have a look if these properties will influence the result of the deoxygenation reaction. So we perform several techniques from BET, hydrogen TPR, XRD, gravimetric analysis, and the last one is the hydrogen chemisorption. So we basically, some of them conducted in University of Aberdeen. It's just a collaboration. So from this technique, we got several characteristics. The first one is, of course, the porosity, the surface area, and pore diameter. Cobalt silica has higher pore surface area, compared to the cobalt silica, and also has higher reducibility. But if we look at the dispersion and particle size, cobalt alumina is superior compared to cobalt silica. So let's have a look to the initial reaction. Yeah. So we tried to perform the deoxygenation of methyl stearate over cobalt silica and cobalt alumina with a variation of reaction time only to 2 types, yeah. 2 hours and 14 hours. We tried to make it so far opposite just to test it. Okay, from the conversion we can see that cobalt alumina is much superior than cobalt silica. So even cobalt silica only has like 11% after 14 hours, while the cobalt alumina has 18.7% after 14 hours. And if we look at the product selectivity, while it's quite surprising, cobalt silica doesn't produce sterile alcohol, straight away heptadecane and octadecane. But then when we look at the cobalt alumina, we found sterile alcohol as the intermediates at lower conversion. And in the end, of course, the alkanes becomes main products. So from this result, we continued the reaction with cobalt alumina. So we just basically left the cobalt silica. So we test a reaction of methyl stearate with cobalt alumina 8 to 8%. We basically actually we varied the cobalt loading, but we didn't perform it here. So this one is the result. We varied the reaction time. Yeah, Okay, so if we look at the conversion, of course, it's very common. The conversion increased as a function of reaction time. At the first 30 minutes, we had only about 18%, and 70 and 87 after 14 hours. And the product is sterile alcohol as the intermediates, and octadecane and heptadecane. Okay, if we look at the selectivity, okay, this one. Okay, the selectivity of sterile alcohol, of course, because it's intermediates, it's quite high at the first 30 minutes, but afterwards it's getting low to about 20%. Octadecane is the major product here. So we see this line, yeah. So this one is the octadecane. So octadecane has the highest selectivity from the start until the beginning if we leave the sterile alcohol. Okay, and the next is heptadecane. Heptadecane has a very similar selectivity, but slightly lower than that. Okay. So from this one, we try to figure out how the catalyst influence the product selectivity and which route is the main one, or which pathway is the reaction. So we have a look to the yield of the product. The first is sterile alcohol. So this one, yep. So we can see that at first sterile alcohol, of course, it's always the main one, about probably 13%, if I'm not mistaken, yeah, this one. And then it inclined to about 30% and stay the same, and finally declined to about 12%. If we look at this profile, then we can see that, okay, the sterile alcohol increased, and after that, when it stayed the same and declined, then it means sterile alcohol is transformed to another compounds. So we can figure out how it happened by looking at the others product. So from the sterile alcohol profile, we conclude that the sterile alcohol comes from the direct hydrogenation of the methyl stearate. So the next one, let's have a look to the octadecane. From the octadecane, this one. Okay, I think. Okay, yeah, this one. So the yield increased up to like 7 hours, and after this, there is like significant increase. So I can guess that there is a relation between the sterile alcohol and the octadecane, because it's like in inverse here. So, okay, we conclude that the octadecane comes from the excess hydrogenation of sterile alcohol. And the next one is the heptadecane. So heptadecane is just like, I can say, linearly inclined. So I don't think it's related to the sterile alcohol at some point. So we infer this route. Okay. So heptadecane comes from the decarbonylation of methyl stearate. So, and we check the octadecanal, of course. We didn't find it much. We found octadecanal in a trace amount. So we concluded, okay, perhaps this heptadecane comes from the octadecanal that comes from the hydrogenation of methyl stearate. And we tried to figure out these relations between sterile alcohol and octadecanal. So we performed the reaction with sterile alcohol as the reactant, but we didn't perform here. We got the octadecane, octadecanal, and heptadecane. That's why we proposed this one. But the other problem is we haven't had look at probably the mechanism in organic way. So it's probably the next work or the future work for us. Okay, so only here what I can deliver today. So to conclude my presentation, so we can how to say, we can confirm that methyl ester, in this case is methyl stearate, can be upgraded to green diesel through the deoxygenation over cobalt catalyst. And cobalt alumina has better performance than cobalt silica. And also at low conversion, sterile alcohol is the major product. So it gives us an idea that sterile alcohol is the intermediates. And also at high conversion, octadecane and heptadecane was the main product. So heptadecane comes from the decarbonylation, and octadecane comes from the excess hydrogenation of sterile alcohol. Thank you very much, and I would like to thank some people here. So the scheme, the research grant for this project, which is the PDKN from Kemendikbudristek, and also my previous supervisor, Professor James Anderson, and Dr. Alan McHugh. Thank you very much.
Okay. Thank you, Dr. Zeni, for a nice talk. So we have 2 minutes for discussion. Maybe if any of you have a question, please. Okay. Let's go.
Okay, thank you for opportunity. I ask only one question. You said in the introduction that oxygen content in the organic molecule will reduce the completeness of the reaction. Why?
Oh, so let me just try this. So you mean the oxygen content, how it comes, causes the incomplete combustion?
Yes.
Okay, so thank you very much for the questions. Can I answer it directly?
Yes.
Okay, so basically in the hydrocarbon, when we have only CH, yeah, so correct me if I'm wrong, there are a lot of organics professors here, so I'm a bit, sorry if I am mistaken. Yeah. From what I read, so basically the combustion of hydrocarbon, it happens between the oxygen, yeah, because it's combustion oxygen and CH, yeah. So it will create energy that we use for fuel, for example. If in hydrocarbon we can produce complete combustion because we can like burn the CH, become CH2 and H2O. But if in biodiesel or fatty acid or another, like for example, natural oil, so if we have more oxygen here, oxygen cannot be combusted, so there will be like incomplete combustion. So we only combust the CH1, the CH, but the oxygen's left there, so it will make like the composition over there.
Okay, thank you. I think he's so satisfied with your answer. So maybe we have one more question. Anyone? No? Oh, maybe I will ask. Thank you, Dr. Zeni. You share about your interesting research. So I'm curious, actually, about the couple in your cover. What? Sorry? About the couple image in your cover presentation. No, anyway. So you are using the term of green diesel, right? But in the process of making this diesel, you are using a lot of hydrogen. Instead, it is up to 50, if I'm not wrong, there 50 megapascal, right? So in the point of view, I think I will just use the hydrogen as a fuel. What do you mean with the green diesel here? Okay. The green.
Okay, so
thank you.
There are 3 kinds of biofuel, yeah. The first generation, the second generation, and the third generation. The first generation is biodiesel. So it depends on the feedstock. The second generation is the green diesel. It's just the name that we normally use. Green diesel, renewable diesel, or renewable alkanes. It comes from the upgrade of the natural oil or the upgrade of biodiesel or fatty acids or any other feedstocks. And the last one is biodiesel from algae. So there is calculation, but it's not me who calculates. So we have just look at the literature. Actually, in overall cost, it will be more efficient, this process. And the other one, we can remove the hydrogen if we can direct the pathway to the decarboxylation and or decarbonylation. So in decarboxylation, we don't need hydrogen.
Okay, thank you.
Thank you. Yeah. In Gresik, there is industry of green diesel. Is the same products with your research?
Thank you very much for the question. I deeply apologize. I haven't had any idea of that. Probably I will look at it again. So I don't know at the moment. Sorry. So probably I can confirm with you after this, so I can have more knowledge here. Thank you very much.
Okay, thank you. So I think that's a wrap for Dr. Zeni Rahmawati session. Please give applause to her. Okay, so we are moving to the next presenter. Oh, he is the only student here. So brave. Okay, our next presenter will be Mr. Alvin Rahmat Widianto. He will talk about the review about the membrane for biogas upgrading. So Alvin, you have a 12-minute maximum for the presentation, so we can discuss more. Okay, thank you. Time is yours.
My name is Alvin Rahmatudianto. At this time, I would like to present my works regarding the review of recent development of polyimide membrane for biogas upgrading. According to the data from National Energy Council of Indonesia, their transformation of fossil fuel becomes renewable energy. In the 20 and 40 and 50, it is expected that the using of renewable energy is 31%. Therefore, we encourage to develop the renewable energy. This policy in order to obtain the Sustainable Development Goals point 7 about affordable and clean energy. On the other hand, CO2 emission has been raised by the year. According to the data from the World Bank, Indonesia CO2 emissions has been raised from 0.8 up to 2.3 metric tons per capita. There are 187% improvement. Therefore, technology for carbon dioxide separation is essential to be developed. In this time, I would like to discuss the biogas utilizations. Biogas can be produced from the several or various sources like livestock waste, crops waste, water, and food waste, using an aerobic digester with utilized methanobacteria. In this time, I would like to focus on the how to optimize the biogas become biomethane. There are several various sources of biogas which produce a different characteristic of the gas that contains, including methane, which is the main item for the biomethane, and other impurity like carbon dioxide, nitrogen, oxygen, and hydrogen sulfides. There are several methods, existing methods that use for upgrading biogas, like membrane separations, pressure swing absorption, water scrubbing, chemical scrubbing, and organic solvent scrubbing. However, the conventional methods has several limitations, including the process is energy intensive, and they are using a lot of room, equipment size, and they still need other process to obtain biomethane. Membrane separations is interesting to be developed and utilized in the biogas upgrading, owing to their high efficiency energy consumption, and they are a low footprint. This is several works that I have done to the review of the advancement made in the membrane development and the progress of membrane development in the industrial applications. In the future, in the current research, they are which conducted by Vidacto using ionic liquid and graphene membrane, and the using membrane for hydrogen productions, full-scale pilot plants in Dominions by Evonik. On the other hand, the using of membrane has been increased. In the year, as we can see in the figure, the membrane is favorable to use in the industrial. One of the parameters that affect the performance of the separation in the membrane is the selection of the material. The polymer membrane is commonly used in the industrial or in the research scales, and as we can see in the figure, compared to the various several polymer, the polyimide has favorable due to the cost and performance, interesting, and as we can see in the right figure regarding the Robertson upper bound curve of the gas separations, which usually can be utilized as a standard in the research publication. The polyimide has a better separation, which is above the Robertson upper bound compared to the other polymer like polysulfones. In addition, according to my previous research regarding the carbonizations of polyimides with embedded by zeolite composite carbon, this is the figure of the mixed metric membranes, and this is the figure of the after carbonizations with mixed metric carbon membrane. And as we can see in the figure that polymeric membrane, if we carbonize, becomes mixed metric carbon membrane, has an improvement of gas permeability and gas selectivity. In addition, this is the figure that I have reviewed regarding mixed metric carbon membrane from the various filler that used in the recent study. There are filler carbon, metal like ferrite oxide, or nickel, and metal organic fiber, silica, and zeolite. In this graph was interesting due to the higher research, higher work, a lot of work that has been successful to surpass the Robertson upper bound curve. And moreover, to obtain a minimum 95% methane purity, the carbon dioxide and methane selectivity is required by 19. And the most of this works, this result, it has above the standard. Therefore, mixed metric carbon membrane has potentially to be explored and in the future. On the other hand, with several using of various module has several characteristic on the membranes like packing intensity and cost of for module and pretreatment. Hollow fiber module is favorable or interesting due to there has a lot of area because there are hole in the fiber and the cost is relatively low. And if we utilize or develop the carbon hollow fiber membrane in the industrial scales for biogas upgrading, this is the schematic of the technology. First, the biogas need to be pre-treatment using to remove hydrogen sulfides, using activated carbon or other materials, and then the biogas to be purified using membrane technology to produce biomethane. In addition, carbon hollow fiber membranes and modified carbon hollow fiber produced on the pilot plant consume 22% less energy as compared with the polyimide membrane system. The conclusion and the future prospect of these works is we expect that membrane-based biogas upgrading will be frequently used as a future upgrading technology. And the development of carbon-based membrane will be considered in the future owing to their satisfactory performance. However, need to be explored regarding the brittleness of the carbon properties. Thank you for your attention.
Thank you, Mr. Alvin. So you have 30 seconds left. So thank you for your in time. Okay, so anyone, if you have any question regarding to the Mr. Alvin works about the review for biogas upgrading? No? Maybe I will ask again. Hopefully you are not getting bored about me asking so many stuff. Okay, Alvin, so thank you. You already did a great work regarding the reviewing about the membrane for biogas upgrading. So it seems that according to Robertson upper bound curve, so basically this picture, right? This one is the carbon metal MOF silica is the fillers or the materials?
Is the filler in the mixed matrix membrane, carbonized mixed matrix membrane.
Carbonized mixed matrix membrane. Okay, so it is basically an inorganic mixed matrix membrane in the form of the carbon, right?
Yeah.
So we see that the challenge about this membrane is that the carbon membrane is so brittle. Yeah, so it's so brittle. So from your review, do you have any? Have you found any papers or any report that that is so convincing enough to apply the carbon membrane for in the big scale?
Thank you, Dr. Trianta. For the big scale, I think there are some modifications that have been done, like the addition of the additive in the membranes and the top solution, which has reported that carbon membrane also can be high tensile strengths which is applicable in industrial scales, I think.
What kind of modification is that? Do you remember?
Using additive in the DOP solution, so they reduce the brittleness of the carbon membrane.
Okay, so adding an additive
Yeah.
to the DOP solution, but the DOP solution is in the form of to form the polymeric membrane, right? And
Yeah.
the polymeric membrane after that is like carbonized to form a carbon membrane. So the additive is still working there.
I think on the other hand, it can be controlled by the temperature of carbonization. If we higher heating of the carbonization, it higher brittleness properties, and if reducing the heat temperature of carbonization might be can reduce the brittleness of the carbon membrane.
Okay, okay, thank you. Is there anyone to ask again? No? Okay, so I think that's a wrap for Mr. Alvin's session. Please give him a big applause. Okay, thank you, Mr. Alvin. Okay, so we are moving to the last speaker of this session. I will welcome Dr. Ratna Ediati. Oh, Dr. Ratna Ediati is still praying. So what we do now? Maybe I will give back to the host so that Dr. Ratna will join the next speaker session, I think. Okay, so maybe that's all for this session, this afternoon session, the first afternoon session. Hopefully we can gain a lot of knowledge, new knowledge. We can learn a lot. If you have still interesting into the one to another works, feel free to discuss with the respective person. And that's all for me as your moderator this afternoon. Oh, Dr. Anna is already back, so I will take back my words. Okay. Okay, cool. Okay, so I'm sorry. So Dr. Ratna, since Dr. Ratna already here, so this last session will be presented by Dr. Ratna Ediati. We call it usually as Bu Ratna. She will present about the MOF material for methylene blue absorption. So Dr. Ratna, you will have maximum 12 minutes. You ready, Doctor? Bu Ratna? Yeah. Okay, thank you. Time is yours.
Okay, good afternoon, ladies and gentlemen. Let me present our student result. Actually, Alvin Ramadhani Putra Hidayat, and also just now Alvin Rahmat Widianto. To Alvin is a great student. They are very great student. He's just completed his master degree, and at the moment she's going to an industry for work. Okay, so he asked me to give presentation then. I'm sorry about that. So this is the it's about the synthesis of the metal organic framework using ultrasound assisted method compared with the sulfothermal method. So this is absorption of methyl orange on UO66 synthesized using ultrasound assisted method. This is written by Alvin Ramadhani Putra Hidayat. Okay, this is, I think this is the background. It's about the wastewater contain of some dyes from industry. We need to treat this one. The dyes will be coming from leather, tanning, and paint industry, dye manufacturing industry, textile industry, and coloring industry, and paper and pulp industry. This is most of them, and we will discuss about the one of the dyes is methyl orange, which is this is a waste that is harmful to the environment. And because the methyl orange is toxic, carcinogenic, mutagenic, because there is an azo group dyes which have the group on N double bond N. And we will remove or decrease the concentration of this dyes using adsorption technique. And we need to select the adsorbent suitable for this adsorption process. We use one of the metal organic framework called UO66, which consists of zirconium metal or cluster of zirconium with ligand benzene dicarboxylate. This metal organic framework, UO66, this is very special because the thermal stability and also chemical stability is very high, because this is consists of zirconium and link very strong with the oxygen double bond from the carboxylic acid of the ligand. This OO66 has a high surface area, 765, and pore size 1.1 nanometer, pore volume 0.446, thermal stability reaches 500 centigrade. So we will synthesize this we will synthesize this UO66 using two different methods. The normal synthesis method for the metal organic framework is sulfothermal, which is require quite a lot of solvent. Normally we use dimethyl formamide, which is toxic and also expensive. So we need to use the another method we call ultrasonation method, which is shorter synthesis time, environmentally friendly, and the resulting material is nanosite with higher yield. So this is the method of the synthesis. We use DMF as solvent, and there are two methods for the crystallization using ultrasonic and also sulfothermal. For ultrasonic, we only use 2 hours, but for sulfothermal, we need 24 hours at 120 degrees, followed by washing, washing with DMF, washing with methanol, and drying at 90 degrees. And then characterize using XRD, FTIR, SEM, N2, adsorption, desorption, and TGA. And then for the adsorption process, we did effect of contact time. With the adsorption condition, we use this dosage 10 milligram per 20 ml with a variation of concentration of methyl orange. Results and discussion. As we can see, we have a similar XRD pattern for UO66, synthesized using sulfothermal and ultrasonic. This is a typical typical XRD pattern for UO 66. This is the size of the UO obtained by sulfothermal and also by ultrasonic. And also we match the FTIR spectra with the standard, and we can see in here UO 66 synthesized using ultrasound and sulfothermal has similar spectra. For the SEM, we can see in here, for the sulfothermal, we have actually this is similar regular octahedral morphology, but in sulfothermal we can see in here the agglomeration of the particle, and for ultrasound I think it's more separated. This is the what is it called, this N2 adsorption desorption surface area of the UO66, and this is the N2 isotherm, and we can see in here we have some hysteresis loops. From this pore diameter, we can see the increase in the pore volume and mesoporous diameter from UO66 synthesized by ultrasound. And this also from the TGA. I think it's all right for the TGA. We can see in here it's got the same thermal stability. This is the effect of contact time of the methyl orange adsorption and the effect of the concentration. We can see in here the maximum time for adsorption is 60 minutes, and we have in here the maximum adsorption concentration is 300 ppm. And from the adsorption kinetic, we can see in here the UO66 matched with pseudo second order kinetic adsorption. And also from the adsorption isotherm, we can see in here the adsorbent matched with Langmuir isotherm. With the adsorption capacity of UO66 synthesized using ultrasound higher than synthesized by sulfothermal. So the conclusion is that UO66 synthesized by ultrasonication method has been successfully synthesized according to the standard XRD and FTIR diffractogram and spectra. The Qmax 188.7 and also N2 adsorption desorption isotherm reveal in the irregular mesoporous structure with a pore diameter of 8.88. Thank you very much.
Okay, thank you, Dr. Ratna. We still have plenty of time, 4 minutes to discuss. Is there any question regarding to the Dr. Ratna works? Alvin works actually.
Alvin works, yes. To Alvin. We have a pair of Alvin in here.
Well, thank you again to give me an opportunity to ask the question. Wha- are the solvent between the thermal and the ultrasound method same?
Yes.
Oh, same. So, what the plus, what the positive, what the advantage of the
Ultrasound negation.
versus the conventional thermal method?
Yeah, I think I said in the beginning that the sulfothermal we use longer time to get the crystal. Because we need we just put the solvent, I mean the reaction mixture at 120 degrees without any stirring. But in the sonication, I think we can put the sonicator on top of the reaction mixture. And we only need 2 hours to finish the reaction.
Oh, so the advantage is only the crystallization time?
Yeah, and also the I think you can see in here, this ultrasonication produce smaller particle size, which leads to higher surface area.
Oh, okay, thank you.
Okay, thank you. Thank you, Dr. Ratna, for the answer. Okay, we still have time. Anyone? No? So, may I ask, Dr. Ratna?
Yes, of course.
Okay, so
just simple question.
Okay.
Okay.
So actually the table has turned. Usually we ask students to present. Now student ask us
Yes,
to
yes,
present.
that's right. Yeah.
Okay. So Dr. Ratna, your work, you are presenting the kinetic, and it reveals that it follow the pseudo seconds, right?
Okay.
Pseudo second order. So is this mean that the adsorption process is chemically are promoted chemically or physically?
I think the adsorption process is chemically, because if we analyze using FTIR for the adsorbent before and after adsorption, there is a bonding between the adsorbent and also the adsorbate with the methyl orange.
So there is a new peak. After the application, there is a new peak appeared in the material.
Not a new peak, but disappearance. The peak of the methyl orange disappear.
Oh, I see. Okay. Okay, thank you. Okay, thank you. Anyone? We still have 1 minute for one more question. No? Okay, maybe that's wrap for Dr. Ratna Etiati session. So please give her a big applause.
Okay, thank you very much. So give us time to present. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, so maybe that's all for the first afternoon speaker session. And I'm here, Trianda Gunawan, as your moderator. That's wrap for this session, and I will give it back to Dr. Zeni to continue our next speaker. And okay, that's all. I'm sorry for any inconvenience I made during the moderatory. I will give it back to Dr. Zeni. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much for all the speakers and the participants for their interesting talk and also very interesting discussion. So now we are moving on to the next session, which is the talk by our keynote speaker. And this talk will be delivered by Professor Adi Setyapurnomo. And his talk will be directed by our new lecturer, Pak Gracianto. Please welcome. Oh, sorry, my bad. Okay, so our keynote speaker's talk will be directed by Pak Hamdan. So please welcome Pak Hamdan.
Okay, Bismillahirrahmanirrahim. Okay, good afternoon, ladies and gentlemen. Let me take the session now. After this, we will move to invited speaker session. And for this session, will be directed by Professor Adi Setiapurnomo. First, let me introduce Professor Adi Setiapurnomo. Professor Adi Setiapurnomo is head of microbial chemistry department, microbial chemistry laboratory in chemistry department of ITS, and his expertise is in biodegradation and bioremediation. So, Prof. Adi, are you ready? Okay, your time will be 30 minutes, and I will divide into two sessions. 25 minutes for presentation and 5 minutes more to question and answer. Okay, Professor Adi, the time is yours.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Thank you very much for the time. Today I would like to share about our recent study about the biodecolorization of methyl orange by bacteria immobilized on sodium alginate, prophenyl alcohol, and WO66 matrix. My name is Adi Setiapurnomo. I'm from Department of Chemistry, Institute Teknologi 10 November. And in the previous presentation, Bu Ratna also give presentation about the methyl orange. So we have a collaboration with her, especially in the WO66, and we try to combine the absorption and also biodegradation. So because of that, we mix the WO and also the bacteria to increase the ability to dechlorize the methyl orange. This is the outlet of my presentation. Okay, we start with the introduction. So, as we know that the textile industry cannot separate it from the dyes, and one synthetic dyes is azo dyes, especially the methyl orange, and this dye is dangerous for environment and health. Because of that, in our previous study, we use the environment-friendly methods. It's called biodecoloration. So this method combine the degradation and bioabsorptions by using the bacteria. Previously, we used the free cell of the bacteria, the Pseudomonas aeruginosa and Bacillus subtilis. But this, in this study, the degradation is not so high, and also this free cell only can be used one times. So we want to improve the culture with the immobilize the bacteria in the SA and FeVl matrix, sodium arsenate and polyvinyl alginate. And to improve, as I mentioned before, to improve the decolorization, we also add the metal organic framework. So we collaborate with Buratna here to combine the MOF with the bacteria. And so since the methyl orange is very dangerous, we try to develop the effective method by using bacteria and also combine with the MOF, and we immobilize in the matrix. So these methods expected as the effective because cheap, also eco-friendly, and can reusability. And this is scope and limitation. We use the matrix SAPVA-WO66 with the 2 bacteria, P-argonosine and Bacillus, and then makes the ratio of the matrix is 2/4/0.4% weight and volume by volume, and then we use the concentration of methyl orange 50 ppm in the aqueous media, and we use the variation, 3 variation. First is matrix without bacteria as the control, and then matrix with dead bacteria, and finally with the live bacteria. And we also characterize the beads by using FTIR and SEM-ADX. And this is the objective of the research. We synthesize the biocomposites from the immobilized bacteria, the argonosine, also Bacillus subtilis, in the matrix of SAPVA and WO66, and then testing the ability to decolorize the methyl orange, and also the reusability, and finally characterize the beads. And this is the material and method. First, we synthesize the WO66. We prepare the ZR-CLV4 and also S2-BTC, and then mix together. And after that, oven for 24 hours. And then after soak with DMF, we wash with methanol and then dry again. And finally, we got the powder of WO66. And next, bacteria preparation, we prepare the Na agar media and then inoculated the bacteria into the medium and then incubated for 24 hours. And after that, we inoculate the bacteria from the agar into the liquid LB medium. And next, we measure the grow curve by using a spectrophotometer. And for free cell, for decolorization and by free cell, the bacteria inoculated in the LB, and then we separated the cell. In the case of dead bacteria, we kill the bacteria by using autoclave, and after that we also separated by using centrifuge, and then put in the MO solution at the concentration of 50 ppm. And next, we calculate the adsorbent from the supernatant to get the percent decolorization. And this is the bead synthesis. We put sodium alginate, also with PVA and also WO66, and then we mix together. And after that, we sterilize by using autoclave before we add the bacteria. So after that, we mix again with, and then we printed the bead by using syringe into calcium chloride. And after that, we got the beads of SAPVA-WO66 contained with the bacteria cell. And this is the MO decolorization by using beads. So 50 grams of bead was inoculated in the aqueous MO media, and we observe every 24 hours for 10 days. and we separated the cell, and the supernatant was measured at the absorbance at 165 nanometer, and we got the presence decolorization. And this is the result. So first, this is the OEO66 XRD. We got that our synthesized OEO was matched with the previous reported publication by Song that have 3 specific peaks here. And next, we got the white powder of the OEO66. And next, this is about the growth of the bacteria. So this experiment to get the time for harvesting the bacteria. So we got the stationary states here. About both of these bacteria got around 24 hours, both of the bacteria. We choose this 24 hour for the incubation for harvesting bacteria. And this is the visualization of the beads before and after decolorization. This is the bead without the bacteria. And after absorption, the orange MO from the orange color appear in the beads. And next is the bead with dead bacteria, same color. So this is indicated that these 2 beads have a same mechanism, that this is the absorption, only absorption. But in the case of the leaf bacteria beads, the color after decolorization difference with others. So this means that the orange color was disappear. It's indicated that in this bead, the bacteria can degrade the MO. So in the case of beads without and with dead bacteria, it's only absorption, but in the case of leaf bacteria, they also have biodegradation. And this is the supernatant visualization. This is from the bead without bacteria, and this is with dead bacteria. And we can see that the supernatant from bead leaf bacteria, the orange color was a little bit disappear if we compare with the others. Okay. So from the supernatant, we calculate the Okay, from the supernatant we calculate the percentage. We can see that this is the free cell dead bacteria. It's the lowest one, and then the next is free cell leaf bacteria. So the increase the percentage, and then this is the result about the from the immobilization without bacteria, just empty beads. Higher than the free cell, and after we put the dead bacteria, the decolorization little bit increase, because the mycelia of dead bacteria also have ability to absorb the dye, and the highest decolorization appear in the beads with leaf bacteria, about 95%. So this is in the table both of the P. subtilis and also P. arganosa. In the case of the immobilization of leaf bacteria, so the highest one. And next is about the reusability. So we use again the beads. This is the first cycle, high decolorization, but after second cycle, the PA is higher than the BS. The arganosa is higher than BS, but after 3 cycle, the P. arganosa beads slightly decrease, and we stop in the 3 cycle because For the fourth cycle, the bead was broke, so we cannot continue the experiment. And this is the FTR result of beads before and after decolorization. This is from this figure we can see that there is no different spectrum here. So it is indicated that the interaction between beads and MO is physically, not chemically, because there is no new peak here. And also for base subtilis, so also not significantly different. So both of them is physically interaction. And this is the SAM's result. This is only PVASA beads, so the bit rock, and this is after addition of WO66. The MOF is agglomeration here, and this is the mapping. This is from the P. argoniosa beads, and we can see that the beads which contain of bacteria have a more NPGCSNO element, so it's indicated that this element might be from the bacteria cell. Also in B. subtilis, also found the same result. Okay, for conclusion, so we have successfully synthesized the beads which composed of the immobilized bacteria into SAPVA WO66, and from these beads they show the highest decolorization percentage compared with others, and these beads can reuse even P. argoniosa only until second cycle and B. subtilis third cycle, and we will improve this beef to more stronger for reusability, and based on the FTR and SAM characterization that interaction between methyl orange and beads might physical interaction. So this study can indicated that immobilized P. argoniosa and also B. subtilis into the matrix SAPVA WO66 can be effective for decolorization of MO. This is my presentation. Thank you very much.
Okay, thank you, Professor Adi. You still have 3 minutes left? So maybe we will accumulate the time to the question and answer session. Okay, so we have 8 minutes for question and answer session. From participant, any question? Okay.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you, Pak Adit. Please show to figure about compare immobilization dead bacteria and live bacteria.
Yang itu loh gambar itu, yang hasil yang perbandingan ke atas ke atas. Oke,
oke. Di slideshow. Okay, comparison about the immobilization live bacteria, dead bacteria, and immobilization without bacteria. Live bacteria is higher than dead bacteria and without bacteria. But if we compare immobilization dead bacteria and immobilization without bacteria, dead bacteria higher than without bacteria. is did bacteria as contribution to adsorption or the other mechanism? Thank you.
Okay, thank you very much. Yeah, because in this system, in this pits without bacteria, we have a MOF. MOF have a high absorption ability for MO, as mentioned by Bu Ratna. Before that, MOF is very good for absorption. So that's why the absorption, the percentage is high. But after we put the dead, so because in the free cell deaths, they also have a good ability also. So we can see the increasing, but not so high in this site. So I think, yeah, because without is very high, and then when we put the cell bacteria that also have absorption ability, I think the degradation also increase. And I think based on the FTERs, because there is no new glucose function here, so I think the mechanism just physical interaction between the methyl orange and the surface of the bit. So there is no new functional group, I think. So this is answer you as no. Maybe you can, if you. Yeah, absorb. Yeah, absorbs. Because when we see these free cell deaths, they also can absorb. But the color still orange, as I mentioned before here. Mana ya? Oh. Ini. So if we see this figure, this is only beads without bacteria, and this is addition of that cell. Both of them is still orange, so it's just absorption. But if compared with the leaf bacteria, the color was different. So it means that the leaf bacteria and the beads can metabolize the methyl orange, not only absorption. Okay, thank you.
Thank you for the question and answer. Any question again from another participant? Okay, Dr. Edwin.
Thank you, Professor Adi, for your presentation. So I'm just curious, what if we combine two bacteria in the same system? So is it possible to improve the percent decolorization?
Okay, thank you. So especially the P. aeruginosa and also Bacillus subtilis, this is the very strong bacteria for decolorization. So I want to know that which one is more effective if we immobilize in the system. But from this is both of the bacteria have a good system, even this immobilized in the bits. Because both of them is very, very strong. We often use this bacteria for decolorization.
And maybe quick question. So after the methyl orange degraded was degraded by bacteria, and then we give a product. So what's going on from the product? Is it more, how to say, is it toxic than the starting material, or and do you have any idea how to treat the product after degradation?
Okay, so this study is not finished yet. So after that we will try to identify the metabolic products, especially by using LC-MS. We will determine, so we will compare also with the bit with without bacteria, and also that we want to make strong reason that okay, this is the different mechanism between leaf and dead bacteria. So we will identify the metabolite.
Thank you.
Okay, thank you.
Okay, any question again? Okay, no question again. Okay, maybe this is the wrap of our invited speaker session, and thank you for Mr. Adi for the nice and interesting presentation and question and answer session. Okay, give applause for Professor Adi Stoiknomo. Okay, and there is something from committee for Professor Adi, and okay, maybe Dr. Trianda as representative of committee to give the certificate to Professor Adi. Okay, thank you very much, Professor Adi and Dr. Trianda. Okay, for the next, I will give back the time to the MC, Dr. Zeni. Thank you very much.
Yeah, thank you very much for Professor Adi and Pak Hamdan Dwi Rizky. I almost forgot his name again. I deeply apologize. So before we start the next sessions, I would like to announce that the coffee break is ready. So you can help yourself with the coffee, tea, or snacks. So we can have afternoon tea while enjoying the presentation. Okay, the next session is the parallel of presentations, and this session will be directed by Pak Gracianto. Please welcome Pak Gracianto.
Okay, good afternoon everyone. So let's continue for the presentations for the final session today. So the next presenter is Miss Dinia Astera that will present the talk about the effect of the different solvent in synthesis of magnetic zeolite. Please go ahead.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Let me introduce myself. My name is Dinia Astira. I'm a postgraduate student at Department of Chemistry ITS Surabaya. Thank you for moderator who already gave me chance to speak in front of you all. In this opportunity, I would like to present my article entitled Effect of Different Solvents in Synthesis of Fe3O4 Zeolite NaOH Composite Catalyst for the Fenton Catalytic Degradation of Methylene Blue. Here are some outlines. First, introduction, followed by method, result, and discussion, and the last one is conclusion. Based on ASEAN Waste Management Report in 2020, Indonesia is in the first place as waste producer, which 60% of waste content is organic waste. And methylene blue is one of the synthetic organic compounds that cause most textile pollutant. And this toxicity is more than 5 milligram per kilogram, and it have bad impact to environment and mental health if contaminated, and have positive charge 13.82 until 14.47 angstrom in size, and the last one is hard to degrade. Several methods are used to separate MB, such as adsorption, precipitation, and filtration, can only accumulate MB without degrade it and causing secondary pollutant. Therefore, in this study, we use IOP, advanced oxidation process, to degrade the methylene blue. One of the IOPs is Fenton reaction, usually used to degrade organic compounds such as dyes, phenols, antibiotics, and etc. And here we can see the Fenton reaction is the reaction between two types of ions with hydrogen peroxide as oxidizing agent to produce hydroxyl radical and hydroperoxyl radicals. We can see in this reaction there is an alternating reaction, ferrous to ferric and ferric to ferrous, and all of radicals produced here will oxidize the organic compound into carbon dioxide and water or other harmless compound. And why we choose Fenton reaction is because of the cheapness, environmentally friendly, easy to synthesize, and some of material have magnetic properties. Of all iron oxide used for Fenton reaction, we choose Fe3O4, or usually called magnetite, due to it has two types of ion that very beneficial for Fenton reaction, and because of its magnetic properties. The magnetic properties will help us to easily separate the catalyst after the degradation process. Because of the magnetic properties, magnetite is easily to agglomerate, so that the additional of support are needed. Here are some examples of support that ever used: zeolite, activated carbon, carbon nanotube, graphite oxide, and SBA15. And the combination between magnetite and zeolite shows quite good result. We can see here the combination between magnetite and zeolite A, zeolite X, and more than it show the degradation percentage more than 80%. As far as we know, the use of zeolite NaOH as magnetic support haven't been widely studied. Actually, zeolite NaOH have a characteristic that have potential for magnetite support. Here we can see high surface area and porosity, micro and regular pores, acid stable structure, have good absorption and catalytic capacity, high ion potential exchange, and high thermal stability. And these two of the example of the use of zeolite NaOH as catalyst support and show the degradation percentage more than 90%. Therefore, in this study, we synthesized magnetite supported by zeolite NaOH in two different solvents, demineralized water and hydrochloric acid, to see the different characteristics produced. Here are the methodology process. This is the synthesis process of zeolite NaOH divided into 3 steps: seed gel, feedstock, and overall. The overall gel is the combination between seed and feedstock. And here, the way to synthesize seed gel and feedstock are the same, only the mass of compound that added in the reaction is different according to the calculation that we've been done. After age for 24 hours, the seed was mixed to feedstock gel and then stirred until homogeneously gel obtained. It calls overall gel. The overall gel then aged for 24 hours, hydrothermal, wash until neutral, dried overnight, and the last step is calcination at 300 degrees Celsius for 4 hours. And to produce the composite catalyst, in here the magnetite supported by zeolite NaY synthesized by co-precipitation method. We can see here the magnetite precursor was added to hydrochloric acid or demineralized water. Then 0.5 gram of zeolite NaY was mixed when the temperature reached 80 degrees Celsius. Stir for an hour, then ammonium hydroxide was added as precipitate again. Stir for 2 hours, and the precipitate then filtered and washed until neutral. And the last step is dried it at 100 Celsius for 4 hours. And we obtain two different catalysts, FEZ and FEZA. FEZ synthesized with demineralized water, and FEZA synthesized with hydrochloric acid. And this is the result, and the last one is the gradation test against methylene blue. 0.1 gram of catalyst was added at MB solution 20 ppm, then hydrogen peroxide was added as oxidizing agent, mixed in the dark place for 5 minutes, sampling for every 10 minutes to see the different adsorbents and the changes of concentration from the solution. And here are the results of my research. The first one is XRD characterization. Yeah, the green one shows the zeolite NaY diffractogram, and all of the peaks shows the conformity with the GCPDS standard. For the blue one, the zeolite NaY dissolved in hydrochloric acid to see the different peaks obtained, and it's seen all of peaks were decreased compared than zeolite NaY, especially into theta 6 degree, it decreased vividly. For the red one, FEZA, we can see the combination between zeolite diffractogram and magnetite based on GCPDS standard. The magnetite peaks, there are 5 magnetite peaks, and while for the black one, FEZA synthesized with hydrochloric acid just show 2 peaks, indicated the formation of magnetite, and we can conclude from the FEZA diffractogram that the composite catalysts have amorph phase. From the FTIR characterization, these all 5 absorption peaks show the functional group that present in zeolite NaY at wave number 581, indicating the formation type of FeOFe from the formation of magnetite, and that wave number also seen in FEZ and FEZA. And the last one, at 3,400 is OH bond, maybe from the water compound that bond in the surface of catalyst. Next to SEM characterization, in here zeolite NaY, FEZ and FEZA. Zeolite NaY shows smooth surface catalyst. FEZ show the formation of new particle, but the zeolite structure still indicated. And the last one for the FEZ, hydrochloric cause damage to zeolite structure and shows an irregular shape. The last one, for the PSA characterization, in here we can see the average particle size of both catalyst compound. In here FEZ and FEZA. For the FEZ, the average particle size is about 252.6 nanometers, while for the FEZ is about 778 nanometers. So we can see that the particle size of FEZ is 3 times fold than the FEZA. For the MB degradation, the blue one is FEZA synthesis with hydrochloric acid, and the yellow one show the FEZ synthesis with demineralized water. And in here we can see in the 5 first minutes of the reaction, FEZA can reach degradation percentage more than 95%, while after 60 minutes of degradation reaction, only 45% of MB can degrade by FEZ. And for the conclusion, magnetite supported by zeolite NaY was successfully synthesized by co-precipitation method. FEZA can degrade more than 95% in the first 5-minute reaction, and the last one, FEZA can degrade MB more than 2 times fold than FEZ in 60-minute reaction. That's all for me. I'm so sorry for my mistake, and thank you very much for your attention.
Okay, thank you for Ms. Dinia Asteria for the next talk. Is there any question? Okay, please.
Hello Dinia, based on your presentation, you state that the catalyst that synthesis with hydrochloric acid, it's better than FAZ. Is that right? Yeah. Okay. What is the difference of both this catalyst that give a different effect to the degradation of MB?
Okay, thank you for the question. I'll try to answer. Based on the degradation percentage that obtained from both catalysts, in here we can see that the FAZA show better degradation percentage than FEZ that synthesized with demineralized water. There are some reasons. The first one is from the PSA characterization. We can see that the FEZA, the average particle size of FEZA is much lower than the FEZ that synthesized with demineralized water. Yeah, as we know, the lower particle size, it will increase the surface area of the catalyst, and it also will increase the active site from the catalyst, so that the percentage of degradation also increase. And another reason, in here, based on SEM characterization, we can see that the FEZ show more irregular shape than the FEZ, and it's supported by the XRD characterization. In here, for the FEZA, we can conclude that from the diffractogram, FEZA show amorph phase, and as we know, based on recent research, the amorph phase of catalyst will increase the efficiency of catalyst, will increase the degradation percentage due to the availability of active site, so that the degradation percentage is increased. Just that from me.
Okay, thank you very much. Is it clear? Okay. Any other question? Okay, please.
Okay, thank you. So you claim that this is the degradation, yeah?
Yeah.
So in my opinion, if you claim the degradations, what kind the metabolites from the MB? So what the product of the degradation on the MB?
Okay, thank you for the attention, Prof. Adi. Thank you for the question, Prof. Adi. I claim that this is the degradation percentage, maybe not because of the metabolite that will produce, because I'm not yet further characterization. I claim this as degradation percentage because the different percentage that obtained after without and with the additional of hydrogen peroxide. So without the additional of hydrogen peroxide, the percentage of the degradation is much lower than when I add the hydrogen peroxide. So that I claim that this is the degradation.
So if only percentage, maybe we can use removal or something rather than biodegradation. So if degradation is mean we broke the structure into the smaller structure, yeah?
Yeah.
Or maybe less toxic compound like this. So if we cannot prove this, so maybe it's better use removal or something rather than degradation. Okay, thank you.
Thank you very much, Prof. Adi, for your explanation.
Okay, thank you very much. Any other question? So maybe I will ask, there is 1 minute left. So yeah, can you show me the PSA data? Particle size
PSA.
analyzer. So yeah, I think like the result quality is good, but I saw that the PDA is quite high. Did you measure by yourself?
No.
Oh, I think if you where do you measure?
I'm not measured it by myself. It measured by the people who characterize.
I think you can request to change the refractive index, because when you measure the PSA, you can change the refractive index so you can get the beta PDA, because the PDA is quite high, almost 0.5 I think. Okay. That's all my that's my
Thank you
question.
very much.
Okay, give applause for the Miss Dinia Asteria.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, the next presenter is Mr. Afdal Junaidi that will present the work about the carbon dioxide methane gas separation third membrane. And I would like to remind you again that the presentation is about 12 minutes, and then 10 minutes for discussion. Please.
Good afternoon, everyone. My name is Afdal Junaidi. I am from Department of Chemistry, Institute of Technology of 10 November. Institute of Technology 10 November. I am a magister student. Today I would like to present my project. It is about the carbon dioxide methane gas separation performance to polyphenylene sulfide sulfone membrane, a computational study. The outline of this presentation, I would like to introduce, to give you some introduction, molecular simulation methodology, and result discussion, and finally is the conclusion. For the introduction, we know the major causes of the global climate change. It is carbon dioxide and methane, because these gases can be able to trap a heat, resulting to the strong effect of greenhouse gases. It leads to the uncertain climate change. Since pre-industrial era, this carbon dioxide has risen about 50%. It is equal to now is 415 ppm, but for methane gas, it is increased about 167%. It is equal to 1900 ppb. Although this methane is short-lived, but it is equal to 80% more potent than carbon dioxide. So these two gases have directly impact to our weather or our global surface temperature. Right now, the average global surface temperature has reached by 0.9 degrees Celsius, which is really close to the Paris Agreement. It is the temperature rise limit is about 1.5 degrees Celsius. It is really a bad news for us, because the closeness about the temperature. We see that the predominantly produced by human activity that listed in the picture. You know that fossil fuel production and use, agricultural waste, and some other process. So this activity, it is produced the mixture of carbon dioxide and methane. This is really an issue, because this gas is in state of mixture. So membrane technology can be some practical way to separate these gases, because the membrane technology has advantages with its high efficiency, about 90%, easy to scale up because it can be used in industrial scale. So it is energy efficiency about 75%. In this structure, we are gonna propose a polyphenylene sulfide sulfone as a novel membrane for gas separation. And also it is contained the sulfone and sulfide, which is hypothetically could improve the gas performance. For the computational study, I will use the molecular dynamic and grand canonical Monte Carlo prior to conduct the experimental research, because this method are being able to identify transport properties and morphologies of the membrane. Also, the advantages of this method, it is low cost and controllability. For this state, I will use the Biovia Material Studio 2020 by examining the PSF membrane and PPSS membrane to the transport properties and also the morphologies. The first field that I'm going to use, it is about the COMPASS. It stands for the Condensed Phase Optimized Molecular Potential for Atomistic Simulation Studies. So basically, they are going to calculate all of the energy bounded and also energy non-bounded. For the energy non-bounded, as we can see here, it is going to calculate about van der Waals Leonard Jones and all the electrostatic Coulomb by calculating the Ewald summation. So the molecular simulation details, the first step, I'm gonna create the initial structure. This initial structure, it is the PPSS structure. So after that, we're gonna go the step with repeating unit. In this picture is contain about 20 repeating unit of PPSS and constructed the amorphous cell, and then the final equilibrium, as we can see in this picture. It is the final equilibrium of our amorphous cells. Next, the result and the discussion. The result is first, we're going to examine the simulation density from the density fluctuation. From this state, the density fluctuation has reached equilibrium after the 100 picosecond. Because it is the neat polymer, it's not really that hard to get the equilibrium state. By the number of the density, we have the number of density simulation of PSF is 1.22, which is really close to the experimental density. It is 1.24. And the membrane type for PPSS has a density about 1.38. That is really close to the experimental study. It is 1.4. And then for the X-ray diffraction, we have the maximum peak of XRD simulation for PSF. It is 15.65. It is not the right peak for the XRD PSF because the highest peak and XRD in experiment, it is about 70.5 to the 20. But on the PSS membrane, we have the peak is about 18.4. It is really close to the maximum peak of XRD. It is about range 17 and 22. So for the fractional free volume, we can see it's right here. It is the color, it is free space, and the gray one, it is the polymers. By the free volume, we can conclude that fractional free volume of PSF, it is higher than PPSS. So the number of the free volume is 0.11 for the PSF and 0.07 for the PPSS. This data will gonna affect the permeability on this membrane. So for the diffusion coefficient, we're gonna using some method. That final equilibrium cell, we're gonna embed some gas. So the amorphous cell will look like this. It is the polymer and it is gas. We're gonna use the molecular dynamic ensemble NVT by the temperature of room temperature and 2000 picosecond to obtain the MSD diagram. So what for the MSD diagram? MSD diagram is really correlated to the diffusivity coefficient. Okay, we can see here that the PSM membrane has a number of diffusivity higher than PPSS. We can get the diffusivity coefficient by dividing this slope with the 6 because we're using the 3D molecule. And basically, the equation is 1 divided by 2 and times for the dimension that we are used. So the slope by divided by 6, and then we get the diffusivity coefficient. This data also confirm that from the previous fractional free volume, the PPSS have fractional free volume lower, so the permeability is also lower than the PSF. So for the solubility from the PSS in carbon dioxide compared to the carbon dioxide on PSF, it is really much, really big data here. As we can see, by the pressure 1, the number of solubility of PSF, it is 3.68, but for CO2 PPSS has much increased higher, it is 5.47. It is included that the sulfide group in the PPSS can increase the solubility number for this polymer. So basically, it is answer our hypothesis about the sulfide group that can increase the solubility toward the carbon dioxide. But we can see in the methane gas, the solubility for the PSF and PPSS is much closer, but the PSF still have a little bit higher, but it's not really that's so different. So from this picture, we can see that the energy of the sorption for the PSF on the on the carbon dioxide, it is much higher than PPSS. It's confirmed that the carbon dioxide will be soluble late in the PPSS membrane. For the final permeability and selectivity, we can see the graphic in here that selectivity of PSS is much higher than the PSF membrane. It is 24.1 and PSF is 17.17. It's really a big difference from the solubility, from the selectivity data. To the conclusion, we can see the sulfide group have potential to increase the number of solubility toward carbon dioxide by 48.64% compared to the PSF membranes. According to the molecular dynamics simulation data, not only does the PPSS membrane have the potential to be used as gas separation membrane, but the PPSS membrane have also a better performance than the PSF membrane. So that's all for me. Thank you for the attention. So I give it back to the moderator.
Okay, thank you very much for Mr. Afdal Junaidi for the beautiful talk. So any question from the audience? Really, it's about computational study. Okay, let me ask you some questions. So firstly, about the, I don't know, I forgot the number of your slide. It's about like the extracting data. Maybe next before this one, this one. Okay, here you use like 2000 PS, yeah. Right? What is your consideration? Is it enough to extract the data to get the, to check the, to confirm the reliability of your data?
Okay, thanks for the question. My reason, and one and only reason why I choose the 2000 picosecond is about the time we're gonna using to simulate our morphic cells from other project that can be used in 3000 picoseconds, but they're gonna examine the composite membrane. So it is much complicated than my membrane, because this membrane is just knit polymer, so there's not to it's not require some more time, but it's enough to the 2000 PS. I also tried to the 1000 picosecond. The data is not compatible to the experimental data, so I choose the 2000 picosecond.
Yeah, because like I'm wondering actually the next slide, this one, after this one. Next. Can you get?
Yeah.
This one maybe this kind of different, maybe because you only have like 2000 PS, but I'm not sure exactly because you haven't tried for the larger than 2000 PS, right?
Yeah, maybe I can give some more answer about this. This before we gonna examine to the molecular dynamic NVT, we are using the 1000 PS. atau picosecond before we examine that, because we can let this amorphous cell to reach the final state. So we're not technically, I'm get the data from the 2000 picosecond, but actually I'm gonna do it in 3000 picosecond. Yeah, because the amorphous cell is try to oscillate first in 1000 PS, and then after that we're gonna examine that from the different time. It's double in time, I guess. So that's my answer.
Okay, I see. Got it.
Yeah.
Okay. Any other question? No? Oh, yes, please. Udah.
Okay, thank you Juna and Pak Gracianto for allowing me to ask. Okay, Juna, you are studying computational study about the PSF and PPSS. Actually, I'm curious why you choose this kind of a sulfonated membrane, base membrane for the case separation. And if we look at the PPSS, it is like I think it's a brand new for the case separation. Like the synthesis is not so familiar. What is your next goal after you got some confirmation from your work here? Thank you.
Okay, thanks for the question to Dr. Trianda. I will answer the first question first. It is about why I choose the polyphenylene sulfide sulfone. Basically, the gas separation using the sulfone membrane is it is well known because PSF membrane have also good mechanical and thermal stability. So if you search in the project about the PSF membrane for gas separation, especially for the carbon dioxide and methane, it is a lot of them. But why I choose the sulfone? It is because the sulfone have ability to increase the solubility toward carbon dioxide than the methane. So from other study, the sulfide group also have more better performance than PSF. So basically I just combine these groups through this functional group, sulfone and sulfide. And the better news, it is existing polymers, but it is so hard to find it in commercial ways, so we have to synthesize it. But before I do that process, I want to examine this by computational study first. So I know that what I'm gonna synthesize, it is gonna have better performance than the other polymers. So basically this answer from the number 2 questions. Also, the next goal is much goal that I want to pursue to this computational study because I'm new to that, but I have the ability or the enthusiasm more than I know before, because yeah, I'm gonna examine my polymer to the computational study, and I'm also gonna do experimental research. So that's all my answer.
Okay, thank you very much for Mr. Afdal Junedi. Let's give the applause for.
Okay, thanks you all.
Thank you, sir. Okay, let's move to the next presenter, Mr. Omaria Abdullah, that will present about synthesis and characterization of microcrystalline cellulose. Please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thanks for the opportunity and good afternoon everyone. Let me introduce myself. My name is Romario Abdullah and I'm a postgraduate student at Chemistry Department, Institut Teknologi 10 November. I will present the result of my research with the title Synthesis and Characterization of Microcrystalline Cellulose, or MCC, from other hycin, Eucornia crassipes, and Sangonwood albizia canadensis. And my point of discussion in this presentation is the introduction, method, result, and discussion, and is the conclusion. Cellulose is a natural biopolymer with the largest availability in nature, with amounts ranging 1 billion to 1.5 trillion tons per year. The abundance of natural cellulose in nature makes it a renewable material. However, the use of a natural cellulose is still low when compared to commercial cellulose. For this reason, it's necessary to develop the use of natural cellulose. Microcrystalline cellulose, or MCC, is a material that can be obtained by the depolymerization of cellulose. MCC is widely used in pharmaceutical, food, and cosmetic industrial sectors because its properties that can act as a texturizer and emulsifier. The high demand of MCC in various industrial fields encourage efforts to produce more economical MCC by utilizing lignocellulosic biomass. Some of the lignocellulosic that can be used as a source of MCC are water hyacinth, sangonwood, bagasse, corn cobs, rice husk, and cotton waste. Each type, lignocellulosic biomass has different characteristics. So, when used as a source to produce MCC with different characteristics, water hyacinth and sangonwood are abundant source in nature. Besides being abundant, water hyacinth and sangonwood have high cellulose content and low lignin content. Water hyacinth content is 57% cellulose and 4% lignin, and as well as sangonwood content is 60% cellulose and 9% lignin. For this reason, in this study, MCC synthesis was carried out from water hyacinth and sangonwood to see the different characteristics produced. And the method in this research consisted of the cellulose isolation process and the conversion cellulose to MCC. Cellulose isolation process consists of the pretreatment process, the waxing, the lignification, and bleaching. In the first stage is pretreatment process, where the hyacinth and sangonwood biomass were cut into the small pieces and then dried in sun for 2 days, and then mashed and sieved to produce a fine powder of water hyacinth and sangonwood. And the second stage is the waxing. This process was carried out to reduce wax compound in water hyacinth and sangonwood. Each 10 grams of biomass was extracted using soclitation method with a mixture toluene and ethanol solvent, and then the raffinate was dried to evaporate solvent, and the raffinate was washed and filtered, then dried. And the next stage is the lignification. At this stage, the dewax product was carried out to reduce lignin compound using 5% sodium hydroxide, and the resulting pulp was washed and neutralized, then dried. And the next stage is bleaching. At this stage, the delignified product by dissolved with a mixture 5% sodium hydroxide and 3% hydrogen peroxide. This process is done 3 times. And then the resulting pulp was washed and neutralized, then dried. And the next stage is synthesis of MCC from cellulose. This process was carried out by dissolving cellulose in 5% hydrochloric acid and stirring for 6 hours at 65 degrees Celsius, and the resulting pulp was washed and neutralized then dried, so that MCC is produced from hyacinth and sengon wood. And the result of the MCC synthesis, the percentage of cellulose and MCC yield from sengon wood is higher than hyacinth. And the next result, the result of the XRD analysis, and show that of both biomass from MCC from hyacinth and sengon wood, the show typical peak of MCC at 2 theta, 15 until 16 degree, and 22 until 22.5 degree and 34 degree with crystal plane 110, 200, and 040 respectively, and indicates the MCC crystallinity index for hyacinth is higher than sengon wood. And the result of the FTIR analysis and show that MCC from hyacinth and sengon wood show a typical absorption peak from MCC, and the absorption peak at wave number 3,400 until 3,504 indicates the stretching of the OH group on MCC, and the absorption peak at wave number 2,902 until 3,922 indicates the CH stretching fibration, and the absorption peak at wave number 1,627 until 1,639 and indicates the presence of the carbonyl bone, and the absorption peak at wave number 1,055 until 1,060 indicates the stretching of the COC bone. The result of the TGA analysis, show exhibit three-stage decomposition, and the first stage at 50 until 100 degrees Celsius because of water removal in MCC, and the second decomposition occurs at 200 until 340 degrees Celsius because of cellulose degradation, and the oxidation process on carbon residue happen at 350 until 600 degrees Celsius. So this indicates MCC from hyacinth has better thermal stability than MCC from sengon wood. And the resulting of the SEM analysis and has different characteristic MCC from hyacinth and sengon wood. The hyacinth MCC show irregular shape, meanwhile the sengon wood MCC show cylindrical and stem shape. The conclusion in this research, and the first conclusion is there are differences between MCC synthesized from wood and non-wood lignocellulosic biomass, especially whether hyacinth and sengon wood, and the percentage of cellulose and MCC yield from sengon wood is higher than whether hyacinth. And the last conclusion is MCC crystallinity index of whether hyacinth is higher than sengon wood. Okay, that's all. Thanks your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much for the interesting talk. So, any question from the audience? Okay, please.
Assalamualaikum warahmatullahi wabarakatuh. I am Dinia from ITS. I will ask you a question. Based on the explanation before, you stated that the thermal stability of water hyacinth is better than sengon wood. Is there any different characteristic from both of the material and cause the increasing of the thermal stability?
Okay, thank you for your question. In MCC from water hyacinth has better thermal stability than MCC from sengon wood. This is indicated by temperature the composition cellulose. For MC from the water hyacinth MCC is higher than the sengon wood MCC. Jadi it's known MCC from water hyacinth undergoes cellulose degradation at temperature 215 degrees Celsius. Meanwhile, the sengon wood MCC in the cellulose degradation in 210 degrees Celsius. So MCC from water hyacinth has better thermal stability than MCC from sengon wood. Thank you.
Is it clear?
So this is due to the decomposition of cellulose. So the sengon wood the sengon wood temperature for degradation is lower than water hyacinth, so that the thermal stability is increased. Is that true?
Okay. Thank you very much for the question and the answer. So any question? Any other question? Okay, please.
Okay, thank you for the chance. I would like to ask about the MCC isolation that you mentioned about the MCC isolation. I highlighted that you use long isolation process. Okay, is there any breakthrough for your isolation process that simple way to isolation, or is it what is it called? Do you know it is very hard to get a simple way? Is there any simple way to get a good MCC characteristic? Is that and then is there any addition or additive that you have, or maybe here base and acid hydrolysis? In your presentation, you conducted with base isolation using sodium hydroxide. That is there any difference if you substitute with maybe hydrochloric acid or something else with using acid? Okay, thank you.
Okay, thank you for your question. The method in this research is long process because to process the waxing, the wash carried out to reduce wax compound and the delignification process to reduce lignin compounds in biomass, and the bleaching process and to remove our lignin compounds in biomass, and
how about if you change out substitute with other like again, like for example not yes. This one. No, this one, I think. Oh, the previous one.
Hydrochloric acid.
The previous. One more slide, please. Okay, this one. You use sodium hydroxide 5%. This is like base condition. How about like you change with sodium chloride or acid condition, something like that, right? Okay. Only acid, yes. How about like in acid condition, is it the reaction still occur or microcrystalline still can be obtained, something like that?
And I know if use acid in this process, in cellulose will degradation in acid, but in alkali, in base, cellulose is not degradation. So I use base in this study.
Basic condition is more preferable, I think, right? Okay. Okay. Okay, thank you very much for the question. And give you one more applause for Mr. Omaria Abdullah. Okay, take a seat, please.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Oh, waalaikumsalam warahmatullahi wabarakatuh. Okay, let's move to the two last presenter. The next presenter is Mrs. Nurlina, that present about influence of calcination temperature of kaolin kapkala on geopolymer. Yeah, please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First, I would like to introduce myself. My name is Nurlina. I am a student of Institute Teknologi of 10 November, Surabaya. In this afternoon, I would like to present influence of calcination temperature of kaolin kapkala on the compressive strength of geopolymer. This is outlined in my presentation today. I will start with the introduction and explain the methodology and result and discussion, and end with the conclusion. According to the International Union of Pure Applied Chemistry, geopolymer is a polysilicate. Geopolymer is a ceramic-like, but it can synthesize at temperature below 100 degrees Celsius. Geopolymer also have a heat-resistant material refractory and high compressive strength, chemical erosion resistant to acid and base attack. And this material is more durable compared with cement. Since introduced in 1979, this material have several applications, like for geotechnical field, absorption, membrane, binders, catalyst, thermal energy storage, and drug delivery system. Several raw materials that can be used to make a form geopolymer, like fly ash, metakaolin, red mud, and demolition construction, and others. Actually, making geopolymer from the fly ash is give us several benefits, because it using hazardous waste. But if we look the characteristic of fly ash, it contain several metals like mercury, lead, or chromium that can be leached by acid or base. But in the metakaolin, because metakaolin is from kaolin that controlled by calcination and no heavy metal content, so maybe it's more safe than fly ash. Several studies that have make geopolymer from metakaolin that with the different thermal treatment, calcination temperature, and there is a compressive strength value of the several research. The calcination temperature of kaolin it's from 450 until 900 degree of Celsius. So the aim of this study is to determine the most suitable kaolinite clay calcination temperature for the production of geopolymer with highest compressive strength. Kaolin cap kala was treated at the following temperature: 700, 750, and 800 degree of Celsius. And knowledge of the properties of the geopolymer based on kaolin cap kala as a raw material will allow a sustainable use of natural resources in many applications. So for the first preparation of kaolin is sifted to the 100 mass and calcined at 750 and 800 degree of Celsius for 2 hours. And we use alkali mixture from consists of natrium hydroxide, sodium hydroxide, and sodium silicate in a weight ratio of 1 to 1 to 1.124. And then we synthesize geopolymer. At the first, we do alkalination process. We mix metakaolin and the alkaline mixture, and then the paste casting in the mold. There is this mold for the setting time test, and this mold to form the geopolymer that we're gonna test the compressive strength, the geopolymer. And then we have to setting time and compressive strength test. Okay, firstly, this is the characterization of the kaolin and metakaolin with the variation of the calcination. First of all, we can see there is a disappear of several peak of the metakaolin from kaolin, like hydroxide, and then this peak at 1031 shift to the highest wave number. It can be concluded that the change the change of the path of kaolin to metakaolin. When the dehydroxylation process, the the 6 coordination of Al is convert to the 4 coordination of Al. So the shift of the wave number evidence to the change of Al coordinated. And then if we see in the X-ray diffraction, we can see in the metakaolin there's no kaolinate phase in the metakaolin because the kaolinate phase is changed to the metakaolin, but there is a quartz in all the diffractogram. And if we see the scanning electron microscopy, the morphology of metakaolin is changed from the kaolin because there is a change of structure in kaolin to the metakaolin. And if we see the spectra of FTIR spectra to the metakaolin and geopolymer, hydroxyl groups appearance in this spectra because the content of water in the process to make geopolymer, to form geopolymer. And then we can see the peak in the wave number of 1093 shift to the lower wave number. It because metakaolin have a ratio Se to Al 1 to 1, but in the geopolymer the ratio of Se to Al increase to the 2 to 1. So the shift of this peak give evidence that a geopolymer form in this research. But if we see the X-ray diffractogram, there is no significant change in the metakaolin and geopolymer because a geopolymer already have a amorphous phase like metakaolin. But we can see there is a peak of quartz. It means that the quartz does not dissolution perfectly in the alkali medium. And if we insert this picture, we can see that the shift of amorphous hum in metakaolin, the amorphous hum in the 2 theta of 2 theta 20 to 40 degree, but in the geopolymer shift to the in the metakaolin 18 to the 30, but it shift to the highest 2 theta degree 20 to 40. It typically show the geopolymerization diffractogram. Increasing the calcination temperature cause a faster setting time and the increase in compressive strength. This is associated with a decrease in crystallinity in the amorphization of kaolin. As I mentioned before, if we assume that metakaolin have if we assume that kaolinite in the kaolinite is 100%, and if we calculate 5 peaks in the geopolymer and we compare with the peak of the kaolin, we can get the geopolymer that calcine in the 800 degrees have a lower crystallinity than the others. So because the metakaolin, the kaolin that calcine in 800 degree of Celsius have a lower crystallinity, so it so the metakaolin it's more soluble in the alkaline mixture, so resulted the highest compressive strength and the faster setting time.
Sorry, you have 2 minutes remaining.
Okay. And the last is conclusion. The temperature calcination of kaolin cap kala influence the setting time and the compressive strength of geopolymer, and the highest compressive strength is 32 megapascal. If we do benchmarking with the with the previous study, this compressive strength is same with the previous study, but in the previous study, calcination process is due in the longer time than in this research. I think that's all that I want to share.
Okay.
Thank you.
Oh, thank you very much. Give the applause first. Okay. Yeah, actually time is over, but I want to give one opportunity to, yeah, please.
Thank you for the opportunity. I will ask you a question. If I didn't wrong, you synthesized the geopolymer in 3 different temperature. And after you synthesize, what is the function of the geopolymer, and maybe what is your further plan for your future research? Just that.
Thank you for your question. Actually, this geopolymer is Actually, this geopolymer will continue to synthesis membrane geopolymer for filtration. When we make a membrane geopolymer, we have to thin membrane, but also want to have a highest compressive strength of membrane. So in this research, I do some optimization to get the highest compressive strength, and then that geopolymer continue to make a geopolymer membrane.
This is kind of the initial investigation, right?
Yes.
Okay. Okay. Thank you very much. Give one more applause to Miss Nurina.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, let's move to the final presenter for this session, Miss Farhanah Novita. That, yeah, she will present about the nano emulsion of the cytospheric on mud cake. Yeah, time is yours. You can use the stage. Yeah.
Assalamualaikum warahmatullahi wabarakatuh. Okay, good afternoon everyone, ladies and gentlemen, committee, invited speaker and audience. Let me introduce myself. My name is Farhana Nurfitro. And before I start my presentation, I will to say thank you to Bu Zahra that give me this opportunity that can make me as a presenter in Isoc 20 and 22. Okay, then my research is the title Citrus Peel Extract Nano-Emulsion using Soy Protein Isolate or SPI and Maltodextrin or MD as additive to mud cakes. Okay, this is the main content of this presentation. There are introduction, procedure, result and discussion, and then the last is conclusion. Okay, first, this is the background of this research. We start with the citrus. As we know that Indonesia is the number 8 in the world as the biggest producer of citrus, and at the same time Indonesia can produce about 2 billion in every year. And however, at the same time, there is the result of the citrus is give the citrus peel with based on the research that citrus peel have a bioactive compound. There are linoid and flavonoid. We point the flavonoid. The flavonoid is have biological activity. Can be antioxidant, anti-inflammatory, and then the flavonoid can be have potential to be used as a additive, food additive. Okay, the flavonoid can be we can use flavonoid in the citrus peel that we use extraction method, but the weakness is citrus peel have fragile, volatile, and the taste is a little bit bitter. So we try to do encapsulation with method nano-emulsion with maltodextrin and SPI to cover the extract or active compound, the flavonoid, to make this little bit maybe sweet. And then we use this extract to be food additive at the mud cake. Then there is food fortification. Okay, so there are the problem of this research is what is the optimum heating temperature to drying citrus peel to extract the content of biological compound. There are total phenolic and flavonoid and antioxidant activity in citrus peel. And the second is what is the effect adding citrus peel extract nano-emulsion as a natural food additive in mud cake. Then aim of the research is to determine the optimum temperature condition of the extract of bioactive compound. There are phenolic and flavonoid and antioxidant activity of citrus peel extract. Then the second is to determine the effect of variation in the additional of citrus peel extract nano-emulsion. There are SPI, MD, and SPI plus MD in the mud cake of the content of bioactive compound, antioxidant activity, resistant the mold, and the organoleptic properties of the mud cake, which include color, aroma, texture, and the taste. So we next to the procedure. Okay, we start the citrus peel. We preparing the citrus peel and then do extraction with variation of drying, and we got the citrus peel extract with maceration method. Then we characterization this result as the phenolic content, flavonoid content, and antioxidant activity. The result of the three characterization, we use the optimum result. Then when we got the optimum, we use to encapsulation with method nano-emulsion and maltodextrin and SPI. The next step is after encapsulation, we use this material to
fortification to the mud cake. Then after that we characterization again with phenolic content, flavonoid, and the antioxidant activity. Okay. At the same time, we observation the mud cake to organoleptic test and the malt growth. Okay, then we cut the result. Okay, so this is the result and discussion. The first one is phenolic and flavonoid content in citrus peel extract. We got the optimum at the 19 degrees Celsius. I can show the graphic. There are optimum at the 19 degrees better than another variation. And next is the total phenolic content. We got the optimum at same, that's 90 degrees Celsius. Okay, true. So antioxidant activity is citrus peel extract. We got at 90 degrees Celsius. There are at the 90 degrees Celsius we got the optimum value. There are 86. Okay, the next is result of the mud cake. We try to characterization again with phenolic and flavonoid content, and the result optimum is at the variation KL6. Or we can see the mud cake variation. There are KL0 is control, KL1 is with extract, KL2 is with SPI, KL3 with MD and sonication 5 minutes, KL4 is with MD and sonication 10 minutes, KL5 is with SPI, MD and sonication in 5 minutes, and KL6 is with SPI, MD and sonication in 10 minutes. Or we can see the graph in the total phenolic content is optimum at KL6. Flavonoid content is optimum at KL6 too. And the antioxidant activity optimum and KL6. Or that is the graph. Cool. So let's next the organoleptic test. In the organoleptic result, mud cake and KL1, the taste has a little bitter, better than 5 another variation, because at the KL1 is only with citrus peel extract. And the second is about texture. Mud cake with SPI have a texture more chewy, better than another. And the aroma, mud cake K1 with extract of citrus peel have a strong citrus aroma, and the color of K1 has a color more brown, better than other. So that is the malt grow. The result of observation found that all variation is of the mud cake began to grow malt on the second day. If we look closely at the picture, there are a white and black mold that grow in the mud cake. Okay, so the conclusion is the first, the optimum drying time of citrus peel extract was 90 degrees Celsius with a total phenolic content of that, and dried citrus peel, total flavonoid content is that, and the dried citrus peel and antioxidant activity. And the second is the highest content of phenolic, flavonoid, and antioxidant activity was found in the mud cake with addition of SPI, that nano-emulsed with citrus peel extract, and MD, sonication 10 minutes at the or variation KL6. And the third is the result of the organoleptic test showed that the panelists prefer the taste of the mud cake without adding citrus peel extract. However, but the assessment of the aroma, texture, and color, citrus peel extract was preferable. Okay, thank you. That's all. And
okay, let's give the applause for the Miss Fahau Sorry, Farhana Novita. Okay, so we have 2 minutes remaining for the discussion. So, is there any question? Okay, yes, please. Please wait. Yeah, you can ask after that. After, yeah.
Yeah, thank you for your nice talk. So, so it seems like when you show on the graph, so the optimized condition is 90 degrees Celsius to obtain the flavonoid content, right? Sorry. Yeah, can you hear me? Okay. Yeah, so it seems like from the graph, in the optimized condition is 90 degrees Celsius to obtain the total flavonoid content. But when you use much higher temperature, such as 100, then it decreases. It seems like the stability of compounds, right? So when you apply that doing the fortification on your mud cake, so do you consider about the the stability of your compound in the cake itself? Yeah, during preparation. Yeah. And how about have you ever checked the antioxidant activity of the cake that combined already with the nano encapsulation?
Okay, that's what I got from
Edwin.
Okay, the result of maybe flavonoid content and phenolic content, right?
Yep.
At the 19 degrees. So, how to say, at 90 degrees is where I say optimum, because optimum condition is what I mean in here is the best result of produce better than the variation and 60, 70, 80, and 100. And when we prepare the mud cake, is that will something different with phenolic and flavonoid. So we try to test the mud cake to phenolic and flavonoid content. There maybe when we prepare the mud cake, we try to keep the temperature at the not higher than 90 degrees. So the phenolic and the flavonoid content at the mud cake it not broken at when we preparing the mud cake.
I'm sorry. So what's KL 0 to 6?
Sorry.
Yeah.
There are a variation of at the mud cake. There are control with extract, SPI, MD, and how we preparing the mud cake and adding the encapsulation.
Okay, so the preparation is to avoid the high temperature to get the kind of the mixture of mud cake and encapsulation of your compound, your flavonoid, right? I'm sorry. So I mean, basically, you prepare the mud cake with lower temperature after combining with the encapsulated flavonoid.
We keep the temperature at the not higher and 90 degrees.
Okay, so maybe my last question is how do you differentiate, or how you differentiate, how to say? So during the extraction of metabolites from the orange peel, so how do you discriminate flavonoid from the other compound? Because sometimes I'm just consider about the toxicity of another compound looks like limonoid, right? So how you discriminate that to get only the major component?
Okay, maybe I try to answer. Maybe sorry if any mistake in my answer. So the flavonoid is part of phenolic content that as I know, when we calculate flavonoid, we use some reagent, and sorry, I forget what the reagent, that so we can know the total flavonoid at the mud cake or at the citrus peel. But you say you asked too about how if there are toxic component at the citrus. Okay, wait. Okay, maybe a toxic content at the peel extract. Before we start our research, we see previous research about this too. Maybe the compound at the citrus peel extract, and we try to identify how to make the toxic compound at the citrus peel extract can say hilang gitu ya. Yeah. And because of that, we choose this method to make the citrus peel extract that maybe not that toxic.
Okay, maybe you can discuss later when you have a seat. Okay. Okay, thank you very much for the question and the answer. So, yeah, take a seat.
Okay.
Oh, yes, please.
Okay, thank you all for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, so this is the end of this session. So I would like to thanks for all presenter and also for the participant here. And yeah, on behalf of the Isoc committee, we very appreciate it. Okay, I will give the time to moderator, please, Dr. Zeni.
Okay, thank you very much for all the participants and the speakers or the presenters. Okay, before we move on to the next session, I am sorry to say that we have to postpone again because we have a prayer break. Yeah, so 15 minutes. So what time is it? Sorry. So we will be back here at perhaps 4:35. Yeah. So please come back at 4:45, and after that we will continue to the next session. Thank you very much.
Do you ever wonder what makes a life-changing history? right, a solid mission of the visionaries. It was Dr. Anka and his colleagues' mission to accelerate technology development. Through the establishment of Institute Technology 10 November, has encouraged ITS students to take important roles in both local and global communities. CEOs, professors, entrepreneurs, and yes, another history maker. These successful alumni were trained in a healthy learning environment that was equipped with various supporting facilities. From vocation to marine technology, all faculties and departments of ITS were formed to be the best place to learn science, technology, and design. 7 faculties and 1 interdisciplinary school. Scientists, Faculty of Science and Data Analytics. MARTech, Faculty of Marine Technology. INSYS, Faculty of Industrial Technology and Systems Engineering. Electex, Faculty of Intelligent Electrical and Informatics Technology. CivPlan, Faculty of Civil, Planning, and Geoengineering. CreateBiz, Faculty of Creative Design and Digital Business. Vocation, Faculty of Vocation. And Interdisciplinary School of Management and Technology. Recognized as one of the top best-ranked institutes doesn't mean the finish line for ITS. To gain greater international recognition, ITS launched International Undergraduate Program. Students can get wider international exposure through 20 study programs they can apply. The chances are also open for professors from all over the world to teach and conduct research at ITS. These opportunities have made international joint research and other international activities successfully performed. Like IUP, students and lecturers from other programs have also contributed to the ITS achievements. Appreciations earned exemplify Institute's excellent performance. But technology and academic excellence is not the only goal of the Institute. Students are guided to apply their knowledge for the welfare of society. Because to note a new life-changing history, technology must advance humanity. ITS, Institute Technology, 10 November.
Surabaya, the provincial capital of East Java, is the second largest city in Indonesia. This city has a huge number of diversities among the people, cultures, and ways of living. Surabaya has been acknowledged for its green public open spaces. It also has successfully equalized the development between build-up area and green area that makes Surabaya a livable city for all.
I see Surabaya as a great city with amazing people.
Living pace here is quite slow, so you don't feel the rush of living in the city.
It's also a good place to travel around. I mean, in bus you can go in many places, or taking train on Java.
It makes me so to be in peace, so I think that is a good place for me to stay.
Surabaya is also known as the City of Heroes because of its role in Indonesian struggle for independence. Moreover, Surabaya nowadays has already become the center of businesses, commerce, industries, and education in Indonesia. One of the pioneers of education in Surabaya is the Institute Teknologi Sepuluna Pemba, better known as ITS. ITS has 3 campuses in Surabaya. ITS Sukolilo as main campus. ITS Manyar its campus vocational study of civil infrastructure engineering. ITS Joko Aminoto as campus for Master of Management Technology. Occupying a large area of 180 hectares as its main campus. ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, 10 faculties, and 38 departments. ITS has various fields of study, faculties, and strategic study program which are the center of excellence. Faculty of Industrial Technology, Faculty of Marine Technology, Faculty of Electrical Technology, Faculty of Civil, Environmental, and Geoengineering, Faculty of Business and Management Technology, Faculty of Architecture, Design and Planning, Faculty of Information and Communication Technology, Faculty of Mathematics, Computing and Data Science, Faculty of Natural Science, Faculty of Vocational Studies. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS also has more than 130 full-time international students and 400 international student mobility short program, K&B program, student exchange, and another programs.
I work with many projects and many assignments, so it's helped me to improve my personal skill and also for communication skill.
There are many things that we have to fulfill, and ITS has been helping me to improve this kind of things. Beside my hard skill, I also have been able to develop my soft skill, which is important for nowadays leadership.
Also with ITS, I had a lot of opportunities to join different events for free, like the Rujak Connect Festival, which was the cooking event, something. Yeah, this is like kind of opportunities that you don't have every day, and it's funny to take part for once. Or yeah, it's nice.
ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS. ITS Central Library is in a 6-story building, with total building area 9,000 meters square. This library, more than 121,000 printed textbooks, more than 10,000 e-books, 10,000 audio-visual data, and 18,000 digital library collections. Besides providing students with the books, the library also provides students with comfort study area, like discussion area, hotspot cafe, computer rent, multi-purposes room, and Indonesia Development Information Services, which connect to the World Bank database. Research and innovation of ITS are geared towards addressing global challenges. Therefore, creative inventions are increasingly being produced by ITS researchers.
If people are talking about logistics and supply chain in Indonesia, we publish papers, we are doing research on transportation modeling, we are doing research on warehouse modeling, and we also do a lot of networking with industries, with companies, and our research has been used in many companies in Indonesia.
We know that Indonesia is the second biggest biodiversity in the world after Brazil, but I think if we combine with our sea area, Indonesia will be the biggest biodiversity in the world. And we do believe that if we perform science of nature and how to utilize it, it is very big opportunity for the treatment of some disease, not only for Indonesian people, but also for the world.
Considering the fact that Indonesia has unique climate characteristics, and also Indonesia is also very well known as the laboratory of disaster, therefore a lot of issues, a lot of problems have to be solved. But this is a challenge for us. We cannot work alone. We need to work interdisciplinary, which involve expert, local or internationally. Therefore, we invite all of you to work here with us in ITS. We expect that our contribution and our work will bring ITS as the Center for Excellence in Disaster in Indonesia.
ITS has more than 180 laboratories spread over 10 faculties. The laboratory is used to support faculty and students' research and provides the opportunity to collaborate on big projects and create impactful research programs.
institution, I think ITS has a lot in terms of giving an ideas and spirit, and in the same time self-confidence to our country about how capable we are.
ITS, within the next 5 years, it would be a research and innovative university. It means that ITS will be playing a big role in the region, especially in Asia. For the next long term, in 2045, ITS would be an entrepreneurial university, means that it having a big role playing in the global world.
So, come and join us.
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 Come and join with us, ITS.
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 The University of Heroes.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart Eco Campus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web and mobile site. Smart Eco Campus is also implemented by building an eco farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area. Various sports facilities, indoor and outdoor fields. A medical center as health service unit. Language and culture center to boost English competence. ITS library. And several co-working spaces as a learning resource center. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory, that has pioneered research, development and education, and already successfully winning national, regional and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis and training services. Material and
Good afternoon, ladies and gentlemen. Thank you very much for staying with us until this. Okay, so for the next sessions is the presentations from the sponsor. The first presentation will be the Organization for Women in Science for the Developing World in Indonesian chapter by Dr. Sri Fatmawati. Please welcome Dr. Sri Fatmawati.
Okay, thank you. First of all, I'd like to express our sincere gratitude to all of the participants for Isoc 2022. And in this opportunity, I also would like to convey our thanks to the committee of Isoc for this collaboration between OS and Department of Chemistry, and also all of the partners in this seminar. Okay, let me introduce you about the Organization for Women in Science for the Developing World, or we call it OWSD or OS, Indonesian National Chapter. Sorry. So OS basically is international non-profit organizations which is based in the office of the World Academy of Science in Trieste, in Italy, one of a unit from the UNESCO program. And the aim of these organizations is actually to increase women's participation in developing countries in scientific and technological research, teaching, and also leadership. And talking about this is our history. That in 2018, actually, we tried to establish this chapter. And at that time, Professor Johnny Hermana is rector of ITS, agreed, and we finally based in ITS as host institution of OS Indonesian National Chapter. So we have a logo here. We have like women who carry items, and also we have the garter wings, peacock, and also the lotus. So this is the behind the history or the symbol of our logo, and that all of the logo have representative. One of our goals is try to express not only about the science but also about the culture of Indonesia. And this is our objective, how the participation of Indonesian female scientists, achievement of female scientists, collaboration, supporting the role of women, and also how we can empowering each others. And through this objective, we have executive committee. This is last year, actually. We have the updated one, sorry. And we have the division, actually. We have the divisions, yeah. Later I will explain you more detail about this. So, as you can see here, that the growth of members in Indonesia is quite significant compared before we have the national chapters. So you can see the significance growth of not only about the members but also how diverse we are. So right now in Indonesia we have actually more than 200 members, yeah. But you know, after pandemic COVID, we have passed away members and also members who are inactive. And our members came from 80 institutions, so you can imagine how big we are, and also from 22 provinces in Indonesia. So this is the picture. This is our profile, member profile in Indonesia. So not only from the Java, you know, if you talk about Indonesia, mostly come from Java, but in this organization we have from Aceh to Papua, yeah, just like our song, yeah, dari Sabang sampai Merauke. Okay, so here you can see the province and also the institutions that we have from Aceh, Lampung, Bengkulu, Sumatera Selatan, Sumatera Barat,
Riau, and also we have Jawa Timur, of course, yeah, Banten, Jawa Barat, DKI Jakarta, Bali, Nusa Tenggara Timur, Yogyakarta, Jawa Tengah, yeah, Jawa Timur. We have from this, yeah, and we also have Kalimantan, Barat, Timur, and Utara. Sulawesi Tenggara, Sulawesi Selatan, Sulawesi Utara, and also we have from Maluku and Papua Barat. So, what is actually activities? I will show you that we perform conference, seminar, and also congress and annual meetings. You can see this is from 2018 until 2019 before pandemic, and we have also, we have also charity. And we also have programs, OS goes to school, scientist goes to school, training for students, etc. And yeah, and pandemic hit us, yeah. During pandemic, we still have, you know, online activities like webinars and also annual meetings. This is during pandemic, yeah, you can see, and we also have a talk series, yeah, and also workshop. And this year, actually, we also the main program that we have, mostly talk series, and also together with the other institution try to perform the seminar and also workshop. And also we have a Kartini Modern Fest, yeah, talk show developing science, etc. Together with the ITS, Advancing Humanities, Advancing Humanity. And the last program that we have is a collaboration with L'Oréal UNESCO for Women in Science. We have a program namely Stop the Drop, yeah. And yeah, this happened in June 2020 in ITS campus. And actually, today we also have a second Congress and annual meeting of OS Indonesia. And yeah, this is the Minister of Social Affairs, yeah, together with others, yeah, from Deputy of Gender Equality. And I think this is the most important things for you, how to join, become a members. So this is the membership categories. So we have two kind of memberships, full member or affiliate member. So if you, I think all of you here is, yeah, can be a full member because, you know, the requirement to be a members have the minimum master degree, yeah. And other things, yeah, we have the requirement here. You can see, yeah, women, and yeah, Master of Doctoral in Science and Social Science and live in Indonesia, or yeah, actually we also have some members that right now pursuing yeah, their educations abroad, but before they, yeah, they live in Indonesia actually. So. So the benefit actually for this organization, we have no fee, no membership fee. So everyone you can join with us and have the, you know, excellence circle, yeah, positive vibes, and support each other, and also you can also share your ideas, your leadership, and also you can collaborate with others women scientists in Indonesia. And okay, right now you also can directly, yeah, it's very simple to join with us. Just click this one, yeah, registration link, yeah, osowsd.net, and you can click memberships, and they have a link how to join and become a members. So then you will, yeah, you will need to write down your name and email, and after that you need to verify your emails. And so please verify your email, otherwise you cannot be a member. So last but not least, we have the secretariat. We have the office in ITS Research Center building in 10th floor, And if you have any questions, or if you have any issue regarding your membership, or try to register but you cannot find how to do that, you just send email to this email address, or just send WhatsApp here. And also we have two kind of social media through Instagram and also Facebook. So I think this is the end of my presentation. So I will come in of you if you have any question regarding this organization. Thank you so much.
Okay, thank you very much. Please give applause for Dr. Fatmawati. Okay, so for the female scientists here, so please join so you can have opportunity to have extensive network, and also you can collaborate with scientists all over Indonesia. So if you have any questions for Dr. Fatmawati, please raise your hand. Any questions? Dr. Kartika, you seems like to ask question? No? Okay, so maybe I will ask questions.
Okay.
Okay, so about the, you mentioned before in the slide about the OS award. Can you please explain more about that?
Yeah. Actually, for contribution, we have three kind of program through the OS head chapter. We have OS award, we have OS fellowship, and we have OS what's it like a workshop, yeah, short program. Well, unfortunately for OS award, Indonesia is not, yeah, is not belong to the yeah, it's not included anymore, because actually I myself received this award in 2016, and one of my colleagues also received in 2017 and 2018. I think she was the last awardee for this award, because since then 2019 they remove Indonesia from the lagging countries. Yeah, we are not lagging countries. So for award, unfortunately we cannot apply for that anymore. But we still have the fellowship, yeah, fellowship and other program, yeah, and we can collaborate with others Indonesia, no sorry, with others national chapters, yeah. I mean, for OS itself, now we have more than 6,000 members around the world, yeah. And we have the national chapter totally 51 countries. Can you imagine how big the network of us? And I think that's the opportunity, yeah, for the OS itself, because in 2000, maybe next year we will be, we will have anniversary for 20 years of OS, yeah. So I think that's all.
Thank you very much for the answer. Any more question? I will give opportunity from the people here first. Okay, while waiting for that, any more questions from here? Dr. Laili, maybe? No? Bu Nurlina? No? Okay. Let's move on to the Zoom questions. Okay, let me deliver it. Can other chemistry subject becomes a member? Maybe such as veterinary or agriculture
veterinary and
subject.
agriculture subject. Yeah, absolutely, of course. Right now, we have, as I mentioned before, we have 195. That's active member in the website. Actually, we have more than that. And from the we have diverse subject, not only chemistry. Yeah, we have the biologist, we have the medical doctor, we have engineer, we have also social scientists, we have agriculture, and also was it agriculture and also veterinary. We also have those kind of subjects. So please, all of you who have the background in social science and also in applied science and basic science or engineering fields, yeah, try to register, and then after you register, please try to verify the email, and after that they will give, you know, like not selection but identification about your subject, because if your subject is not related with the STEM, as you can see that before, that we basically in basic science, applied science, engineering, yeah, STEM, yeah, STEM, science and technology, education, and etc. So yeah, you can apply
So,
as a member.
yeah, thank you very
thank
much.
you for the question.
Yeah, thank you very much, Aulia. I think you can be happy now. You can join. So
Yeah,
no
please, yes.
problem.
Yeah.
Okay, I think enough for this presentation. Thank you very much, Dr. Fatmawati, for the interesting presentation. So please give applause to
Yeah,
Dr.
thank you.
Fatmawati. Okay. The next presentation will be the Indonesian Chemical Society, that will be presented by Dr. Muhammad Zaki as the Secretary of the Indonesian Chemical Society. He will deliver online. So is everything ready? Let me check first. Assalamualaikum, Dr. Zaki. Okay, while waiting for everything to get ready, don't forget we still have one more event that we are waiting for. That is the awarding for the best presenter. So the presenters today, I think you are hoping perhaps you will be selected. What is the award? Like, is it only certificate or there's something like a gift or? Okay, so the pride, yeah. Okay, so you will be so proud of yourself, yeah, because you get recognized by many people in this occasion. Okay, is everything ready? Dr. Zaki, can you hear me?
Yeah, very well.
Okay, thank you very much. So ladies and gentlemen, please welcome Dr. Muhammad Zaki.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to express my gratitude to be here, and then thank you very much to the committee for international seminar on chemistry, Isoc 2022. And then at the moment, we will share about legal organization in Indonesia, covering for the chemical society, namely is Indonesian Chemical Society. And then okay, yeah, a little bit about the history of our organization. More than 2,300 chemists, including a student, a chemist, and professional from Indonesia. And then it will be legal organization with we held on the non-profit organization, and then it covering for many activity related to the chemical activity in Indonesia. This organization, a little bit for the structure of organization, yeah, we for organization we adopt collegial system for the structure. After supervisory board, we have three presidents, and then on this year Professor Hamdiah Fansuri is the president, current president, that supported by past president and elected president. And then beside the executive, normal executive board consists of the secretary and then yeah, treasurer. We also support by five fields that concerning on the specific or particular aspect regarding scientific development, ethic, and chemical governance, and human resource development, educational development and teaching, cooperation, communication, marketing, community outreach. And then we also support by a branch of Indonesian Chemical Society because we actually have 26 20, 26 branch of the Indonesian Chemical Society, and then it belong to the province or yeah, belong to the province on the Indonesia. We also have a science division regarding for the chemical aspect, like physical division, physical chemistry division, analytical division, and then organic and inorganic division, and also educational division. One division is special. We also concerning on the network of the security and chemical safety. We also concerning on that because this aspect that important to be improved regarding support and supporting the chemical activity. And then a little bit inform you about the membership. They have advantage if all be member in the Indonesian Chemical Society. One is we design our the member card related to the like tip class from particular bank, so we can have a multi-function card. And then another advantage is the discount for participate to the specific conference sponsored by Indonesian Chemical Society. We also it is also to have a chance to promote the profile or the member, and also not only the member, institution also can be promoted by if you the membership of this organization. And then it's also possible to share grant for the research and other aspect. And also the important thing is the network that connecting food for the national and international chemists, and access for the journal in the uh, Indonesian Chemical Society. And then so to inform you how procedure for the registration, it's quite easy. You can visit the our website in hki.org.id, and then you create a new account, and then we will send for the account to your email. And then this continuing by uh, registration, because you may see here they have a creating account, and then we send by email to your email. And then once you get the username and the password, you may log in to the official website of Indonesian Chemical Society, and then choose the membership and registration. Uh, this will information about um, term of the membership. You might for 1 year or 2 years, and then it continuing following the procedure. They have uh, how kind of the membership that you want, not only for the general membership in chemistry, but they have specific for the division. Yeah, so this is possible to the division. And then once is for check art, and then confirming, and then for and in the end of this step, for submitting the order, we will send to you the uh, virtual account that it will be account for bank transfer. And then once you transfer for the membership price, we will send you a temporary card, and then sending you the original or official card, member card at that case. And then we will deliver in the post, and then to your address. And then this is shortly. I'm sorry, I'm prepared it well, but I hope it can yeah inform you, and then can attract you to join to Indonesian Chemical Society. I think that's it. Thank you very much.
Nyala dua-duanya. Kenapa padahal sudah nyala belakangnya?
Thank you very much, Dr. Hamzaki, for the interesting presentation. So, any questions for Dr.
To pass the questions. Okay, before others' question, I would like to ask if we have a membership, but it's already expired. Also, how we reactive our membership. So, should we start from the beginning or how? Thank you.
Okay. Regarding to the expert for membership, yeah, we now still in the process to reviewing the procedure, but so far the step is to the initial step. But you don't need to create account because the account is already set by our system. So you just continuing to yeah expand the membership by clearing the subscription 1 year or 2 year, and then following the step like the registration for the new member. But this is different because you already have account, so it will be easy.
Thank you very much. Is there any other questions?
Or is it enough? No more?
No more?
Okay.
Okay.
So before we close this presentation, I would remind you, please join this membership. You can apply the membership because, as already mentioned, you will have a lot of advantages. Not only about the network, but the research as well. So please, after this, you can straight away request the membership. Okay, thank you very much, Dr. Muhammad Zaki. Please
Okay.
give applause for Dr. Muhammad Zaki.
Okay, thank you very much.
Okay, we will move on to the next session. Okay, so now we are moving on to the part that we are waiting for, which is the awarding for the best presenter. Okay, let me check. I have got the message for the best presenter. And oh, there are two presenters. Yeah. And it's not like the first and the second, but okay, they are in the same, in the same level, yeah? So, it means that when I mention the first, it's not like the second one, it's the least, yeah? Okay, so the first best presenter is Nurmala Maulidia. Okay, please, you can come forward. And the second is Afdal Junaidi. Okay, please, you can move forward. And we would like to invite our head of department to deliver the certificate for our best presenters today. Okay, please give applause for Nurmala Maulidia. Okay, thank you very much. Okay, please give applause to Afdal Junaidi for his great presentation. Can you please take picture like together with the Vice of Chairman, please? Thank you very much for the best presenter and Professor Freddy and also Dr. Trianda. Okay, now we are at the end of the sessions and it will be closed by the closing speech and Dr. Trianda Gunawan will deliver the speech. Please welcome Dr. Trianda Gunawan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Alhamdulillah, we have just finished our train of speakers in Isoc 2022. For the summary, this event is participated by 118 participants from across more than 5 countries, and this is the first time that Isoc is conducted in hybrid format, which is include both offline and online performance. So in these 2 days we already talked a lot about some chemists that contribute to the sustainable development goals, from the medicinal chemistry, educational chemistry, environmental chemistry, and the others. Hopefully, from these seminars, we can create a new network among us, so we could improve our collaborative research, improving our own productivity, and contributing to the society. And I would like to thanks to all of you who are still here by this time, this late time, and from the face I can see that all of you are tired, actually. And I would like to thanks to our department head for coming, and also the management, secretary department, Bu Yulie, Bu Nikmah, and the others seniors lecturers from our department, as well as our colleagues, our invited speakers, our keynotes, our committee. And I'm here representing Prof. Joko Hartanto as the chairman of the Isoc 2022. Would like to apologize for any inconvenience that happened during the events, and I would like also to make some announcement regarding the publication. So the publication for EGTech, we will wait for up to 2 weeks from today. So for the next 2 weeks, we will still accepting your full paper in IGTech. How about the IP as well? So the IP also apply the same rules, because if your IGTech paper is hopefully not, but being rejected, it might be transferred into IEP. While for the others, like in Indonesian Journal of Chemistry and Hayati or MGFAS, since they are conducting a normal submission, the committee will just send the abstract to them, and they will rapidly choose which among those papers, those abstracts are inside their scope. So we will inform you if, okay, if they have, this is can be published in our journal. So we will inform you that kind of information from Hayati, EJC, and MGFAS. Actually, MGFAS, you just submit it directly. So maybe that I would like to some information regarding the paper. And last but not least, I would like to thanks to our super team, our Isoc super team, who are spend sleepless nights to prepare all of this, so this can be happen, to design the book program, to arrange the schedule, to build the photo drop, photo booths, and the others. And I would like to invite them to come here with me. So the first is coming from our newly added lectures, our newly college, which is with our Dr. Zeni Rahmawati. So please give applause. So Dr. Zeni Rahmawati is are responsible for the international exposure. That's why we have a lot of guest speakers invited from the West. And the second is the Gracianto PhD, or Pak Gracianto. Please come in front here. So Pak Gracianto is the one who responsible for all of the seminar kits, goodie bags, and the others. And the third one is Bu Kartika. Bu Kartika is the one who are responsible the sponsorship, that so all of this can happen. And the fourth one is Pak Hamdan Dwi Rizky for setting up this studio. This is not studio, this hall. And the last one is the army, from our student. They are the true MVP of these events, because without them, I don't think the Isoc can be held like this. So I would like to invite our dearest students who are spending a lot of tireless night, sleepless night, that they cannot even feel the dreams because they are not sleeping. So I would like to call the Irma to come here with me. And the next is Alvin, Arif, Rivaldi, and Juna. So, but I would like to clarify first, Juna winning the award, but that's not my responsible, because the one who are conducting the mark evaluation is not me. I already said, please do not make our student wins. But he also, yeah, the fact is that he scored high, so yeah, he deserves it to win. But it's not because of my influence. Yeah, so that is to take note. So this is these are the MVPs of these seminars, and thanks a lot, guys, for helping us to make this happen. And I think there will be a great candidate for the next seminar, for leading the next seminar. Okay, maybe that's all from me, more or less. I would like to apologize if I, as a deputy or secretary that is representing the chairman of the Isoc, made some mistake, or is there any inconvenience regarding the foods, regarding our service and the others. I would like to truly apologize, and if you have some feedback, please send it to us so we can make it as an evaluation for the future event. So that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, so before we close this event, please can we have a picture together, like all of us? Yeah, all of us. The rest of participants and us, like the last one. Is that okay? Okay, please. Would you please move forward to take pictures together?